web dev. In this video, we will try to have a brief introduction about the files in the Node.js. How the files will be handled in the Node.js, we need to understand it. So now let's try to see that Node.js, we need to understand how the file handling will be done in the Node.js. So normally before this video, we have learned about the buffer concept. So that is why we have learned about the buffer concept. What is this buffer? Buffer is nothing but storing the binary data. So if you try to see any video file or audio file or any image or anything, so this consists of a binary data only. So that means whatever the file you are trying to copy or if you are trying to read it, so you will be able to read the binary data. So that means the binary data means you will be getting the data in return as a buffer. So that is one concept you need to understand. So if you try to open the Chrome and if you try to see the file concept in the Node.js, let's try to open and we'll try to see it. I will try to open here and here I'll be opening the Node.js. Okay. If you go to the documentation for this one, so let's go to the documentation and here in the docs, so we will be able to see the file system. Okay. So this is our file system. And if you try to see here, let's go into between this down. So here it is saying that it will be interacting with the file system in a way in the POSIX functions. We'll try to see about this POSIX function. So now let's see that I will try to show you a simple file, what will be the output of this one. So here what I will be trying to do is I will be creating a new folder, new directory, and here I will be keeping it as a files. So we'll try to write some code regarding this files concept, and in these files I will create a new file that is nothing but app.js. Okay, and let's say that we will be having a small file that is nothing but text.txt. So here I will be writing it as an hello world. So this is our simple thing which I will be writing. In the text.txt file we will be having an hello world, and in the app.js let's import the fs, and it should be require of fs module. So we need to import the fs module. So this is our code. So now, so what I would be trying to do it is, so now here let's try to read the file text.txt file. So now I will be doing constant contents, file content. I need to read the file. So that is nothing but fs.read file sync. So I will be using the sync here. So I will try to explain you after this some couple of minutes. So let's try to read the file, and here it will be taking two parameters. First one is the path. Here the path I will be having is the text.txt file. So keep it like this only, and the encoding type which you will be having. So here you will be able to see the vast variety of encoding types. So right now we know that the code is in the UTF-8. So if you try to open the text.txt and if you observe at the bottom, you will be able to see that it is in the UTF-8 format. So that's why I have written it as an UTF-8. Fine. So we got the contents. Let's try to console.log of contents and we'll try to see. So what will be the data in this one. Now if I go into our command prompt, okay, and here if I try to see node app.js file, what is happening here? Module not found app.js file. So what I have did it here, read file sync, fine, and I am here. Okay, so I need to go to the files, and here I need to write node app.js file. So now see here you will be able to see a hello world. So why we are able to see an hello world? Let's try to see it. Okay, so we have mentioned this one as UTF-8, right? If I try to hover here, you will be able to see. So the encoding, so it is already, and if encoding is specified means then this function returns a string, otherwise it returns a buffer. So I will be not using the encoding, so that's why it is encoding and it is giving you the data. So we will just write the text.txt file and let's try to see the contents. And here if I try to run this node app.js, we'll be able to see the buffer. And this buffer, you know that each one is a 1 byte. 1 byte means 8 bits. So 48, 65, 60, 60, this is all that is nothing but hello world. And the second and the third and fourth is double L, right? So here you will be able to see in the output also the third and fourth are one and the same. So that means it is an LL, the hexadecimal representation of the binary data. So it is something like 0011 and 1100, something like that it will be having. But instead of mentioning it is a binary data, it is representing in an hexadecimal format. So if you want to see means you can open the calculator or something like that and you can check the hexadecimal representation of this UTF-8 of the alphabet. You can able to see, and you will be able to see this 6C. So now we are able to see the buffer. So that's why we have learned about the buffer concept. So we'll learn more about this buffer concept and all those things while going on into these files, just in order to understand. So fine, now we understood that whatever the file we are trying to read it, it will be read as a buffer. So here you will be able to see. So this one returns a buffer. The contents returns a buffer. That is the main thing. Contents returns a buffer, and that buffer. So we can play with the buffer whatever you want it. Now when you are trying to read the file or something like that, Node.js supports 3 types. Okay, let's open the Notepad++. So Node.js supports 3 types of accessing the files. So the first one is promise based. Okay, so you will be writing the promised based accessing of the file, and the next one is callback based, and the last one is the synchronous based. So here which one we need to take, so which methodology we need to implement in order to access the files in the Node.js. So if you want to ask me means that, then I would rather suggest you maximum whenever you are trying to access the files or something like that in the Node.js. So I will be suggesting you to use the promise based only. So promise based will be somewhat easier to implement and all those things. And if you want to have a performance, so in the Node.js documentation itself they have written that if you want to have a performance thing and all those things, then we need to implement a callback. So callback has a little bit edge over the promise based thing, so it has some performance thing, and the Node.js documentation itself has written about this. Callback has an performance is more rather than compared to the promised base. And the synchronous means, so here what I can say it is, so this way, this is as much as possible you should avoid using this synchronous. So there will be a situations in a such a way that we will be using the synchronous type of API also, but I would be suggesting you to avoid as much as possible with this synchronous API. So most of the things I would suggest you to use the promised base. So just I will try to show you how we can implement these 3 things. So just I will try to show you an example. Constant fs is equal to require of, so here I will be writing node fs/promises. So here I can write it something like this. So that means I will be using the promised based only. So here I can write something like async. Okay, and here this one is a function, and this one is a self function. Okay, and here I will be writing constant contents is equal to await fs dot copy file. So here I would be trying to do the copy file. Okay, so copy file, what I can see, so text.txt. so you will be having the text.txt, so it should copy into the destination file, that is nothing but copy hyphen promise.txt file. So this is the thing which you need to do it, and here I can write try, and if any errors comes or something like that means, then you can use the catch of e and you can do the console.log of e. Okay, and if I try to show you the output for this one, so let's go here and I will try to do node app.js file. So done. So here you will be able to see copy hyphen promise.txt has been copied, and here in this one also you will be able to see an output also. So for example, let's say that I would be trying to do access a file which doesn't exist, so then you will be able to catch the error. So you will be able to see the error code as ENVOENT, and it is telling that no such file or directory is present. So this is one way of accessing the promised base. Okay, so I would be trying to do the promised base. So now what I would be trying to do it is, so now here this is I would be keeping it as a comment. So callback based thing, so constant fs is equal to require of fs, and here constant contents is equal to fs dot copy file. So I can use it directly like this, and here I can write text.txt, and here copy hyphen callback dot txt, and you will be having an error. So if any error occurs, so you need to write it as in third argument. and console.log of e. That's it. Sorry, error. That's it. Finish. So this is one way how you will be writing the code. So now here, if you try to implement this one, callback error. What happened to this one? fs.copy file. So let's try to see the output for this. So if I try to run this one, so here automatically you will be able to see the copy hyphen callback has been created. So you will be able to see this one also. The last one which I would be trying to tell you is the copy file sync. So here constant contents is equal to fs dot copy file sync, and you can write something like this one, copy hyphen callback, and this mode will not have, and this one you can say it as an copy hyphen sync. That's it. So this is also one way which you can use it. So now here if I try to run it, identifier already has been declared. Okay, so here contents sync, I will try to use it so that we can able to run it again. So here you'll be able to see the copy hyphen sync also has been created. So these are the different ways. So one is we have implemented using the promises, and which we are, the second one is using the callback, and the last one is the synchronous. So these are the three different ways how we can achieve the same thing in the Node.js. If you try to observe the documentation also, if you open this documentation also, the accessing of these files, so you will be able to see the first one is the promise API. Okay, so here this is all the promise API, and if you come down, so these are all the methods, and the callback API, the same thing you can write, these all the methods are existing in the callback API, and the last one which you will be able to see is the synchronous API. So this synchronous API also you will be able to have it. So these are the three ways how you can access the file, or how you can access the file in the Node.js using the synchronous, using the callback, and also using the promises. So that is what I want to explain you. So I have shown you a simple example. So in the next video we will try to do a simple application or a simple demo how we can access the files and all those things. We'll try to see it. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will try to create a simple project or a simple demo, how the files we can able to access and what we can do it with in the Node.js. Let's try to see. So for this one, I am trying to create an empty project here. In the files only, I will create something like we will try to see here new directory. Okay, so just a demo. So in this demo, I will create a new file that is nothing but app.js. Let's assume. So this is the app.js file which I would be trying to create it. And here what I would be trying to do it is file. So here I will create a new file, another file that is nothing but command.txt. So here I would be trying to give the commands, so that based on those commands, the app.js will be trying to do it. So here I have created two files. One is app.js and command.txt file. So this file command.txt file will be monitored for changes, and app.js, this will contain the Node.js code. So fine. The objective of the project. So what is this, the project, and what is the objective of this one? The goal is to watch this command.txt file. So the Node.js project or the Node.js application, the goal is to watch the command.txt file for any modification. So whenever a change is detected in the command.txt, the program will read the file and execute the commands specified by the user. So the focus now in this video, the focus is on how to detect the change events. So how we can able to know that whenever the file is changed, how the Node.js can able to know that the file has been changed and needs to read the content in the command.txt. Let's try to see. So watching a file in the Node.js. So if you try to observe in our Chrome, if I open this Chrome, and here we can able to see, I will try to search for watch. So here you will be able to see, so fs promises.watch. Okay, so it has been added in from the Node.js version 15.9.0, and this one is fs promises.watch. And what does this one will do? So this returns an async iterator that watches for changes, that watches for file changes on the file name, where file name is either a file or a directory. So whenever for a particular file name any changes happens, it watches for the changes, and it returns an async iterator. So fine. So the Nodejs documentation provides examples on how to watch the files. So here you will be able to see. So I will try to do a simple example for this one. So let's try to do it. So we will be using fs.promises.watch. So here you will be able to see. So it is used to monitor a file or directory for changes. First of all, we will import this one. So we will import the fs module. So that is nothing but constant fs, sorry, not this one. This is command.txt app.js file. Constant fs is equal to require of fs/promises. So we are importing the promises. So now we have imported the promises. The next step what we need to do, so we will create an immediately invoked function expression, that is nothing but IAFE, to allow using the async await. So for this one what I will try to do it is async, and here I will try to do it and immediately invoke function. So we will be calling it immediately. So now we are creating it. Now here what I would be trying to do it is one is, so here I will be creating a watcher, constant watcher is equal to, sorry, here I can use fs.watch off and I will try to give a //. So now this one will return an async iterator. Okay, fs.watch. So this watcher returns an async iterator. So here you will be able to see async iterable. So now async iterators allow handling data that arrives asynchronously. So by using for await off, we can continuously listen for the events. So that is the reason what we can do it is, so here you can use for await. Okay, so this continuously listen for the event. So constant event of watcher. So each event you will be able to get it, and here I can do console.log of event. That's it. So now let's try to see the output for this one. So if I go into here and in these files, if I try to go to the cd demo, and here I will try to do node app.js file. So now it is listening for the changes. So now as soon as listening for the changes, here I will try to write some data and I will click on save. So immediately if I try to open here, you will be able to see a change has been happened. Okay, a change has been happened. Change, rename has been happened. So here if I try to save it, so here you will be able to see a rename, change like this. It has been happened. Okay. So what this means, so this loop will continuously listen for changes in the watch directory. So if you try to see here, this loop will continually listen for the changes. So now testing the file. So now here whenever you are running the script using node app.js, it keeps on running. So editing command.txt in the editor won't trigger an event immediately. The event only fires when the file is saved. So on saving, so you will be able to see that event type like this, change and all those things. So now here if you want to create a new file, so here you can create a new file in the demo. So here I will be creating a new file, new file.txt. So if I try to create it here, immediately you will be able to see if new file.txt has been created. So now if you, whenever you delete this file, so if I try to delete this file, so I am deleting this file. So if I try to delete this file, immediately an event has been fired, rename like this. So now that means a rename event will occur whenever the file is created, deleted or renamed. The change event will occur whenever the file content is been modified. So now what we will be trying to do here, so since our project will only focus on the change event in the command.txt, so we can filter it in a such a way that, so here you can write it if the event type, okay, is equal to change, and also the ampersand event dot file name is equal to command dot txt. So then only we will be consoling the event. So that means I will be watching only the command.txt file only. Now if I try to run this node app.js, so let's remove this one, node app.js file. So now whenever I try to change this command file, okay, so then the change event is occurring. So here you will be able to see the duplicate changes. I will try to explain you over this one. So now here deleting or renaming files does nothing. Modifying and saving command.txt, then only you will be able to see the file has been changed. So now you'll be able to see sometimes multiple events are logging on a single save. So the possible reasons for this one is the operating system behavior. Some systems trigger multiple events per save, or otherwise the text editor behavior also. So VS Code or WebStorm or anything whichever you are trying to use it, so may save in multiple steps. So that's it. So workarounds for this one is check the file modification time to verify actual changes, implementing debouncing, ignoring the duplicate events within a short time window. We'll try to see about this one all. So instead of watching the entire directory here, so what we are trying to do here, we are watching the entire directory. Instead of watching this entire directory, so we can directly write the command.txt here, directly command.txt, so that there is no need for us to write this extra condition. So automatically we are watching the command.txt file only. So this is the another way which we can do it. Now if I try to stop it, and if I try to run this one, okay, now if I try to change it, so here you will be able to see the change events. We are able to see the for the command. So this eliminates the need for checking the file name. So now, so that's it guys. So now we are able to check the changes. So whenever we are modifying the file here, so we are able to see that events are getting filed here. So the events are getting filed. So the script watches the command.txt for changes. On modification, it logs the file was changed, something like that, the event type and all the things you'll be able to see. So now the app is now ready to read and process the file content. So now next step what we'll try to do is, so we'll try to read the contents of the command.txt upon the change, and we will try to interpret the command and execute the appropriate action to this one. So in the next video, we'll try to implement we'll try to write the commands, and using that commands, the Node.js needs to execute those commands. We'll try to see it. So hope you understood about this file watching. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So we have seen about the watching of the file changes. So fine, let's move on to the furthermore. So now what I want to do, I want to read this file. Okay, let's say that here I'll be having some text in such a way that I'll be having a my command or anything. So here we'll be having a simple text, and I want to read the file content. So first of all, let's try to understand, before reading the file, what you need to do, you first need to open it. So when you open a file, the system does not load the entire file into the memory. Instead, it gives you a file descriptor. So that is nothing but a unique number that represents the opening file. So how we can open this one? Let's try to see in our Chrome. If I try to open here Node.js files, okay. So here in our file system, let's go to the promises class file handle, and in this file handle, what we need to do? So file handle, okay, we know about this one. So here, whenever you are trying to play with the file handle means, so you will be able to get a file descriptor. This file descriptor is nothing but a unique number which has been given when you try to open a file. So this file handler you will be able to create it with the promises.open method. Okay, the file handle is not closed using the file handle.close method. It will try to automatically close the file descriptor and emit a process warning, helping to prevent the memory leak. So that means whenever you open a file, if you need to close the file using this file handle. So that's the thing. So now let's try to see what we can do it. So here create read streams. We'll try to learn about the streams concept also after completion of this one. Write stream, these all the things is not needed. So reading a file. Okay, so directly we are reading a file. So directly if you are having a file means, so you are having a file handle, you need to read the file. So but we need to get the file handle, right? So first of all we need to get the file handle. So how we can get the file handle? That is nothing but we will be having a open method. So let's try to see this open method. Dot open promises dot open. Yeah, here you'll be able to see open. So what you are trying to do, so this one will open the file, opens a file handle, and you will be able to get the file handle. So let's try to open the file handle. So let's try to open this one. Let's go to the here. So now here we are trying to change whenever a change is happened or something like that. So whenever, so whatever the thing it may be. So now here I will be trying to open the file. Let's try to open the file. Let's see this one. So here I will be opening here. So let's try to the constant command file handler. So I will be creating it like this. File handler is equal to, so what I will be trying to do, I need to create the file handler. So here let's try to see the Node.js document. So we will go through the Node.js document only. So here this returns a promise. So this returns a promise means what we need to do here. So I need to use the await fs.open. So this open, and here I need to use the file name, that is nothing but command.txt file. That's it. So now we have opened the file handler. Let's try to see console.log of command file handler. So what is the data it might give it to you. So let's try to open this one. So now here if I try to move it, node app.js file. So if I try to give it here, so now if I try to change the file here, let's try to go it here and let's try to see it. So this is the file handle which you are able to get it. So it's a unique descriptor and all those things, so there is no need to worry. So we got the file handle. Okay, so this is how we will be opening the file in the Node.js. Now here what we need to do, so when we open this file, by default we need to provide a second argument also. So in which mode we need to enter. If you try to here hover this open file, so here you will be able to see, so here you will be able to see the path we have given, and the flag also we need to provide it. So the flag means nothing but what is the version. So here let's go into this one and we'll try to see the flags. So here if you try to see the flag, default is read mode. So you will be having different read modes here. So file system flags, so you will be having append mode, a plus space. So these things we will try to learn it, read mode like this. So right now we are trying to read the file, right? So here you can give it as in read mode. That's it. So now here R means the read only mode, and here we are able to get the file handle object. So this allows us to read, write or get information about the file. So fine, it's finished. So now let's try to read the file. So how we can read the file? So the reading of file is nothing but what we can do it is, so we can add in such a way that here let's go into this one. Okay, I will try to remove this event so that we can able to see it. So here constant content, okay, is equal to, and here I can do something like reading of the file. So we need to get a file handle. Let's try to see. So we need to read the file dot read. So here you will be able to see read file instead of having this read file. Read, where is this? Yeah. So here you will be able, fs.read. Oh sorry, file handle dot read. Yeah, here we got the file handle dot read. So we are having two different ways of something like that which we can do it, buffer and also the options. So fine. So let's try to get this one. So what I would be trying to do it is, so let's try to get this one. So here what I would be trying to do this one is, so let's try to where is this file handle dot read, create read stream, these all the things are there. Yeah, read. So here we are having buffer, offset, length and position. So let's try to read this one. So if I go into here, await, and what is this one is returning. So let's try to see the return type of this one is also a promise. So here I am doing the await fs dot read, not fs dot read. So here we got the command file handler dot read. So here we are reading the file. So now we got the content. Let's try to console.log of content. Sorry, console.log of content. So here we are doing the content. I am removing this console. So now if I try to see the output for this one, let's try to see the output for this one. Okay, here we are having it, and let's try to refresh this page, and if you see here, so here we are able to see the data. Okay, here we are able to see the data, but here we are seeing that 16,334 bytes we are able to get it. By default, if you try to understand, whenever we are trying to read it, by default the buffer is too large. It is around 16,000 bytes it will try to give you, which is inefficient if the file is small. So right now we are having a file is small, and we are able to see this, all the buffer memory location has been assigned by the computer, by the RAM, and we are able to see that lot of memory is getting wasted by our file is very small only. So what we can do it is, so we need to allocate an exact buffer size. So that is the reason here you will be able to see the content for this one. So the buffer and all those things you can able to send it. So now allocating a buffer, exact buffer size, instead of using this large buffer, so which you are able to see by default, this one is allocating for us a large buffer. So instead of this one, so we already learned the buffers concept in our video. Instead of using a large buffer, we allocate a buffer of just the correct file size. For example, let's say that this is our command and here I am using a high. So that means we are having 3 letters. Okay, 3 words, three letters only we are having. So by default, each one is an 1 byte. Okay, so that means it is 8 bits. So if you try to see here, so you'll be able to see H, I and this one. So only 3 letters the buffer has been occupied. Remaining all 16,000 bytes is everything is wasted. So we should not waste the memory like this. Instead of using the large buffer, we allocate how much buffer we need it by using the right size. So how we can do it? So in order to know this one, so we need to know the file size, the file meta size of this data. So for this one, so you will be having a method that is nothing but .stat. Okay, .stat. So this one will return you the complete file status. Okay, so here if you try to see, this one will return you the complete file status. So let's try to see this one. So here I will be using app.js and here we are having a read, and here I can use something like constant file stats is equal to, and this one is also in promise fi file handler, sorry, command file handler dot stat. That's it. Now let's try to see the output for this one. So console.log of file stats. So if you try to check the file stats for this, so let's try to see this file stats for this one. Let's see here. Here if I try to open the Nodejs, so let me try to save it and let's try to see. So here you'll be able to see the file stats, and here we have a file that is nothing but size. So we are having 2 letters, that's why the size is 2, so 2 bytes. So we can use this type. So now we get the file size in bytes. So what can I do here? So here I can use something like constant size is equal to file stats dot dot size. So now we have got the size. Now we need to create a buffer. Constant buffer is equal to, so we are creating a buffer dot allocate. So we are allocating the memory, and the memory we need to provide it, that is nothing but the size. So the 2 bytes of memory we need. So whatever the file size we are having, we are trying to create it, and here we can directly give the file size to this one. So now here the stats provides the file metadata like size, last modified date, etc. It will try to give you, and buffer dot alloc, whatever the allocation we are trying to do, it creates a buffer of the exact file size. So now we need to read the data for the correct position. So now here I need to use the buff. So that's it, finish. Now let's try to see the output for this one. If I try to show you the output for this one, let's try to save it, and here if you try to see, so bytes read is 3 and buffer we are able to get the correct buffer. Okay, so now if I try to change it again, so here also we are able to get the correct buffer, and if I try to read it like this, so now here you will be able to get the correct buffer. So now here if I try to show, so here also you will be able to get the correct buffer. So fine. So now we also have an extra things, that is nothing but here from where to read it. So read buffer. So we also have in such a way that let's try to go to our column, and here we will try to see dot read of not this one, where this one is gone, yeah, file handle dot read. Let's try to click on this. Let's try to click on this one. Yeah, so we are having an offset, length, and also a position. So offset is 0, and the position we need to read it from the 0, and the length is total buffer. So we can also provide it like this in order to avoid the buffer reading thing. So here offset is 0, and the total size is that is nothing but the size. Okay, and the last one is the position 0. So now you will be able to get correctly exactly from starting onwards. It will try to read it. So here without any problem it will try to read it. So here it is able to read the buffer. So now the data is always read from the start of the file. The buffer is fully utilized. So this is how we can read the exact file by using this buffer concept. So at last, whenever your concept is finished and all those things, what you need to do it is you need to close the file handle. So command file handler dot close. So you need to use the close concept. So in order to close this one, so this is how we are doing it. So key takeaways in this one is, so you need to understand, opening a file gives you a file descriptor. The first one, opening a file gives you a file descriptor. Reading a file requires allocating the right buffer size, and the dot stat size will give you the metadata of this file size. That means nothing but the file size when it has been modified, everything. And the dot read method requires correct offset, length and position. Always close the file to prevent the memory leaks. So that's it about this one. So how we can read the file in the Node.js. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, I will describe the process for handling the file reading in Node.js efficiently using an event-driven approach with the event emitter class. Normally, all the people, if you try to see in our Node.js, we have a concept called as an event emitter. So if you don't have understood about this one, so normally, so we can have an event emitter class. That event emitter will try to, you can emit an event and you can listen to that event, and you can off the event, and you can only once you can event, and you can remove the event. Like this, we'll be having an event listener. So I hope that everyone know about this event. When you are trying to work in the browser JavaScript also, you'll be able to listen. You are able to understand about this event listener thing. So here is a breakdown what is happening for this one. Let's try to understand. Let's go to the file system, so which we are trying to learn it. Fine. So now what I want to do it is, I want to clean up this code. Okay. So if you try to see this one all, so here I have written in this if condition the everything, right? I want to clean up this code and replace some lines with the so here to improve the clarity. So now here, if I try to understand here, so for the first one is we are trying to get the file size, okay, and we are allocating the buffer to store the file data, and we are determining where to start the buffer, okay. So determining where to start reading the file, specify how many bytes to read, ensure that entire files are read. So that is the main thing. So now we'll try to use the event emitter for cleaner code. Normally, if you try to check the file handle, so here if you try to check this file handle, okay, if I try to open this one, so here you'll be able to see that all file handle objects are event emitters. So that means I can able to use these events classes in this one. So normally this file handle object or in the Node.js inherits from the event emitter, meaning that we can listen for and emit custom events. Instead of manually handling changes every time a file is read, and we can decide to emit an event, change event, when the file contents change, handle this event with a separate function, making the code modular and also the cleaner way. So let's try to see this one, the event. So here what I can do it is, so the event system normally works as follows. When a change occurs in the file, the event is emitted, and a listener function responds to the event and process the file content. So now let's try to see. So for example, let's say that here I will be having an event emitter. Okay, let's try to write an event emitter for this one. So here we are having the command event filer, right? So for this one, what I can do it is, so this one entire thing, instead of writing in the for loop, I can move this one to the what I can say it is to here. Okay, so I can use it at the top. So fine. So this is our code. Now what I want to do it is in this one, sorry, here what I can do it is, here let's say that command file handler dot on. So I am trying to listen to this change event, and here this is the method which I want to do it. So here what I can do it is, I can copy this entire code. Okay, so here there is no need to close it, this one. So here I can copy this entire code, and here I can do this one, and here I can write it as an async. Okay, and here what I can do, so here if event type is equal to change means then I want to emit an event. So here I can write it as command file handler dot emit of change of event. That's it. So now here just we have written a simple code in a such a way that, so here we have written this file handler and we have written it like this. So now now let's try to see whether we can able to execute this code or not. So if I try to check this code, let's go in here into this one. So here I will try to show you the exact code. Okay, I am opening, I am making this one as bigger. Fine, let's try to stop this one, and here let's try to make it bigger so that you can able to see it clearly. So here I am doing node.app.js file. So now if I try to save this file again, you will be able to see the same thing. So here the byte rate is 50 and the buffer we are able to read it. So here we are able to get the 2 times because of the operating system or something like that. The multiple events is firing. That purely depends on the operating system or the editor which is trying to do it. So multiple saves it is trying to do it. So let's leave it. We'll try to handle that one also in the upcoming thing. So now this makes the code more organized and also the reusable. So now decoding the file data. If you want to see here, the file contents are stored as a raw binary data. So now normally the file content which you are getting, it will be stored in a raw binary data. Not only here, when we tomorrow, so upcoming videos when you are trying to learn about the TCP, the network data when it is flowing, so this all the data will be transferred using the binary, raw binary data, only zeros and ones, and this is the buffer is the only thing which we will be able to handle the case. So now zero raw binary data, if you are means you need to use the buffer, that's the only thing. So now you are having a buffer here. So now this command file handler dot read, automatically it will fill the buffer. So that's why there is no need for us this variable. So that why, because automatically this buffer has been filled, so we can make use of this buffer. So now you know about the buffer and all those things. So now what you can do here, so let's try to console.log of buffer. So let's try to check the buffer, what is the data you are trying to have it. Now if I try to remove this one and if I try to do it node.app.js, and here if I remove these 2 files and if I try to show you the output for this one, so here you will be able to see the same buffer, you are able to get it, the same output which you are able to see it, the same thing, the buffer is getting filled here and we are able to see the same buffer. Okay, so now when you are having a buffer means, so now we need to convert this into human readable text. So the data must be decoded. So here the buffer contains the encoded data. The default encoder is nothing but UTF-8 which I have shown you. So now we need to decode it. So normally the decoder takes the raw data like zeros and ones and converts it into a meaningful text. Here the buffer is containing the raw data, that is nothing but zeros and ones, which you are able to see it in a hexadecimal format. This is all hexadecimal format. So this one is having 4 bits and this one is having 4 bits. Total of 8 bits, that is nothing but 1 byte. So if you try to convert this 48 hexadecimal into a binary data, you will be able to get the binary value. So 8-digit binary value. So that is nothing but UTF-8. So now it will take this raw data like zeros and ones and convert it into a meaningful text. Now we have a decoded data. Now if you want to encode the data means we need to have an encoder. So the encoder does the opposite. That is nothing but turns the text into a raw data. So that's why the encoder, it has been encoded. So decoder takes the raw data and converts it into a human readable format, whereas an encoder takes the opposite. So takes the text or something human readable format and it converts into a raw data, that is nothing but binary data, zeros and 1. So Node supports character encoders and decoders like UTF-8 natively. So if you want to decode the images or videos or something like that means, then we need to use the third-party libraries. So that is a different case. So now decoding the buffer in the Nodejs. So here we can remove the unnecessary code related to the saving the promises. So now here what you can do it is, so here if you want to convert it, you can use the .to string of. So if you want, you can mention UTF-8. By default it is UTF-8 only. So if you don't mention it, it will by default it will take it as an UTF-8. Now if I try to see this node app.js and in the command.txt, if I save this one and if I try to show you, see here the same content we are able to see this one from the buffer. So that is the main thing. So now in the next step what we will try to handle is, now the contents we are able to see that has been decoded and also the encoded and also the decoded. So now what we need to do it is, the next step is to interpret the user command. So whatever the user writing the commands here, we need to interpret, and the goal of our this demo is to check the command. So if he asks us to create a file means we need to create a file, delete a file means we need to delete a file, append data to a file, and perform other related file related operations. We'll try to see it. So in the next step of the project, we'll try to implement it. So now by end of this video, what I want to tell you is now the code is now cleaner and also more modular. We have used the event emitter, which makes the file handling process event driven, and we have made use of the buffers and decoders ensure that the file data is processed correctly. And the next step what we need to do it is we need to interpret and execute the file related commands based on the content. So that's it guys about this concept. So hope you understood about this one. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to see how to implement a create file command in the Node.js. So let's try to see it. Now what we are trying to do it is, so we are having this command.txt file, right? So we are having this command.txt file. So here the program, whatever the program we are trying to write it, the program reads the command, whatever the command we are writing in this text file. So it reads a command from the text file and it needs to execute it. So the command will be in the format in such a way that create a file, and I will be mentioning the text.txt file. So now here you are having a command create a file and you need to mention the file name or path. So it can be absolute path or anything. So absolute path means something like /user/Leela/document. So wherever you are having, whether depending on the operating system, so you can mention it. Now right now, so I am using it like this only. Now let's try to see it. So we'll try to see that the program first, what we need to do, let's go to the program. The program first needs to check if the command contains the phrase create a file. If the command contains the phrase create a file means, how we can check that one? So we can check it using the include method. So here we know that we are getting the buffer.toString. So this is the content of the file which we are trying to get it. If I show you node app.js file, okay. So here, whatever the thing you are trying to write it here. So if I check it here, so we are able to see create a file text.txt. So we are able to get the information here. So that means this buffer has the file content. So let's try to take it as a constant content is equal to, so this is the buffer. Okay. Now what I would be trying to do, so let's say that this is the command. So whatever the command we are getting, this is the command. Now we need to check that if command dot includes, if the command has the text create a file. So we can check it like this. So this is normal JavaScript method, string method. So here it is there means, so I will add a method, I will create a method create file, and I will try to send the path. So for sending the path, here what we need to do, so constant file path is equal to command dot substring. So I will be using the substring. So here the substring I will be using it. So here first we need to provide the command length. So that is nothing but the file length. So command dot length. So you will be having one space, right? So I can use it as +1. That's it. So we will be able to get the file path. So let's try to console.log file path and see whether we are able to get the file name or not. Console.log of file path. So now if I go here into this one, and if I refresh this page and if I click on this one, let's see. So here I will be adding it like this, and let's see here we are not getting anything. So create a file test.txt, and here we are not getting the file. Let's see here what is it we are trying to do. Command dot length, this is the file path, and here we are getting the command. Let's try to check the command. So console.log of command. So this is the command which we are trying to check it. Here we are getting the command dot something like this, we are doing it. Okay, let's try to stop this one, and here node app.js file. So let's go to the command here, and I will do it like this, and here we are able to see create a file. Okay, so something, so create a file, save it, create a file test.txt, we are able to get it. Now here we are trying to check it, create a file if the command includes or not. So now if it is includes means, then we should be able to get it. So here what I can do, If the phrase is found means we need to extract the file. So we are trying to do, okay, command dot length, it's the wrong, right? So now we will get an empty only. Command dot length plus 1 means you will get empty only. So what I can do here, so I can use something like create a file. So this one needs to be excluded, dot length plus 1. Okay, so now what we can do, we are repeating this one 2 times, right? So what I can do it is, so here at the top I can use constant create underscore file. I can use it as an create a file. So I have mentioned it like this. Now let's go to here, and what I can do it is, so here I can use it directly. Create underscore file, and here also I will use create underscore file dot length plus 1. So these are the 2 things which we can do. Now let's try to see the same output. So hopefully now we will be able to get it. Node app.js. So if I click on this one, and if I go here and if I give save something like this, now here we are able to get the text.txt file. Fine. So now we got the file path. Okay. Now what I would be trying to do it is, so now here what I would be trying to do this one is, so let's try to use create file. Okay, so create file. I am using the method create file, and at the top what I would be trying to do here, I will be having let's say here only I will try to keep it constant create file, constant create file is equal to async of, and here you will be having async like this. So in this async, what I will be trying to do here, we will be getting the file path. Okay, so we got the file path, and here we need to send the file path. So like this, so we have sent the file path, and here also we are having the same thing. So let's try to see why it is missing await function. Okay, so let's try to do the async, and here await, and here we can say it is an async. So fine. So we got the file path. So now we have checked this all we have extracted the correct file path. Now we need to create the function we have creating. Now let's try to see here. So we got the file path. First of all, let's try to see whether we have this file already or not. Try for checking whether the file is existing or not means, so just you can check it existing file path. Let's try to see existing file path. Existing file path is equal to, so here I will open the file using fs command dot open. So we know that, right? Existing file, we can also say it as an handle. So we'll get the handle, right? Existing file handle. Now we will be having the open, and what is that one? File path. So we'll open with file path, and I will try to open in read mode. So if the file is existing means, then it will open, or otherwise it will go into the catch block. Okay. So now existing file handle, let's try it, we will having. So if it is there means, what I can do here, I can say that console.log the file. So here you can say the file with path, you can say the file path, so here we can write already exists. So already exists we can tell it, and here we need to close the file handle. So existing file handle dot close. So we need to use, as this one is an async, so we need to use the await. That's it, finish. So now here, so now if the file is existing means, we are telling that the file is existing. If it goes to the catch block means, that means the file doesn't exist, we need to create it. So here we can create the file constant new file handle is equal to await fs dot open, and here I will try to open the file path, and this time I will try to open with a write mode, so that if the file doesn't exist, it will create it. So here I can say that console.log a new file is created or was successfully created. So now here I can close the again await new file handle dot close. So I can close this one. That's it. So now we are able to successfully create a file. Now if I go into here, we are successfully created a file. So let's try to stop this one and we'll try to run it again. So this is our command.txt, and here I will try to do txt like this and I will save it, or otherwise so I try to give a space or something like that. Now if I try to go here, if I go here, if a new file is successfully created, now we should be able to get here, right? Yeah, here you will be able to see the test.txt has been successfully created. So here it has been made. Again, let's try to save this one. So here it should be created. So maybe we need to refresh the page, I think. How can I refresh this one? Let's try to close it and reopen it again. Let's try to see here. Create a new file. A new file was successfully created. So here, so tested. Oh, sorry. Yeah, here it has been created. So with space and without space it has been created. So just you will be able to see that test.txt has been created. So now what this function does for this one, app.js, if you try to see this create file, so it checks if the file already exists by attempting to open that file in a read mode. If the file exists means so a login error message and exists. If the file does not exist means it throws an error caught in the catch block. In the catch block, what we are trying to do, it creates the file in the write mode. So last one, what we are trying to do, we are using the close method is used to close the file handle after opening. So now, so if the what we are trying to handle the different scenarios are, if the command specifies a file in the current working directory, the file is created. If the command specify absolute var means the file is created anywhere in the system. So by using this one, we can create it anywhere. So this is all about how to create a file. The command we have seen it. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will explore how to delete the files using Node.js, and also you will understand the difference between different functions available for the file deletion. Let's try to see. So the first one, if you try to see how to delete a file, let's try to see it in our Chrome. Let's open the Node.js documentation. So if you try to open the Node.js documentation in the docs and also in the file system. So let's try to open the file system. So here we want to delete a file. So let's try to search for delete. If you try to delete a file, here you will be able to see a method called as an unlink. Okay. So now let's try to go to another delete thing also. Let's try to see it. Yeah. Here you will be able to see fs promises.unlink of path. So this is the method which we will be using. The first method which is using for deleting files in Node.js is by using the unlink function, and the two from fs promises. So this function, what it will try to do, it removes a file from the file system. So what are the steps it will try to do? If you check the Node.js documentation, searching, so now if you search for the delete thing in the Node.js documentation, it redirects to the fs promises.unlink, okay, which is used to delete the files. So now here, if you try to read this one, a symbolic link, okay, if path refers to a symbolic link, then the link is removed without affecting the file or directory to which that file link refers. So here the symbolic link refers to an alias. So something like it is a shortcut that refers to an original file. So whenever you are having in the Windows or in the Mac, you will be able to create an alias file in the Mac, or otherwise in the Windows you will be able to see you will be creating a shortcut file. So the shortcut file is originally it's not a file, okay. So it originally it's not a file, it's just a copy that refers to the original file. So if unlink is done for the symbolic link, only the symbolic link is deleted but not the original file. So it is trying to tell about this symbolic thing. So now here if you try to see here, see the POSIX documentation for more detail it is saying. So what is this POSIX? POSIX means Portable Operating System Interface. It is a standard for the OS compatibility. So now for example, let's say that if you implement this unlinked directory in the Node.js, if it may work in one operating system and it may not work in another operating system if you take the same code. But whereas if you follow the POSIX standards, so these are the standards which need to be followed by all the operating system if you want to work on the file operating systems, file systems. So functions like unlink are available in multiple operating systems following the POSIX standard. So that is the main thing. So this makes the development easier, as code written on macOS can work on other POSIX compatible OSs also. So that is the thing. So let's try to use this unlink in the Node.js. So let's try to use this one. So now for example, let's say that if you go to our WebStorm, so here we need to delete a file, right? So let's try to create a command. So here constant delete underscore file is equal to delete a file. So I'll be writing like this. So the same code here I can write in such a way that if command dot includes delete a file, so then what I need to do, first I need to get the file path, okay, which to file relate. So the same thing, command dot substring of delete file length plus 1, and here I will write await delete file of file path. So I will send the file path also. So now here let's go here and I will create a method that is nothing but constant delete file, okay, which takes async, and so this is a method, and here you will be able to get the file path, okay, and here let's try to console.log of file path, okay. So I will try to write the code, then afterwards I will try to explain you what is the thing happening. So here if you try to write, so let's go into our Node.js, and here I will node app.js, I am running the code, and here I will write delete a file test.txt. When I save this file, automatically you will be able to see that delete a file test.txt, it has been, so you will be able to see delete a file text.txt. This is the total command, and here you will be able to see the console test.txt. So now we are able to get the path also for this one. So fine, we got the path. So here we can use the unlink method to delete it. So here I can write it in try, okay, and here I can use await fs.unlink, and here I can give the file path. That's it. So now next what I can do it is console.log console.log file deleted successfully. This is the thing, and here you will be having a catch error. So here you can write it. Let's try to see console.log unable to delete file, okay, or otherwise you'll try to do error message. So fine, so now we are able to get this one. So let's try to see the code for this. So let's try to remove this one, node app.js, and here you will be having a space, you will try to give it, and here you will be able to see delete a file test.txt, no such file or something like that. So for example, if I remove this space and if I try to go it, so here delete a file deleted successfully, you'll be able to, but here we are able to see some error message, right? So if this one is there, means no such file or directory, okay. So we can take this one, and here I can write a code in such a way that if e dot code is equal to like this is there, means then I can do that console.log no file to remove in this path. So something like this we can write it, and if else is there, means so here you will be having some error, console.log an error occurred while removing the file, and if you want you can add the error. That's it. So now this is how you will be adding. So here you can add the e also. So this is how you will be adding the thing. So now here if the file doesn't exist, unlink throws an error. So we have wrapped the function with it inside try catch, which helps handling the errors properly. The error is checked using the error.code is equal to envoent to confirm that the file is missing. So now while we're running the node app.js and testing the function confirms that it deletes the file. If the file is already deleted, means the script logs that no file to remove in this path instead of throwing an error. So that is the thing which I have implemented. Apart from this unlink, so now unlink is working fine. Apart from this unlink, there is also another function available in the Node.js, that is nothing but rm. If you try to open here, so you will be able to see .rm, okay. So rm, yeah, here you will be able to see this rm asynchronously removes the files and directories. So model with POSIX standard only, no arguments other than a possible exception are given with a complete. So here, first of all, you need to understand that the difference between unlink and an RM. So unlink only deletes a single file. So if you want to delete multiple files means, then you need to use the RM. So it also deletes a single file, but unlink deletes only a single file. So unlink doesn't delete the multiple files, whereas RM deletes the multiple files. So now unlink also, not only that one, it doesn't delete a directory, whereas RM deletes the directories also. Non-empty directories, unlink doesn't do it. So the directories itself it will not delete, whereas RM it will delete the directories with options. So RM function is modeled after the standard Unix RM command. It allows removing single or multiple files, deleting empty and non-empty directories. So now you can also use this one, but you should be very much careful while using this thing. Why? Because if you try to use RM and -rf, so force and with a recursive means, the entire thing will be deleted in your operating system. So running the RM with -rf, especially with the root permissions, means can delete the entire system. So you should be very cautious while using this recursive deletion. So now if you try to use it means, so it will ultimately delete everything. So we have another function that is nothing but remove directory. The remove directory function only deletes the empty directories. It cannot delete the directories that have files inside them. So that is one thing you need to understand. So if the directory contains files, the function will fail. To remove non-empty directories, we need to use the RM instead. So that is the main thing. So at the summary, what I want to tell you is, so if you want to delete a single file means, then we should use the unlink. Okay. So it deletes a single file. So RM, if you are trying to use it means, then you are really trying to delete multiple files, directories, empty or non-empty, whatever the things are present. So entire thing. So you have a great power. So you RM directory. So better be cautious while we are using this RM directory. RM method. RM dir. This method deletes empty directories only. So unlink is summary. What I can say is unlink is the safest, but only works for single files. RM is powerful, but it should be used very carefully. RM dir is limited to empty directories. So that's it, guys, about this deleting a file. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about how to rename the file. So in previous video, we have successfully seen how to delete the file. So in this video, we will try to see how to rename the file. So for this one, so what I will try to do it is, so here I will create another constant that is nothing but rename file. So that is nothing but rename a file. Fine. Let's go here and I will write the if condition. If command dot includes rename file, if it is there means, then what we need to do, so we need to get the two things. For renaming a file, we need to get old file name and also the new file name. What is the thing? So here I can write a command in such a way that rename a file test.txt to copy or new test.txt. So this is the command which I would be trying to write it in this file. So I need to read this one and I need to show. So here I can show here I can say in such a way that constant old file, what I can say is this, in this one, old file index. So let's try to get the index, where the index will be. So that is nothing but, okay, we can get the file index something like this. So here I can say in such a way that command dot include, sorry, index of. So this is the command which I would be trying to do it. Yeah. So here you try to see, this is the two commands. So with the space and all those things, I am trying to get it up to here index. So that means I will get index up to here. Okay. Now I need to extract this file, old file name. So here how to extract that one? So let's see. Constant old file path is equal to command dot substring of. So here command dot length, not this one. Rename file dot length, okay, plus 1. So that is nothing but, so up to here. Okay, so from here to here I need to get it. So that means index. So the index starts from here only, right? So here I can get it something like file index. Okay, so fine, this is also done. Now I need to get the new file path also. Constant new file path is equal to, so here also I need to get the substring command dot substring of. So here I would be trying to do rename file path. So here this time we should not get the rename file path. So here I need to get the file index and I need to count plus value. So here how many values we are having? 1, 2, 3, 4. 4 values we are having plus 4. I will try to give plus 4. So if you try to see here, so 1, 2, 3, 4 up to here, and here you will be having this one. So now here I will be having the plus 4. So we got the old file path and also the new file path. So now I can send it to the await rename file, and here I can write old file path and also the new file path. So this is the method which I would be trying to do it. So now let's go to the Node.js. Okay, and here we need to search for the rename. So dot rename, let's try to check whether we have a dot rename method. So here you will be able to see fs promises dot rename, and this takes only 2 arguments, that is nothing but old path and also a new path. So now this returns a promise, so that means it should be await. So just it's a simple method which has a rename method, that is nothing but old path and also a new path. Okay, let's try to use this one. So we have a rename. So here I would be having create file is there, delete file is there, and here we'll be having another method that is nothing but rename file, which is an async, and here you will be getting the old file path, and another one is the new file path. And in this one, so what I can do it is, so we should rename it, right? Old file path and also new file path, we should rename it. So how we can rename it? So you can use the try, and here you can use the catch. Okay, and here I can write in such a way that await fs dot rename, fs dot rename old file path comma new file path. That's it. And here you can write console.log renamed file. So now here okay, we can keep it like this, and here you can have if error.code is equal to like this, then you can add a console.log no file to remove in this path, or otherwise else means, so you can have a console.log an error occurred while removing this path. So that's it. So now we have used this one. So let's try to test it. Here I will go here into this one, so node app.js, and if you try to see here, first one, the file doesn't exist. So first you'll try to create a file test.txt. So when I save it, automatically a file will be created. So here you'll be able to see the file also, test.txt has been created. Now I want to rename a file test.txt to new test.txt. That's it. So when I save it, automatically here you will be able to see rename a file test.txt to new test, renamed file test. And if you try to check it here, so the file has been changed to new test here. So this is how we will be renaming the file in the Node.js. So we have used the command rename a file. So this is nothing but rename file, and we have extracted that old file path and also new file path, and we just pass it to the Node.js file system. So that's it guys about this renaming a file. So the last final one which we will try to work on this file operations is adding a content to a file. So by this we can close this all file system content in the Node.js. We will move on to the next topic, that is nothing but streams concept in the Node.js. How to handle the streams and all those things I will try to explain you. So that's it guys about this. Hope you understood about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will try to do concept that is nothing but adding the content to the file. So up to now we have created a file, renamed the file, deleted the file, but we need to add the contents to a file. So how we can do it? So now normally the adding the content to a file means nothing but appending to a file in a Node.js. So when appending to a file, we want to add a new content at the end of an existing file while keeping its original content intact only. However, if we attempt to write the file without specifying the right flag, it will overwrite the file's existing content instead of appending. So let's try to see. So now by default writing a file in Node.js means we will be using fs.write file will replace its existing content. So if you try to use this fs.write file, so fs.write file, so this one automatically overrides the existing content. Okay, however Node.js provides various flags to control this behavior, like write mode by default overrides the file completely, and append mode adds a new content at the end of the file. To append data we must use the a when opening the file. So fine, so let's try to implement this concept. So here let's go at the bottom. So here we will be having so here I will be having a constant add file. Okay, so here add a file. Here I will be writing if, so the command will be in such a way that add a file test.txt with content hello world. So this is the thing. So now here the file name is this one and the content is this one. So we need to extract this file name and also the content from this text. So first of all, let's try to get the text. We know the text, and here we will try to do includes add underscore file. Okay, so first we need to get the index. Constant file index is equal to command dot index of. So here, so I want to get index of this one with content. Okay, so this is the space which I want to have. So let's try to go here and I will paste it this one. So let's remove these two spaces. Yeah, I got the index. So constant file path. So we need to get the file path. So that is easy. Command dot substring of. So here add underscore file. Sorry, add underscore file dot length plus 1, and I need to get the index. So that is nothing but file index. Okay. So now here up to file index. So here up to here it will get, you got the file path. Now I want to get the content also. So content is equal to command dot substring. Here what we need to do, so file index plus 15. So we need to add the 15 characters. Why? Because this total content is having 15 characters. So here we will be getting the content. So here if I try to do console.log of content, and also I will try to do console.log of file path. So I will try to use this one. And if you go to the Node.js, so here I will try to run the node app.js, and here in the command I will try to add it like this. So here if you try to see the output for this one, see here the content is hello world and the text is, and the file name is test.txt. So we are able to get this one. So here I can write the method in such a way that, so we will be writing the method. So that is nothing but await add content, let's say, or otherwise add to file. So here you will be having the content, and also the last one is the file path or otherwise file name, whichever it may be. So let's go here. So delete file, these are all the things we have written, rename file, and here the last one we will having the constant add to file. Okay, add to file, it is an async, and here you will be having the content, and also you will be having the file path. Okay, so in this one, so we got the content. So first one what we can do, it is constant file handle is equal to, so I will open the file in an A mode. Okay, so for example W mode, let's try to open in a W mode. Now what I need to do, so I need to write the content. So here I can write await file handle dot write. So we will be having the buffer of the content. So here I will be writing the content. That's it. So we can add this one in a try catch mode. So try, and also we can add a catch mode. So here you can have console.log error in writing the content. So just I have added like this. So fine. So now let's go to our here, and I'm adding node app.js file. Let's go to the here and I will remove this hello world. So let's try to see whether we can able to write it or not. So add a file to the content, we are able to see it. If I open this text.txt file, so here we are able to see hello world has been written. Now in the command which I would be trying to do, hello world, and here, so hello world should be there, and good morning. So I have written something like good morning. Let's check this text.txt. So it has been updated to good morning. So hello world, the old content which we are having, it has been removed. So what we need to do here, so instead of having this app.js, so instead of what we have did it here, so we open this one in a write mode. So write mode means every time when you are trying to open a file, so automatically the file, the content, everything will be removed. So the fresh content will be added. So instead of writing the first fresh content, so we need to append, we need to keep the existing content like that only, and we need to append the new content to that one. So what we can do it is, so we need to open this one in an append mode. So now if you try to check the same output for this one, let's go here, let's stop it, and here I will try to do it. So let's go here. So we are having this one, and here I will try to write hello world. So now if I go to the text here, so now we are able to see hello world has been added double times. This is because of the our operating system issue or something like that. So the events is firing multiple times because of the save or something like that. It may be the editor issue or operating system issue, something like that. So in order to overcome this issue, what we can do it is, so here I can add something like let added content. So I will add a flag, something like that, so that the content will be added only once. So here I can show in a such a way that if added content is equal to content, okay, then you return immediately, then you can add added content is equal to content. That's it. So now let's go into here. Okay, so I will try to do the node app.js. I will remove this entire code also, so for the first time. So here I will try to do hello world. So if you try to see here, only one time it has been written, and here I can write something like good morning or something like this. Now if you try to see here, so we are able to see the content has been written, appended only once. So this is how we will be adding the content to the thing. So preventing the duplicate writes also we have did it. Sometimes due to file system events, something like that, the same content might get written multiple times. To prevent this, we have defined a global variable added content. Before writing, I am checking that added content is equal to content or not. If it is, means do nothing. So I am just writing it. So that's it. So now we also have an what is the difference between this append mode and also a write mode. So this is one thing you need to understand. If you use write mode instead of the append mode, means the file contents will be replaced. So I have already shown you this replaces the content. If the file originally contains hello world, means after writing the new content, the file will now only contain the new content only, instead of having that, instead of keeping that hello world like that only. So that's why you need to maintain the write flag is very crucial. So apart from this one, we also have an instead of manually opening, so here we are, instead of manually opening the file and writing to a file, Node.js also provides us another handy method, that is nothing but append file, which does both the steps in one call. So instead of having this one all, so afterwards we need to close it, right? So we need to close this file handle.close, like this we need to add it. Instead of having these all the things, automatically it can be taken care. So here you can use await fs.append file, and you need to give first the path, that is nothing but the file path, and last one you need to give the content. That's it. So here this function also does the same thing only what we have did earlier. This function also does the same thing only. First it will open the file, appends the given content, and closes the file automatically. So how does it work internally? fs.append file internally calls the fs.write file, specifying the append mode. Before writing it, it first opens the file and assigns a file descriptor, that is nothing but the file handler, a number in memory representing the opening file. Then it writes to the file. Finally, it closes the file. So even though the API looks simpler, behind the scenes, it is performing the same steps which we are trying to write it. Now, if you see the output for this one, the same output you will be able to achieve the same output only. Okay. So here if I, okay, this is a text.txt, right? So command.txt, if I try to write it, okay, if I open this text.txt, so here you will be able to see the same content has been appended. So that is the main thing. So in the summary, before closing of this one, so now we have successfully implemented the adding of the file. Appending keeps existing content and adds new data at the end. Use append mode to prevent overwriting. Use fs.open plus write for manual control. We can use the fs.append file for a simpler approach. Be careful of the duplicate writes and prevent them if necessary. So like this, we have used it, right? Here is this one, append added content like this one. So that's it guys about this one. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So we have successfully completed the files concept. Now I hope that you are very much comfortable with the file system, handling the files in the Node.js. Now what we need to do it is the next concept which we need to learn it in our Node.js is the streams concept. So what is this streams? So this is one of the crucial and also one of the important concept in the Node.js. So the streams is the concept which has made Node.js more popular today. So that is the reason we need to learn the streams. So let's try to understand about the streams concept. So I will try to give you an overview of this one. So in the upcoming videos, please try to follow with me so that the concept is so much crucial and also little bit harder also to understand. So if you understand once the streams concept, so whatever it may be the programming language, so it will be easy for you to understand the logic and all those things. So this is one of the important concept. So please bear with me and without skipping the video, so try to understand. So if you want to become a serious developer, so understanding the Node.js streams, a deep dive. Streams are one of the most important concept in the Node.js. Not only in the Node.js, any programming language, if you are dealing with the backend, means streams are one of the most important concept in the Node.js. In fact, Node.js wouldn't be as popular as it is today without its efficient stream handling. So that is the main thing which I was supposed to tell you, that Node.js now it is so much popular today is because of the streams, so efficient handling of the streams. As a Node.js developer, truly understanding streams is crucial for building high performance, memory efficient applications. So this one you need to understand it clearly. So if you want to become a serious Node.js developer, means you must truly understand the streams concept. It is very much crucial for building the high performance and memory efficient applications. We will try to see these all what is meant by high performance and memory efficient applications and all those things in our upcoming videos. So don't skip the videos and follow the things so that you can have a clear understanding about the streams concept. So the next point which I would be trying to tell you is, why do streams seems hard to understand? Okay. So all the developers and all the things, so if you try to contact everyone, so they find streams will be a little bit hard to understand. Many developers find streams as a confusing concept. So that is the main thing. They read multiple tutorials but still feel like they don't fully grasp the concept. So now also if you try to me also, when you try to learn different articles and different ways, it seems to me that I am able to understand the streams, but sometimes I may be feeling that I don't fully understand the concept. So that is the main thing. However, streams are not necessarily difficult. They just require a solid foundation in the Node.js. That's it. With the right approach and enough time, anyone can master them. So that's why you need to keep so much of efforts in order to understand the streams concept. That is what I want to explain it to you. So however, streams are not necessarily difficult. They just require a solid foundation in the Node.js. With the right approach and enough time, anyone can master them. So that is the thing. So now let's try to understand here. So our approach to learning the streams. So what is our approach in learning the stream? Instead of just briefly covering the streams and showing a few examples, so this guide aims to provide a deep and thorough understanding. So whatever the guide I am providing you in these upcoming videos, I will provide a deep and thorough understanding about this one. By the end, you will be able to use streams confidently in your applications. So that's what my goal is. So that whatever the things I know, so I cannot tell that what I was telling is correct. Whatever the concept I know, I will try to explain you the streams confidently so that you can able to use your applications without any problem. So this learning journey will take some time, but it is worth it. Let's outline what we will cover. Okay, so the things what we are trying to learn, it will be somewhat little bit boring, but it's truly what I was saying is what I was trying to say it is, if you want to become a serious developer, or if you want to do it means, so this is worth learning. So that is what I can explain. I can tell you one thing. So please bear with me and try to learn the streams concept. So why I am telling you repeatedly again and again is, So these concepts is a dry concepts. Okay, so the concepts will be looking little bit of new to the things, but surely if you want to if you learn this one, the logic and the programming building, whatever the programming language you are, so this programming language will not be a barrier for you. The foundation concepts which you are trying to learn it, these are the basic foundations for any programming language. So that is the main thing. So what we will learn, first one is we will try to learn about the writable streams. So that is one thing what I would be trying to tell you is, first concept which we will be using is the writable streams. So how to use the writable streams, and we will see the next one is the implementing of the writable streams. So how we can use the writable streams and how we can implement the writable streams. And the next one is, so the concept which you need to understand is the writable streams. So first one is the writable streams. What is this writable streams? How to use these writable streams and implement your own writable streams. Implementing writable streams. Okay. So the next one which we will be having is the readable streams. So these are all the different types of streams which we'll be having. First one is the writable streams. The second one is readable streams. So how to use it, using of this one, and also how to implement. So implementing, so existing readable streams, how to use it, and how to implement your own readable streams. So these are the two things which I want to tell you. So the next one what I want to tell you is, after mastering the readable streams and writable streams, so what we will try to do it is duplex and transform streams. So we have another concept that is nothing but duplex and transform, duplex stream and also the transform stream. So totally we are having 4 types of streams. One is readable stream, writable stream, duplex stream, and also transform stream. So after mastering these readable streams and writable streams, we will explore the duplex streams. These are the streams that are both readable and writable. That is the combination of both readable stream and also writable stream. And we have a transform streams where while we are passing the data, we can modify the data and we can pass it. So that means nothing but an encryption and decryption we can do it. Those are called as transform streams. So if you don't know about these terms and all the things, don't worry about these all things. We will cover them in detail. So now and afterwards, after learning about this, what are these duplex streams and transform streams, so then we will learn another concept that is nothing but developing and using our duplex streams. Since a duplex stream is both readable and also writable, understanding readable and writable streams first will make this easier. So we will then afterwards we will create a duplex stream and we will use the duplex stream we created. So that is the thing. And after completion of this duplex stream, we will develop and use the transform streams. A transform stream takes input data, modifies it, and outputs the transformed data. So we will create a transform stream and use our transform stream. So that is the thing. So and we will cover with an encryption and decryption example. So with the transform stream, to understand the transform streams better, we will build an encryption and decryption system. This involves working with raw binary data like zeros and ones. So you should be familiar with these all things. And we will encrypt a file, decrypt the file back to its original state. So that is the transform string. So now in the upcoming videos, we will be writing a lot of code and we will be building the simple applications at each step. The goal is to gradually improve our understanding of streams. So that is the main goal. Some parts of the code may not seem directly related to streams, but they will help us grasp the bigger picture. So this is one thing. So now this will be a long and detailed section, but this stream section will be long and detailed one. But writing code and completing challenges, so you will be able to master the Node.js streams, improve the performance of your application, and you can take your Node.js skills to the next level. So that's it guys about this concept. What I want to tell you is the brief introduction of the streams concept. So let's dive into the code and let's understand about the streams concept. So that's it guys about the streams thing. So different types of streams. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So now in this video, we will try to understand the detailed explanation of writing a data to a file multiple times using the Node.js, and we will analyze its performance. So let's try to do it. So first of all, we need to understand the concept of streams. Before diving into the streams, so now in this video, I will try to write the file multiple times so that we can check the system limits and benchmark code performance of the code which we are trying to write it. So for this one, you need to have a background about the file system and also the buffer concept. So these are all the things we have already covered in our earlier videos. So if you don't have a knowledge on this one, I strongly request you to see those videos so that you can understand about the buffers and the file system. Then you can understand about this one. So now here I have created a new folder, streams, and I will be creating a new file that is nothing but write more.js file. Okay. So here I am using a file write more.js file, and now the program challenge is to write some data to a file, let's say 1 million times. The data could be numbers like 1 to 1 million or any character, for example like A or anything, and we will try to check the benchmarking, the execution time using the console.time. So I have created. Now let's try to go here, constant fs is equal to require of node fs promises. So I will be taking the promises approach only. So now I will be using an immediately invoke function that is nothing but async, and here you will be having it like this, and it is an immediately invoke function, so I can use it like this. So now I will be trying to open the test.txt file, and I open it in a write mode. So that means constant file handle is equal to await fs.open, and you can see the test.txt, and I will try to open it in w mode. So now what I will be trying to do is, for I will try to do let I is equal to 0 and I less than, so let's say that 300,000 times. Okay, so 300,000 times I am taking it, or otherwise 3 lakhs, and here I can take it one I plus plus. So now here I can do await file handle dot write. So I am trying to write the code, so here I can use $i, so I will use a space like this. That's it. So now we have written this all the code. So at the last, what I would be trying to do it is, so if I try to execute this code, what will happen? Let's see. So if I try to execute this code, node app.js file, we went into this one, right? So here if I click on this one, so it is trying to create the file and it is writing so much of time. So it is creating test.txt file and it is writing the 1, 2, 3 up to 300,000. So it is trying to write it. Let's try to see whether it is able to write it or not. So maybe it may take some time depending on the code. So now it has been finished. If I try to open this text.txt file, so it is very big file, and here you will be able to see 0, 1, 2, 3 and so on. If you go down, so it will be able to write let's say that 2,999 something like that. Okay, fine. So we are able to write this code. Fine. So let's try to benchmark the code. So the execution time is measured using the console.time at the start and also console.time end at the end. So now let's try to see it. So here I will be writing console.time, and here I can write more. The same name we need to give it at the bottom. So here we should use it as in time end. I will take it something around 1 lakh so that we can finish it very quickly. So if I try to use node write more, so immediately it needs to be finished. So it is taking too much time. So it has taken around 6.5 seconds for me to complete this one. So if I try to make it as in 200,000, then how much time will it take? Let's try to see. It needs to take double the time, that is nothing but 12 seconds. So let's try to see it. So here the execution time and all those things depends on the variations. So depending on your execution time depends on your CPU model, the background, other programs affecting the performance, temperature might affect, disk speed. So these all the execution time varies. So here let's try to see 12.203. So now let's go to the task manager. Okay, and in this task manager, so I was searching for node, and here I will write node write more.js file. So if I try to write it here, you will be able to see the CPU time it is taking, the CPU memory it is taking around 26-25, it is increasing, and also the memory also it is increasing to 26.5, something like that it is taking. Okay, for example, if I try to give it as an 5 lakhs, okay, 500,000, let's say that how much CPU time it will take. So if I try to run it again, so here let's try to see how much time it is taking. So the CPU is going on increasing 22, 23, and here the memory is also increasing to 18, 18.5, 19, 25, 26, 27. So slowly it is increasing. So I don't know how much it will increase. So it is going on. So the CPU memory it is taking around 25 to 26 it is there, and the memory is going on increasing to 40. It is even going to 50 also, maybe that depends. So let's wait for some time. So how much it will take. So totally it took around 34 seconds. The CPU memory it took around is the what I can say is for this type of code. So here I will try to write it. The execution time it took for 5 lakhs is 34 seconds in my system. So maybe it will be very fast for you because my system is very slow. So it may take 34 seconds, and CPU time and CPU it is taking around 40% it in my system, and the memory also it is taking around 50 MB. Okay, CPU is taking more also, but just I have written it here. So this is the total execution it is trying to take it. So let's try to check it one last time. So here I am using it, and here I am trying to check it. Memory is 13.2 and say 19%, 22, 25, and it is going on increasing the CPU. If you try to observe carefully my system, so I don't know whether you can able to see it or not. So 15 it is going on increasing, something like that. Okay, it is around 25% it is taking, and the memory also it is increasing. So it is around 50 MB. I am thinking, I am hoping so, in order to complete the 5 lakh thing writing. So here it is taking too much time. Let it take. Okay, so that's it guys. So it is taking around 25% of the CPU memory of my system, and it is taking 50 MB, and the time is normally it is taking around 34 to 35, something like that. So you can take it as an average 35 seconds. So this is how you will be taking it initially. So this is all about the thing. So it is around taking 50 MB, and the CPU memory is around something like that. So this is the thing. Okay, so CPU 100, 25% means I am having only 4 cores. So in your, if you are using Mac or something like that, means it may take 100%, but it will use only 1 core. So these are all things. So the method of writing data due to a file 1 million times is resource intensive. So here I am writing 500,000, half a million only. It is resource intensive. Since Node.js is single threaded, it doesn't use all CPU cores. So later streams I will be introducing streams to make the process more efficient. So this is the concept which we have seen using normal file handle. In the next video, we will try to see, instead of applying through the promises, we will achieve the same thing through the callback, and we will try to see whether the execution time, CPU and memory has been increased or decreased. Let's try to see it in the next video. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about this, how we can achieve the same concept using the callback. Why? Because in our previous videos, when we are learning about the file system concept, so I have told you about this concept that there is nothing but what I can say it is. So rather than using the FS promises, callback functions is little bit of what I can say. What I can say it is performance wise it is little bit better, we have discussed. So let's try to achieve the same process using the callbacks thing. So for that one, what I will try to do is, so I will comment out this entire code. Okay, we'll try to achieve the same thing using the callback, and here also I will try to do it, and later on we will work with the streams concept. So first what I would be trying to do here, so let's go here and I will do async. Okay, and the same concept I will do it here, but here I will be requiring constant fs is equal to require of fs. So instead of having the fs promises, I am taking the fs. So now here the same thing. So here what I will be trying to do, this time I will use the same thing, write more. Okay, and I will be trying to use the same thing, console.timeend and write more. Okay, so in between this one we need to write the code. So first one, what we need to do, fs.open. So we need to open the first one is test.txt. Okay, and we need to open it in a write mode. Okay, and here if you try to see this one, so this is not an async await, so that's why we will be not using this async and all those things. So here if you try to see this open thing, at the bottom it is coming. So we need to mention the path, okay, and we will be able to get the callback. So let's try to use the callback thing. Here you will be able to get a callback, okay, and in this callback, so what you will be getting is the first one is the error and the next one is the file descriptor, okay. So we got the error and also the file descriptor. So inside this one we need to write this time end, okay, so that everything comes under this one. So now when the file is opened, then this one will work. So here we need to write it. So first one I will loop over this each one for loop, okay. So here I will loop over each one. So I will remove this one. So here you will not have this thing, and here you will be writing fs dot write, and this write will take two parameters. So that one is, first one is the file descriptor, so that one we got it, file descriptor, okay, and the next one is the content, and here at the end you will be able to get a callback if you want to execute anything, so you can do it. So that's it. So this is all what you will be trying to do it, and here at the end you will call self call this one. So fine. So this is the code which you will be able to achieve the same thing using the callback scenario. So what we have did it, the first step is, so we are consoling the time, and here I am opening the test.txt with the write mode. So if you hover here, you will be able to see here you will be having the path. So path we have mentioned it, the flag, that is nothing but read mode or write mode, and the last one is the callback error, so a callback method, and in this one the first method is error and the last one is the file descriptor. So the same thing, I am getting error in the file descriptor, and I am looping over here, and here you will be able to see the fs.write, and the first one we need to provide is the file descriptor, and the second one we need to provide is the buffer or the string, so whatever it may be. So right now we are giving it as a string, later on we will try to do the buffer thing and the callback thing. So that's it. So let's try to see whether this one will be able to execute. So previously it took around 35 seconds of time, CPU 25% and memory 50 MB, and how much fast this callback will be, let's try to see it. So here I will be doing CLS. So if you are not able to see, so hopefully you are able to see it. Let's try to run the same thing, node app.js file. So what is the error we are getting it? Cannot find streams. What is it? Okay, so it is node write more, right? Okay, so fine, let's try to see. So it took around 2 seconds only. So if you try to observe carefully, it took around 2 seconds of time only, and still it is taking some time to execute. Let it take, but most probably it has finished it very quickly. And let's try to see the performance also. So if I go here and if I try to go to the node, and let's try to check the performance for this one, and here, and if I write it is like this, and the Nodejs, it is taking around 476, 459, 362. So it is taking around 500 MB and 30% of space, 500, 900 MB it has. Okay, this one is edge thing. Okay, so it has taken around node.js. We'll try to see with this node.js. I don't know why here we are having, okay, cursor. So here it is taking too much. Yeah, now I have removed this Microsoft Edge also. So now in the Node.js, so this is the node which is trying to take it, and now here this right now the Node.js JavaScript environment is in empty. Okay, now let's try to see, let's try to run it again, how much memory it is taking. One final thing, one final try, we'll try to do it. And here if I try to run, so node.exe has been started, 256, 435, 500, it has gone around 500, 600 MB it has been gone. So 600 MB, and it is taking again one time. Let's try to see it. It is going around 600 MB and 40%, around 40% has been taken. So that means the execution time is very speed. Okay, so the execution time is around 2.5 seconds. Okay, using the callback. So the execution time which we have seen it using this one is very speed. That is nothing but let's try to check it once again. 2.9, 2.8, 2.6, around 2.8, let's say average it is around, so let's say the 3 seconds. Okay, and the CPU percentage is taking around 50%, and the memory is huge, it is taking around 500 MB. Okay, so it's taking too much resources, and the execution time, that's why it is able to finish it off very quickly. Now if I try to open this one, the test.txt, so whether the content it is trying to add it correctly or not, let's try to see. if you try to see here, okay, so this is the text, right? So we are able to see the content is getting these are not sorted order. Why? Because here you will be able to see 1552 is there, immediately it is 1549, then 1554, 1495, 1556, 17, 1553 again. So that means the content is not getting in a sorted order. So so here you are able to get sorted order, somewhere it is getting missed. So somewhere you will be able to see, we can able to see here again 62, 72, 67, 76, 75, 79, 80, 78, 82, 83. So it is not getting in a sorted order. So that means the execution time is very speed, but the data it is not writing in the sorted order. So it is writing in the way how whatever it makes, right? So it is writing, but the execution is very speed, but the CPU and the memory it is taking too much time. Let's say that we will use the sync operator. Okay, in order to achieve the same thing, we will try to use the sync operator. Sync operator means it is a synchronous operator. Okay, so now you will not get this type of issue. So like this sorting issue, you will not get it. Let's try to see how much time it will take. So if I try to use the same thing, it is taking around 2.9 seconds. So this one is also taking around 3 seconds only. So if I try to run again, let's see how much time it is taking. So 3 seconds. So marginally. So depending on the thing, so it may be fast in your system. So according to my system and the configuration, so it is taking around 3 seconds. In your system, it may be finished in 1 second only. So so it is not necessary that it should finish in 3 seconds only. So it is taking around 3 to 3.5 seconds. So that means it is taking around 3.5 seconds. So fast only. Let's check the resources, how much resources it is using. So if I try to run it again, so here the resources also 15, 19, and it is getting finished. Whereas that one took too much time. So here CPU also it is taking less only, and everything is less. And if you try to run the test.js file, test.txt file, if you try to see, if I open this one, so this is all in a synchronous order. So if you try to see, this one is everything in a synchronous order. So you will be able to see everything 6123, 24, 25, 26, 27, 28. So randomly if I check it also, so everything is in synchronous order. So that means, so if you are using the write sync, then it is in a synchronous order. So let's say that this one write sync, what is the command it is taking? It will be taking the buffer. Okay, it needs to have a buffer. If you send the string also, it will try to convert into a buffer. So instead of trying that one into a buffer, so let's try to convert ourselves. So here I will try to do constant buffer is equal to buffer dot from off, and I will use $i. Okay, the same buffer we can use it here. So the same buffer we'll use it. So let's see that whether it will take how much time. So it is taking nearly around 3.2 to 3.4, right? Let's see that how much time this will take. So it is taking around 3.44, so a little bit increased. So previously we got it as in 2.9 also, but this one starting only it is going to 3.4, 3.5. So I think it is around 3.4 to 3.5, whereas this one is 3 to 3.5. This one is around 3.5 to 4. So when we are trying to convert the buffer, it is taking too much time. Okay, see, it is going on increasing. So but it is not decreasing. I think maybe 3.5 to 4 it will be. So here 3.6. So that means little bit performance has been degraded when we are trying to convert it into a buffer. Why? Because so here for every time when we are looping over, we are creating a new variable and we are converting it into buffer. For example, let's say that I add this one in the buffer at the top and I will use a fixed value a. So one time only I have converted and I will loop over and I will do this one. Let's see how much time it will take. So it should be below 3. Then only our whatever we are thinking 3.17. So it is good compared to previous one. It is somewhat good. So it may become so it is somewhat good. So but not too much. Okay. So whatever the thing we have expected in the previous time. So now it has gone to 3.9. I don't know. So it is somewhat good. So fine. So now this is how we can check it in the callback. So we have increased the execution speed, but still it is using the CPU of around 50% and memory of 500 MB and something like that. So in the next video, we will try to use the streams to achieve the same concept, and we'll try to see how much we can achieve it. So that's it guys about this callback thing. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hey everyone, welcome back to my channel Leela Web Dev. Today in this video, we will dive deep into optimizing the file writing performance in the Nodejs. In the last video, so what we have seen, we experimented with different ways to write a million lines to a file, starting with promises. Then we have moved back to the callbacks, and also we have used the write sync method also. So when we have used the callback and this write sync method, we have seen a significant speed improvement. Okay, so we have seen significant speed improvement. Like previously it was around 35 seconds, and we have increased that one to 3 seconds. Okay, so but now in this video we will go little bit further. So can we increase the speed for this one? So can we make our code even faster? Can we cut execution time into half? So something like 3 seconds to 1 second, something like that. Maybe even make it as a 10 times faster, something like that. So well, we can make it. The short answer what I want to tell you is yes, but only if we use the streams. Then only we can make this code faster. Without streams, we have pretty much hit the limit. But with streams, that's a whole new level of efficiency. So only with the streams we can able to achieve the faster execution. So we using the file method and this one, so we have reached the pretty much limit, we have reached it. So we cannot make it even further faster. So if you want to make the faster means, then we need to use must and should streams. So how we can change the code into a streams concept? So let's get started. So now we will try to use it streams. So instead of talking about streams right away, let's jump straight into the code and see them in action. Then we will break down into the concept. So to use the streams for writing a million of lines to a file, first of all we need to create a write stream. So let's try to do that one. So that means what I was trying to do it is, so here I will comment out this entire thing. Okay, so this one is using the callback. Let's go back to the promises, which is 35 seconds. So here I want to increase the speed for this one. So now in order to implement the stream for this one, in order to make it execution time faster, first of all we need to create a write stream. So why? Because write stream means we are trying to write the lines into this file. So that's why we need to have a write stream. So let's try to create the write stream for this. So here for creating a write stream, so what I can do it is constant stream is equal to file handle dot. So you will be able to see a create read stream and also a create write stream. So there are two methods available, that is read stream. So when you want to read the content from the file, the second one is the create write stream. So when you want to write the content from the file into the file. So right now we are trying to write the content into the file. So that's why I will create a create write stream. So we have created a stream. Okay. So now what we need to do, we need to write the buffer. So now what I was trying to say, streams come in two different types, but for now just know that we are using a write stream to efficiently write the data to a file. Now to actually write the data, what we need to use is, we need to use the write method. Just like before, our data can be a, just like before, what I want to say is our data can be a buffer or a string. So let's try to use the buffer instead of using the string. Let's try to use the buffer. So that means first of all I will create a buffer. So buffer is equal to buffer dot from, and I will give the content here. Okay, so now I have given the content. So now we got the buffer. So what can you do instead of using the file handle dot write? So directly what I will do it is stream dot write, and we need to give the buffer. That's it. Finish. So we have used this one. So with this setup, we are continuously writing to the file in a much more efficient way than before. Let's try to do the performance comparison. Now let's run this and see the result. The previous best solution it has took it is the 35 seconds and the best solution is 3 seconds. Right? When we are writing the 500,000 or let's say million or something like that, 500,000 we have seen it. With streams the same task completes in about something, we'll try to see. So how much it will try to do it. So let's go here and this is our streams. So let's try to do node write more.js file. If I try to click on this one, see it has took nearly half a second. So that means it is insanely fast. There is an insane boost in the performance. Instead of waiting multiple seconds, our process finishes almost instantly. This is why streams are a game changer in the Node.js. So now if you try to give node write more.js, all the time it is taking 439.575 only. Right? So it is taking less time for us to complete. Almost 1 second or something like that. So you will be able to see. So for writing the data into the file, it is taking so half a millisecond, something like that. But it is almost finishing it very instantly. So within 1 second, half a second, it is completing it. Now let's try to check the memory usage. Okay. So now let's try to see the memory usage, how much the memory is taking. If you open the task manager or activity monitor in the Mac or in the Windows, let's try to see it here. So this is our thing, right? Let's try to see it here. And I am running the node here. So if you try it right here, the memory is taking around 131 MB, right? 131 MB and it is going away. So if I try to make it as an 5 million, let's try to see how much it will take. So if I try to make it as an 5 million, then how much it will take, let's try to see it. So this one is also we need. So if I try to write it here, so now the memory is going on 266, 473, 700, 1 GB, it is going to 948, 1 GB, 1000 MB it is taking nearly. So it is going on increasing. So I don't know. So the 4 seconds it has been completed. Now it is going writing into the code into the file, but it has gone to 1 GB. So that means the memory usage is too much. So when we are having only 500,000, it has taken around 50 MB the previous it has taken. Now it is taking around 150 MB. Right? Let's try to see the CPU usage for this one. So how much CPU usage it is taking, let's try to see. So let's go into here and I will be using like this. So 474 milliseconds, the CPU usage is taking around 20% only. The CPU usage is one and the same only, but the memory what it is taking is too much. And here the thing is decreased to less than 1 second. Okay. So less than 1 second, it has taken to less than 1 second. So that is one thing which you can see it. So now with streams, our memory usage jumped to around 200 MB. If we scale this up to 10 million writes, memory usage explodes to 2 GB, which we have seen it. That's not good, right? So that is not good. So while our code is fast, it is also, you need to consider that it is inefficient in the memory, in terms of memory. So what we can do solving? At this point, we need to be very smart. The way we are using streams, is it quite right? We are using stream, we have increased the execution time, but in terms of memory usage, it is not correct. So we should be handling the back pressure to ensure efficient memory management. But don't worry, in the next video section, what we will try to do it is, we will fix this one and make our solution both super fast and also memory efficient also we will try to do it. So that's it guys about this one. So now that we have seen the power of stream, it's time to really understand how they work. In the next video, we will break down the concept of streams, explain how they manage data efficiently, and implement a proper solution that doesn't waste memory. So now we have seen using the stream, we have increased the execution time to less than 1 second, but the memory it is not efficient. Why? Because we are not handling the back pressure. So I will try to explain you about the back pressure concept in our upcoming videos. What is this back pressure and back pressure handling and all those things. So but we have used the stream concept. And using the stream concept, we are writing the file, we are writing the content into the file. If you try to check the test, so here you will be able to see the code has been written into this one. So that's it guys. If you found this video helpful, don't forget to like, subscribe and hit the notification bell icon so that you will not miss the next part of this video. So these are utmost important in the Node.js. If you want to become a serious developer, so you need to learn about the streams concept. So that's it guys, thanks for watching and I will see you in the next video. So please stay tuned to this channel. Thank you. Hey everyone. So now let's try to see what exactly the streams are. So we have seen how much we have increased the speed for that one when we used the streams concept. So let's try to see. Have you ever wondered how massive amounts of data are transferred so efficiently without clogging up your computer's memory? Whether you are streaming a movie on Netflix, playing an online game, or even just copying a file, there is one powerful concept at work behind the scenes, that is nothing but streams. So this is the main place where we will be using the streams. So now let's try to see it. In this video, we are diving deep into Nodejs streams, what they are, why they matter, and how they make your applications lightning fast while keeping memory usage in check. So let's try to check about the power of streams. In the last video, we used streams for the first time, and boom, we saw a massive reduction in the execution time. It's about milliseconds. It is around milliseconds. From seconds we have decreased it to milliseconds. We also ran into a memory issue. It is taking too much, around 200 MB if we are running only 500,000. If it is going 1 million or 2 million, means it is going around 1 GB 2 GB of memory issue. So that means we are having a memory issue, but there is a massive reduction in the execution time. Before we tackle that, we need to fully understand what streams are and why they are game changers in the Node.js. Fine, we got a memory issue. Let's keep that aside, and we have decreased the execution time. Before handling about this memory issue and the execution time and all those things, first we need to understand what streams are exactly and why they are game changers in the Node.js. Let's try to see this one. So what is the stream? Let's start with the Node.js itself. What it says, what the Node.js document itself says about the streams. Let's try to see. The definition for this one is, a stream is an abstract interface for working with a streaming data in Node.js. That's it. This is the definition what they have given in the Node.js documentation. A stream is an abstract interface for working with streaming data in Node.js. Simple, right? This looks like simple only. Well, maybe not. Let's break it down and let's try to understand what is this definition exactly means. Normally, when you hear streaming, you probably think of Netflix, YouTube, or Twitch. But streams go way beyond just media. Whenever data flows continuously instead of being sent all at once, that is called as a stream. So that is the thing. Whenever the data flows continuously, the data is coming continuously instead of being sent all at once, then it is called as a stream. Think of a stream is like a flowing river water. Water doesn't come as one massive block, it keeps moving in parts. The same applies to the data streaming in Node.js also. We don't load an entire file into memory at once. We send and process it in small chunks. So this is the main thing. We don't load an entire file into memory at once. We send a process into a small chunks. Let's try to see a real world example for this one. Imagine that you are having a graduation party where 1,000 students need to enter a hall. You wouldn't want all 1,000 students rushing in at once. Instead, people enter gradually 5, 10, 20 at a time. This is exactly how data streaming works. Rather than moving an entire file in one big chunk, we break it into smaller chunks and send them bit by bit. So this is the main concept behind the streams. Let's say that you want to copy a 10 GB file from one location to another. There are two ways how to do it. First of all, load the entire file into memory. Here it's RAM. Then write it to a new location. This is one way. This means your RAM is occupied by 10 GB for that entire operation. On a low memory device like mobiles or anything, this could cause a performance issue. So then we can use, or the second way is use a stream to transfer the file in chunks. For example, 16 KB at a time. This keeps memory usage low and efficient, and the speed is almost as fast as the first method only. So whatever the first method the speed is there, the same fast the second method also will have almost equal, but it will be a little bit slow, but the speed will be almost same. So that is the thing. Now let's see that. Now let's put this into a perspective. What if you had just 1 GB of RAM and needed to copy a 500 MB file? If you try loading the whole file at once, you are using half your memory. Not a great idea, right? That's where streams save the day. Let's try to see the streams in Node.js. Node.js loves streams. They are everywhere in the Node.js. File reading or writing. So whenever you want to read or write files, Node uses the streams. Network requests. So your web server reads and writes data using streams only. Video processing. When working with tools like FFmpeg, your process video streams. Data processing pipelines. You can connect multiple streams to process data efficiently. Even when you make an HTTP request, Node.js is using streams behind the scenes. When you send data to a server, it doesn't receive everything at once. It gets streamed in chunks, making the process smooth and memory efficient. That is what. Let's take a quick look at how Node.js streams work internally. When you write to a stream, it does not write immediately. Instead, it collects data in a buffer. So here it collects the data in a buffer. Once it reaches a certain size, the default value is 16 KB in Node.js, only then does it write. This means fewer write operations, better memory management, and blazing fast performance. So that is what about the Node.js, how it will work in the streams, how it will work in the Node.js. Let's take a real world example. Imagine you are building an online video editor using Node.js. Users upload video files and you process them using FFmpeg. Instead of waiting for the entire file to be uploaded, you set up a stream that reads the file in chunks, process it while data is still coming in, writes the final output efficiently. So this is how, this is just one example. There are countless others also. So this is how the Node.js will be very much using the streams everywhere. Almost all the things which you will be coming across the Node.js, they will be using the streams only. So now you know why streams are a big deal in the Node.js. They make data processing faster, smoother, and also more memory efficient. In the next video, what we will try to do is we will go deeper, even deeper into the streams. We will explore the different types of streams in Node.js and their inner workings. We will try to see about this one. I think you are loving this content, the streams content and all those things. So if you are loving this content, means smash that like button, subscribe, and hit the notification bell so that you don't miss what is coming next. See you in the next one about the streams, different types of streams that are available in the Node.js. We'll try to see. That's it, guys. Thank you. Hello everyone, welcome back to my channel Leela Web Dev. Today we are going to dive deep into the streams in the Node.js, and also we are learning about the different types of streams. So we know about this, streams are an essential part of the Node.js for handling large amounts of data efficiently. So now what we need to do, so here we will cover different types of streams, how they work, and their real world applications also. Make sure to watch till the end to understand how to use the streams properly and avoid the memory issues. Let's try to see it. So before coding, I am trying to explain you in detail about this one. So why? Because in the coding you will be able to not understand clearly. So that's why I am going to theoretical part first. So what are streams actually? So let's try to have an overview about this one. Streams allow us to process data piece by piece rather than loading everything into a memory. So this is the main thing. They are useful when working with large files, network requests, or any continuous data flow. Streams are built into Node.js and provide a powerful way to handle the data. So this is all about the thing. And now you need to understand the different types of streams that are available in the Node.js. Let's paste it here, the code. The types of streams in Node.js. There are typically 4 types of streams in Node.js. The first one is the readable streams, which is used to read the data. Example, reading a file or receiving a request. Next one is writable streams, used to write data, example writing to a file or sending a response. And the last one is the duplex stream. Third one is the duplex stream, both readable and writable, example sockets. Transform streams, a special type of duplex stream that modifies the data as it is written or read, example compression or encryption. So these are the 4 different types of streams that are available in the Node.js. First of all, let's try to understand about the readable stream and also the writable stream. So understanding readable and writable stream. Let's consider an example. You have a huge file that is about 10 GB and you want to read it and write it to another file. A readable stream will read from the file in chunks instead of loading the whole file into the memory. A writable stream will write to another file efficiently. This prevents excessive memory usage and improves performance. Another example is handling HTTP requests. Reading from a client's request is done via readable stream. Writing the response back is done via writable stream. Efficient streaming allows handling multiple requests without overwhelming the system. So this is the main thing. And let's try to understand about the duplex stream and also transform streams. Duplex stream and transform streams. Duplex stream are both readable and writable. Example, a network socket where you can send and receive data at the same time. Transform streams modify data while reading and writing. Example, as I have told you, encryption and compression. When encrypting data, you transform it before writing. When compressing data, patterns are detected and stored efficiently to reduce the size. These modifications are done using the transform streams. So let's try to understand how the streams actually will have it. Okay, so let's try to see this one. So internal buffer and high watermark. What is these two things? Let's say that each stream has an internal buffer that temporarily holds the data. The default size for each stream is 16 KB, that is around 16,384 bytes. This is called as a high watermark, controlled by a high watermark. When the buffer fills up, the data is processed in chunks. This improves efficiency because fewer write operations are needed. So that is the main thing. So memory issues and draining mechanism. Let's try to understand this one also. If you write faster than the buffer empties, excessive data is buffered in memory. If too much data is buffered, memory usage increases and performance drops. To prevent this, use the drain event to wait for the buffer to empty before writing more data. This ensures controlled memory usage. For example, let's say that if we write a huge file, example 800 MB at once, memory usage will spike. Instead, we should write in chunks and wait for the buffer to drain. So we have a different types of events and properties and methods for that one. So here we wait for the drain before we writing more data. This avoids excessive memory usage. So that means what I was trying to tell you is, for example, let's say that here, let's say that this is a readable stream, okay, or otherwise let's say the writable stream, okay, writable stream. So this is a writable stream, okay. Now let's try to write it here. This is a writable stream, okay. Let's try to make it bigger, okay. So this one is not making, okay, leave it. So now this is a writable stream, and here in this writable stream what you will have it is, inside this one you will have a, so you, oh sorry, no, not like this, color picker, pencil, brush. So you will have a, here I can do in such a way that this is an internal buffer. So this one is around 16 KB, which we have discussed. So in the writable stream we'll have 16 KB, and this writable stream, this entire writable stream, so you will have the events, properties and also the methods inside this one. So you will be having 3 in the writable stream. So for example, whenever you are getting a data as a stream here, so here you will write the data into this internal buffer using stream.write, which we have seen in our code. And when this buffer is filled, 16 KB of data is filled, means then this one will be written to another file, okay. And this buffer will be emptied. Again another stream of data will come into this one. So in the same scenario you will be having a readable stream also. Readable stream also, a stream of data, you will be getting it from the network card or something like that, and you will read it here something like this, and you can do some process data or something like that. So this is how actually the readable stream or readable stream you will be having. So when you see this duplex stream, okay, so it will have both readable stream and also a writable stream. So this one will have only one buffer and this one will have two buffers. So that is the main concept which I want to explain you. So in conclusion, what I want to say is streams are powerful and efficient for handling large data in Node.js. Readable, writable, duplex and transform streams have specific use cases. Buffering and drain events prevent memory issues. Using streams correctly optimizes the performance and reduces the resource usage. So that's it guys about the streams concept. So I will try to explain you in the code in the next scenario onwards. You will try to see this entire streams concept in the code so that you can able to understand it clearly. So I hope you found this explanation and all those things helpful. If you like this video, please like, share and subscribe. Let me know in the comments if you have any questions. See you in the next video. In the next video, what we will try to do it is, we will see the practical implementation of the streams. What we have did it right. In the previous video, we have written the file using the streams. In the next video, we will try to see how we can handle this memory usage, how we can decrease the memory usage and all those things. We'll try to see. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So hi everyone, in this video we are diving deep into the Node.js streams and how they manage the memory under the hood. So that is the main concept which we will try to see. Especially we will focus on the buffer sizes, stream back pressure and how you can optimize your app performance. Let's try to see it. So first of all, let's try to see. We are dealing with a problem around a stream memory usage, right? So in the previous video, we have executed this program and we have seen that the memory is taking around 150 MB. Let's say that we will try to run it and so that you can able to see it very clearly. I hope that you will be able to see this screen also, this command prompt also. Node write more.js file. Okay, I'm running this program. And in the task manager, if you try to take it node, so it is taking the memory around 1000 something around the memory has been taken. So that means it is taking around 1 GB of memory space for writing a simple code. And here we are writing this one, right? So it is taking, and if you try to see it, yeah, here it still is taking. So the completion has been completed. Now if you try to see here, the memory has been dropped down. If you try to run it again, let's try to see it again. And here the Node.js went, it is going to around 1000 MB. That is nothing but around 1 GB. 1 GB it is taking. So that means we have a problem when we are using the streams. The memory usage is the problem which we are having it. The CPU usage is less only, but it is taking this one. So let's walk through how Node.js manages this internal buffer and how we can monitor and fix these memory issues. We'll try to see it. So that is the main agenda which we need to work on. So first of all, what we'll try to do is we'll comment our existing code and start fresh. So I will be commenting out this existing code. So this entire code I will comment it out, because what we need to do, we want to analyze the behavior of the internal buffer in a writable stream. So here we want to analyze the behavior. So fine. Node.js doesn't officially expose the internal buffer of a stream, but it gives us two helpful properties. That is nothing but writable high watermark and also writable length. In our previous video, if you try to see, I have told you that whenever you are having a writable stream, internally it will have some buffer. So when whatever the stream data it is coming, it will store it in the buffer. When the buffer is full, it will write to the file or anything, and again it will try to take the data. So by the time when the stream is coming means the data will be stored in the memory. So here we need to know what is the size of this internal buffer. So now the default size of this one is, so if you want to know it means, so we can use variable that is nothing but console.log stream dot high writable high watermark. So this will give you the total size of the internal buffer. Now if you try to show you the total size of the internal buffer, that is around 16384 bytes. That is nothing but 16 KB. Okay, it is around 16 KB. And now you need to know how much of the buffer is currently filled. So how much of the buffer is currently filled means in the stream, you will be having the internal buffer in the stream, right? So the maximum size of this internal buffer in the stream is 16 KB, and how much that stream has been filled, if you want to check it means, so we have another property in the stream object, that is nothing but stream dot writable length. Okay, so this will give you that how much data has been filled. So out of that 16 KB, how much data has been filled? Right now we haven't written anything, so that's why it is showing 0 bytes. So for example, let's say that I have written something like constant buff is equal to buffer dot from. So I have written some data, so my name. So it is around 1, 2, 3, 4, 5. Okay, it's 5 bytes. So each one will take 1 byte. So now here, okay, let's try to check the writable length. So we will write that buffer into the stream. So stream dot write of buff. Okay, we have written. Now let's try to see how much data it has, how much bytes it has taken. So if you see here, the 5 bytes it has been taken, and if you want to print the buffer, console.log buffer, sorry. Okay, now if you see the output for this one, so you will be able to see the data has been written in a hexadecimal format. That is nothing but 6C means it is L, E, E. So that's why 65, L and also E. So that's why this 6C is same, 65 is same, and 61 is the last one. So here the data is storing in a hexadecimal format. Hexadecimal format means nothing but it's an what I meant to say is it's a binary digit only. So this one represents the 4 digit and this one represents the 4 digit. Total 8 bits. It concludes with the both of them combined, it will become 1 byte. 1 byte, 2 byte, 3 byte, 4 byte and 5 bytes. So that is how you need to calculate in the buffer. So this is all totally related to the memory issue, and this all we are dealing with the binary data. So think of it like that only. So when you are converting this L means, so think of that one we are converting into an 8 digit. So it should be something like let's say that L should be in such a way that 0 0 0 0 and 0 0 0 0. So here you can write 1 or something like that. So depending on that one. So that is the thing. Okay. So by default the stream is 16384 bytes, that is 16 KB. You can change it, that one, if you want to change that 16 KB means you can change it, but you rarely need to unless you are building the custom streams. So we'll try to see about that one also. So that is the thing. So we have written the data to our stream, not just a string but a buffer made from that string. So this will help us to visualize what is going on. So now after writing this one, we have seen the writable length, it has become 5 because each character takes up to 1 byte, and when you write the same buffer 5 times, the length will jumps to 36 something like that. So here let's say the 25, sorry, 2 3 4, oh sorry, not this one. Here I will write 1 2 3 4. So 4 5s 20. Let's see the output for this one. So it should jump to 20. So it's correct. So the stream has filled with 20 bytes. So this is how you will need to understand about this one. So now here the crucial part comes. So once the writable length reaches the high water mark, so that is nothing but the writable length reaches the high water mark. So that means when it reaches the 16,384 bytes, when it reaches, Nodejs signals you a back pressure. So that means the buffer has been filled. So if it is then when you are trying to write this one, it will return the false. So where it means the internal buffer is full, and you should pause writing until the buffer drains. So this one we will try to see afterwards. So now we have seen, let's talk about the memory once. So now here we have seen this one. So first of all, what we will try to do, so now we need to create a buffer which is of writable high watermark. So now how we can create the memory buffer with a particular memory by using the buffer.alog. For example, let's say that, so if you want to create it means buffer.alog of whatever the memory you want. So for example, let's say that you want to create 10 bytes, and also I want to fill it with 10. So now if you try to console.log with buff, so now you are creating a buffer, sorry, you are creating a buffer of 10 bytes of memory, and you are filling the data with 10. Let's try to see. So if you try to see here, so all the values is filled with 0A. 0A means it's a hexadecimal representation of the binary values. So 0A is nothing but 10 only in the binary. So now we have created a buffer with a memory of 10 bytes. For example, if I want to create a memory of 100 MB, then what we need to do? 100 MB means, so it will be something like, if you want to search it means you can search it like this. So here you can search it something like MB2 bytes. Okay. So if you search it like this, so here I want to have a 100 MB. There is nothing but 1E plus 8. So this is nothing but 1E means, so 10 to the power of 8. 10 to the power of 8 means, so 1 with followed by 8 zeros. So if you want, you can also create something like, here you can go into this one, and you want to create 1E plus 8. You can write it like this also, not a problem. So now it will create 100 MB. So now here if you try to see the output for this one, let's see whether it will create it or not. So here you will be able to see it has been created 100 MB of space. So if you want to check that you are creating 100 MB of space means, so now I will try to use set interval. Okay, I will create 1000 like this. So now if I run this code, okay, so now we have created a buffer, internal buffer memory. I want a memory of 100 MB. Now if you go here and if you try to see the Nodejs, you will be able to see 100 MB, 103 MB has been taken memory from the RAM. So that means a buffer has been created within 100 MB. So this is how you bring. So now the memory usage spikes immediately. So we have seen that memory usage spikes immediately. And when the buffer is no longer used, Nodejs garbage collector will eventually clean it up, and which you can observe the memory drop. Now when it is not useful means, so if you remove this one, so automatically the memory will be gone away. So that is the main thing. So this is how you can able to see the buffer. Using this buffer concept, we'll try to implement this one. So you need to understand that here 8 bits is equal to 1 byte, and 1000 bytes is equal to 1 kilobyte, and 1000 kilobytes is equal to 1 MB. So like this. So 100 MB means 100 into 1000 into 1000, that is nothing but 10 to the power of 8 bytes. And if you log the buffer, you will see hexadecimal values. Each hexadigit represents 4 bits. So here each hexadigit number represents the 4 bits. So that's it guys about this one. So one final tip before closing, always close your file after you are done. So in this file, in this code, what we have did, so we have opened this one, but we have forgot to close the file. So here at the bottom also we are not closing it. So what you need to do, so we need to file handle dot close. Okay, so if you are manually opening the file means, so always remember to close the file. So proper cleanup is essential to prevent the resource leak, especially in the production environment. So to wrap up, we saw how Node.js streams manage memory, how to monitor and control buffer size, and how to handle the back pressure effectively also we have seen it. So if you like this deep dive, give it a thumbs up, subscribe, and let me know in the comments what you want to learn. So that's it guys about this one. So see you in the next video. So we will try to understand this streams and back pressure and all those things. Thank you. Hi guys. In this video, we are going to dive deep into the Node.js streams and learn how to handle one of the most important but often overlooked concept, that is nothing but back pressure. So what is this back pressure? So you'll see how the high watermark works, how stream.write behaves, and how we can handle the drain events properly to keep our code efficient and safe. Let's get into it, this one. So now if you try to understand our code, so here we have seen, right? We'll have a quick recap about this one. Streams in Node.js have an internal buffer, as you people already know about that one. And the high watermark defines the maximum number of bytes to store in the buffer before pausing the writes. When the buffer gets full, Node.js applies what is called as a back pressure. So we'll try to see this one. So here we have created a file, okay, and we have created the create write stream. And if you want to know this one, so this is the high watermark. So right now what we'll be having, so we have a writable stream with a high watermark of around 16,384 bytes, I think. That means if you try to write more than that, Node.js will return false from this stream.write. So whenever you are trying to write the stream.write, it will return false to signal us to wait. So let's try to see this one. So for example, let's say that I will close the okay, I will close this one. I will remove this one, and here writable length and all those things we know. Now we understood about the buffer allocation. So here what I will try to do, here I will create 16,384. So I am creating a buffer like this. So now if I try to console.log of buffer, let's see how much memory allocation it has been done. Here I will do node write mode.js. So here 16,384 bytes of data has been created, buffer has been created. Now what I will try to do here, I will try to write the console.log stream.write of that buffer, the entire buffer. I will try to write it, and I will check the what I mean to say, the return time. So now whatever the high watermark is there, so I have created the buffers with the same memory, and I am writing that buffer into the stream, and we will try to check whether it will return true or false. So now if you see here, if I write it here, see it has written false. Why? Because the entire buffer has been, since we wrote a buffer that fills the stream completely, this write method call will return false, indicating that the stream is full and we should stop or pause the writing. So here we have written. So for example, let's say that I have decreased one byte and I am writing it. Let's say that whether it will return true or false. So if you try to see here, it returns true. So that means the buffer is still little bit of empty to fill the data. That is nothing but 1 byte. For example, let's say that here I will create another buffer or otherwise console.log stream.write, and I will try to create buffer.alloc of 1 byte. I am creating a buffer of 1 byte. Buffer means here it should be like this, 1 byte, and I will fill it with something A or anything. Okay, now let's see that whether it will the first stream what it will try to return, and the second stream what it will try to return. Now if you see the output for this one, so the first one has returned true. That is nothing but the stream still has, the buffer still has inside the stream has the memory to fill the data. But when we return 1 byte of data, it immediately return the false. So that means the buffer inside the stream has been filled. So notice the difference. Even if the buffer is even 1 byte less, stream.write returns true, meaning it is still safe to write. So even if there is 1 byte less also, it is returning true. Why? Because it is still safe to write. So now if you ignore that false, so now here it has written the false value, right? If the memory is full, if you ignore that false return value and keep writing, your buffer just keeps growing. That's called as back pressure. So for example, let's say that again you are going on writing this one. Okay, so it will go on create a back pressure. So here we'll try to see about the console.log of writable length. Okay, so let's try to see about the writable length. Okay, stream dot writable length. So first of all, let's try to see up to here only. Oh sorry. So now here if you try to see high watermark and writable stream, now I will remove this. Okay, let's keep it like this. So now if you see here, so 16,384 is the high watermark, and the writable length has written the 16,384, such why it has written false. For example, if you go on writing this one, okay, now let's try to see the writable length, what will happen. So let's try to see it. See, if you try to see, the memory has been increased. Okay, this is that's bad, so we should not do it. That data without checking if the stream is full means that's bad. We are overwhelming the stream's buffer and risking our memory issues. So this will be going on writing the memory, even the high watermark, and it will rise into a memory issues. So how to handle this one? So now we are able to know that when the stream.write return false, we are able to understand that the stream is full or the buffer is full. So now how to handle this one? So now instead, when the stream.write return false, so we should pause and wait for the drain event. Now the stream always returns a event. So when the buffer is full, so when the buffer reaches the maximum high water mark, okay, so writable length is equal to the high water mark. So this one return false, and immediately when the data has been drained, it will emit an event that is nothing but a drain event. So how you can capture the drain event is, for example, let's say that here stream dot on off drain. Okay, so this is the drain event, and here you can have a callback method, and here you can write something like console.log. You are now safe to write more. Okay, so this is the drain event. Now let's try to see this one. So now you are safe to write drain, right? Let's try to see the output for this one. So let's try to see whether we can able to get it or not. So we are not able to get it. Why? Because we are closing the file, which should not do it. Why? Because when we are closing the file means automatically the stream also will be closed. Let's see whether we can able to drain it or not. So now if I try to write it here, see, it is taking 16,386, and here it is showing you are now safe to write more. So that means here the drain is happening. So that means here, yeah, now the exactly it matches, right? Immediately the drain will happen. Now here let's try to see. See, now here you are now safe to write more. So that means drain event has been filed. Now if you try to check the writable length in the drain event, it will be again 0. So here you will be able to see. See, it is again 0. So that means the buffer has been emptied. So this is how you need to do it. Okay. So when the stream has finished flushing its internal buffer, it emits a drain event. That is your signal to safely write more data. So here when the event is emptied means then it is a signal for you to write the more data. So for example, let's say that if you are closing the stream immediately means after writing, you will never get the drain event. So here I have closed this file handling close, I have did it, right? So now if you try to stream.end or something like that, if you try to use it also, you will never able to get the drain event. Why? Because we are automatically closing the stream too early. So we are not waiting for the drain event. So that is the main thing. So for example, let's say that you also should be very careful. For example, let's say that here you are having the drain event. Okay, we are having this 683, this one, right? Let's say that I want when the drain event is done, again you want to write this one. Let's say that here 684. Let's say that you are filling this one. Sorry, stream.write of buffer. Okay, again you are writing. Let's say that you are trying to write this one. Now this goes into a loop back. Okay, so this will be a loop. So if you try to see here, so it will go into a loop. Why? Because you are trying to fill again when this drain is happened, again you are trying to fill the buffer 684, and this one again you are trying to write in the stream, which returns the false, and again the drain event will be filed. So this goes into a loop. This code causes a drain write loop. So this goes into a loop. Use conditions or control flow to avoid it. That is the main thing. So now just try to recap what we have learned, how to handle the back pressure. So let's summarize what we have learned up to now. First one is the high watermark, defines your internal buffer limit, and also stream.write returns false when the buffer is full. If it returns false, we need to pause the writing and wait for the drain event to resume the writing. Never let the stream.writable length exceed the high watermark. That is the main thing. Don't blindly write in a loop, always check the return value. So here, so the loop thing, you don't blindly return. So now we are able to see about this writable high watermark and all those things. So this is what about the drain event and also the writable allocation and all those things which I want to tell you. Okay, in the next video what we'll try to do is we'll try to implement this in our file writing thing, and we'll fix our for loop. So here I have mentioned this for loop, right? So down here, this for loop, how we can stop it and how we can write it, let's fix it in our next video. That's it guys about this one. So, and that's how you will handle the back pressure and drain events properly in the Node.js streams. If this video helped you understand streams better, hit the like button, subscribe for more content like this, and drop a comment if you want to have a deep dive in the buffers next. Thanks for watching. Hey developers, this is Leela. Welcome to my channel. In today's video, what we will try to do is we are diving deep into one of the most powerful feature of the Node.js. There is nothing but the writable streams. We are trying to learn about that one also. That's common first of all learning. So this is not the basics thing. So the previous videos all I have completed all the basics. Now we will look on how to handle the back pressure using the drain event properly and understand the significance of this high watermark. So with our experience, so by the end of this video, you will know how to write the streams efficiently without choking your memory. And yes, with real code example, I will try to show you the benchmark and also the tips from the official docs also I will try to show you. So fine. Here we have learned about the basics of this one, all the stream, right, and the drain event. These are all the things we have learned it, right? I will comment out this entire code, okay, or otherwise I will delete this entire code. Yeah. So now we need to target or we need to focus on this for loop. So which we will be writing something like half a billion or half a million. I don't know. So 5 million. Let's say that. So 5 million. I think. Yeah. Let's try to see it. Yeah. We'll try to see the benchmark of this progress. We'll see it. So now we are trying to do this one. So now when you are writing a huge amount of data to a file using a writable stream like a million entries or anything, so you might be tempted to just go for in a big loop. So like this we will try to go it in a big loop, but there is a catch. This fills up the Nodejs internal stream buffer, causing the back pressure, which we have seen it. So this is the thing which we have seen it. Memory bloat and also the serious performance issues you will be able to see it. So that is nothing but this is the best example. So here we are not trying to handle the back pressure. So that means here the stream will have an internal buffer of around 16 KB and we are not taking it and we are going on writing the data into the stream so that the memory will go out. So that's a bad practice which we have discussed in our earlier videos. So this might look fine at the first, but if you monitor your memory usage, it could shoot up to 200 MB or more. So which we have already seen about this one. So fine. So then what is the right way? So we should handle the back pressure. First of all, we should break the loop when the stream dot write return false. So when the stream dot write returns false, we should break the loop and resume it only when the stream buffer drains. So that is the main thing. So now for this one, we need to refactor this code. So let's try to refactor this code. First of all, we will define our loop inside a function so that we can pass and resume it later. So for this one, what I will try to do it is, I will try to create another method. So there is nothing but write many. So in this one, I will try to copy this entire code and I will try to move it to this one. So this is the thing. And the next one, what I will try to do it is, I will convert this for loop into a while loop, and also I don't want to initialize the variable here. I want to make it as a global variable so that I can resume the loop from that I value. So here I will be taking and I will change it to while loop here, and we can remove this one and I can use this I++ also cannot, we will not do it. I less than like this, and we will be await file handle dot write. I am removing this one. So we are creating the buffer and writing it. So fine. Okay. So this is one thing. So now we have created a write many function and set up let's try to set up the drain event also. So let's try to set up the drain event. So here I will write stream dot on off drain. Okay. And here I will be writing, then I will call this write many. Okay, so now when the drain is completed, we will be calling this write many. So resume from where we have left off. So now what we need to do here, so we need to know that here we need to do the I++. So here I will be doing the I++ after writing it into the buffer. Fine. So if the stream is not there, okay, if the stream is not there, then I should have to break the loop. Okay, so if it returns false means I should break the loop, and then afterwards again it should write it. That is one thing. Okay, so now when you run this one version, so memory usage stays around 50 MB with a huge environment like this. So let's try to see the output for this one. I too don't know. So let's try to write here. So it has finished in 12.4. Okay, that is not correct actually. Let's try to see how much memory it will be taking. Let's go to the activity monitor. So here I will be writing this. I will be having it here. So immediately it is completing. So here you are having units, tens, hundreds, thousands. 10,000 lakhs, 10 lakhs, half a million you are having, but it is completing very fast. Okay, it back end. So let's try to write it another one, and here I will do, so that that one leave it, and here if I try to go into this one, why this one is taking, okay, my mistake. So I am not calling this write many function, so I need to initialize this write many function, right? Okay, let's try to decrease this one, so it will not finish this much fast. So first of all I need to jump start that I need to call that function at the starting. Now let's see if it will go. So 20 that leave it. So now its Node.js is running. If you try to see here, the memory usage is not going more than 50 MB. So it is around 38 MB, something 40 MB it is taking. Hardly it will take around 50 MB. So now, so we are able to mention this one. So we need to know about this console.timeend also. So how we can benchmark this? Okay, it is taking some time. So maybe it's half a million, right? It will take some time. So fine. So now how we can know? So the final one, how we can know it? So for that one, what we need to do it is when the stream is ended. So now it has been finished. So now we are able to 22 milliseconds. Okay, fine. That maximum this execution time depends on the CPU thing. So now what I want to do it is, so here if buffer I++ is done, okay, and here I can write it, if I is equal to so this one -1. So if it is in the last time, so the last loop if it is saying means I want to close the stream. So here I can do something like return stream dot end of, and this end will take the buffer. So this is the last write it will take it. Okay, so now you can also implement this one. So if it is less than something -1 means we can end the stream also. So what's happened when we are in the last write means we just don't stop, we end the stream properly. And the dot end method also emits a finish event. So when you are emitting the when this end method is called, so it will emit a finish event, which is the perfect place to measure the execution time and clean up the resources. So here what I can do it is, here I can use stream dot on off finish off, and here it will emit the finish. So here I can do the console.timeend. So what it is trying to do it, that console.timeend I will try to use it here. And what I can do it is, so now here if I want to close it means I can close the file handle also, file handle dot close, that's it. So now we have made it. Now let's try to see this one, let's try to execute this one, how much time it will take. So let's try to see, this is the proper time. So now if you try to see it, the memory, the activity manager, the memory we need to check it. So it is, the memory is not boosting, and also the CPU also it is not taking. So this is the perfect way how we need to, how we will be writing the code. Okay, it will take some time depending on the resources or the system, the course what I am having and all those things, and the processes, what are the process it is running in the backside. So depending on that one it may take some time, but in your system it will not take too much time. So here it will be finished it very fast. So let's try to see it. It depends. So now how many the value will be, so how much the value will be, the resources will be utilized less only. That is the main thing. Now if you try to see the code for the memory for this one, it is around 42,661. Let's say I will try to decrease one value for this one, or otherwise let's say that how many times it has been drained, we need to know it, right, as it takes. So how many times it has been drained means, so here I can take something like let j is equal to 1, and here I can do something like j plus plus, okay, and I can do console.log of j. So we can print this one. Let's see how many times the thing has been drained. If I try to write it here, so it is going on, so these many times it is draining. Let's see whether the number value it is same or not. Let's try to see it. So these many times it is draining. Actually maybe the value is too much big. I think we can decrease the value. Let's see this one, how much time it will drain. Oh, this one is too much, so we'll try to make it with a smaller number. Okay, fine. Now if I try to run this one again, so now it will take around how many things we'll try to see. So now it has taken around 237 drain. So that means the drain thing has been done 237 times. Let's try to see the file size of this one. The file size of this one is around 3798. If I try to see the how many bytes it has been there, it is around 38,890 bytes or something like this. I don't know which one we need to take it. Let me know in the comments. So which one is the correct size? So I am taking 200 something like that. Let's go to the calculator, okay, and I will paste it this one. And we know that the highest watermark value, the writable high watermark value is 16,384. So I will divide it with 16,384. If I do is equal to, it is coming around 237.5. So which is exactly matching with the value 237, and 238 has not came way because the buffer is not full. So half of the buffer is only full. So that's why the drain event has not been filed. Some of the data has been left. So this is how you can benchmark. So now, so there are around 237 drains we are having. So now high watermark is basically the size of the stream's internal buffer. If your chunk size exceeds, you will get a back pressure, and that's when stream.write return false. So that is the main thing. So when you call the stream.end, you can't write anymore. Trying to do so, it will try to throw an error. So that is a very important thing you need to do. So if you didn't return it here, so then means you are ending the stream, and again you are trying to write it here. So then you may get an error here. Let's see. So you may get an error. Why? Because after ending the stream you cannot write it. Maybe at see here you may able to get it. Why? Because stream write after end. So here you need to must and should you need to return here. That's it. So that is one important bonus which I want to tell you. So now let's try to summarize everything what we have learned. Keep your loop inside a function. Okay, so we have kept the loop inside a function, and we have moved the loop index I outside the function to preserve the state. So we have stopped when stream.write return false. So here break it, and we have resumed the inside the drain event. So again we have called inside the drain event, and we have called the stream.end on your last write. Okay, so stream.end event, and we have used the finish event when the stream.end is called. So to clean up and benchmark we added, and also we have monitored the memory and optimized the thing. So that's it guys about this one. So how we have efficiently used the memory, and how we have efficiently written the huge file size without utilizing the most of the resources and Node.js, and we have seen it. So hope you understood about this one. So now you got a solid understanding about the writable streams and all those things. So don't forget to subscribe. That's it guys about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi everyone, welcome back to my channel. In the last video, we have solved a memory issue using the writable streams in the Node.js. And now that we have wrapped up our work with writable streams, it's time for having a little recap. Today what we will try to do it is, we will dive into our official Node.js documentation. So let's go to the official Node.js documentation here, to consolidate everything what we have learned so far right now. So we are going to understand what's going on under the hood, walk through some core concepts again, and see how Node describes them. So alright, let's open the browser, and I am searching the Node.js, and let's open this Node.js. Here I will be going to the docs, okay, and official documentation, and here search for the streams where we will be able to find here. This is the stream. So now here, this is the documentation for this one. Now once you will notice something interesting. The stream documentation is split into two major parts. One for stream consumers. So here you will be able to see API for stream consumers, and another one is stream implementers. So readable streams and all those things you will be able to see, and somewhere API for stream implementers. So in this video what we will try to do is, we will focus on the stream consumers, but don't worry, we will cover all these concepts and all those things, implementers and all those things later in this video. So just we will try to learn about this stream consumers. So right now we have consuming the stream. So that too we are learning about the writable streams. Okay. So if I click on this writable stream, let's click on this writable stream directly. So we have learned about this writable stream only up to now. The first example Node gives us is the HTTP. So here you will be able to see where you will be able to see. Okay, let's try to go to the top. Okay, so here let's come down. So somewhere you will be able to see. So you will be having these all the things. So let's close this one all. So now here let's go to the writable streams directly. Let's click on this writable streams API for stream consumers. Yeah. So here you'll be able to see the first example which you will be able to see the node users using the HTTP module. So now we have mostly been using the FS module in our examples and we will stick to that only for now. But here is the thing. So if you understand the streams in the file system module, you will absolutely fine, and using them in HTTP, TCP or any other places also where the node uses the stream only. So here if you try to see here the create server and this is the request and this response is a stream writable. So here request is a readable stream and here the response is a writable stream. Okay, here you are able to see. So if it is a writable stream means you know that you can use the response.write. So here this is stream, response is a stream.write, you able to see the stream.write, and here you will be able to see this is a readable stream, right? You are able to get the data. So we'll learn about this readable stream afterwards. So here this is all the readable stream, and here you will be able to see the response.write, that is nothing but writable stream, and we are ending the stream. So now if you want to send the last part of the data also, you can send it, and we are sending the response.end error. So here you will be able to see the response.write, response.error, response.end like this. And this stream you can also able to see the finish, stream, the close and all those things also we can see. So here you will be able to see the writable streams is response is a writable stream, so that we are able to use the methods write and end which we have used for the writable stream. So readable stream, so we will learn about that one. So now let's go on to the writable streams here. So here where the writable streams we will be using it is writable streams we will be using in the HTTP request for the client, HTTP responses on the server. So we have used the FS module, writable stream, and crypto, TCP sockets. These are all the things we have used it. So how you will be using this writable stream? So we need to get the writable stream like using the file handler or something like that, and we will write it and we will end it. This is normal. And the class we will be using is the writable stream. So the stream.writable, and we will be having some events. Here they are having close event. So we have already seen this close event. So what is this close event? The close event is emitted when the stream is been closed. The event indicates no more events will be emitted and no further. This one is done. So this is the close event which we have already seen it. And if you want to return false, the drain event. So the drain event also we have seen it. And the another event. So here you'll be able to see the same example which we have implemented 1 million times, writing that 1 lakh like this. The same function write and all those things it is trying to use it. The error is a pretty straightforward. So whenever you are the stream, whenever it is writing the data, if you get error means, so you can use this error method. That is nothing but stream.on-off error. So here you'll be able to see stream.on-off drain and finish it, right? So in the same scenario, stream.on-off, what I can say, same thing, stream.on-off error you can use it. So that is the thing which I want to explain you. So next one is the finish. So you know about the finish thing. So when you have emit the stream.end immediately, so this one will fire. Okay, so when you use the stream.end, finish will fire. So this writer.on finish will fire. And the pipe concept and all those things I will try to explain you about this one. So in the upcoming videos I will try to explain you. So right now keep it aside, this pipe thing. Okay, so finish event you understood, and what I want to say is close event also I have explained you. So this close event will fire whenever the stream, so for which the stream you have started, something like file descriptor for example, if it is closed means then this close event will be fired. The finish event will fire when you end the stream. So these two things you need to understand. So in this scenario what you need to do, so now here in this scenario we are closing the stream. So for example let's say that when you close this file, then the stream.on close event will fire. So that is the main difference between those two. So error event we understood, finish event we understood, and coming down pipe and unpipe we will learn it after when we are learning about the pipe concept. So cork. So this cork is a pretty easy one only. What I want to tell you is what we will not use. I haven't used it anywhere. So when you call the cork, what it will happen is when we will be using is if you are having a small chunks of data, small chunks of data if you are getting it means. So all the time you will use it to use the stream.write like that, right? Stream.write, what it will try to do, it will write it in the internal buffer directly. Okay, instead of writing that one. So now if you use this writable.cork, stream.cork means, so whatever the things you are doing stream.write, everything will be stored in the buffer. It will be stored in the buffer in the memory. So when you call the stream.uncork, then all the buffer data will be flushed. So that is the main thing. So here you'll be able to see somewhere they haven't used it. So like this, the cork will be there. So you will be writing stream.cork, stream.write, stream.write, whatever the things you are writing stream.write, it will store it in the memory. And when you use the stream.uncork, everything will be flushed into the internal buffer. So that is the thing. So these are all the cork. When you have used this writable.cork, the data which you are trying to write it in the stream.write doesn't come into the high watermark. So when you uncork it, then it will goes in, then the file data and all those things is based on the high watermark. That is the main thing you need to understand. Fine. So destroy, so the same thing. So I use it to forcefully destroy a stream. So maybe you don't want to continue writing due to an error or user cancel and upload. So like this you will be using it. And these are all the properties. So you can able to see that closed is true after close event has been emptied. And writable.destroy, whether if it will return true after the writable.destroy event has been called. So stream.end, you know about this end thing. And set default encoding. So if you want to set the default encoding, so we can use this one. Uncork, I told you, right? So uncork, it will immediately flush the data into the internal buffer. So here you will be able to see stream.cork, then whatever the stream.write you are trying to write it, this all comes into the memory instead of into the internal buffer. So when you use the stream.uncork, all this data will be stored in the internal buffer. Then it will comes under the high watermark. So that is the main thing. So now, so writable, you will be able to know about this one. So whether you can able to write it is safe to write or not. So this one is an experimental, it seems. Writable enable, writable cork, these are all properties here. So writable high watermark, you will be able to see what is the high watermark. Writable length, what is the internal buffer. Writable need drain, and these all things are there. Right, so you know about this, right? Stream.write, we have used it. So you have a pretty long data. So if you want to read it, you can read it. So now you will be pretty easy to understand. So you will feel comfortable to read this documentation. Now whatever the things we have learned. So by this, the writable stream is finished. So then next starts the readable stream. So we will try to learn about this, what is the readable stream and all those things. So this is all about a concept of the Node.js writable streams. So hope you understood about this concept. So final notes, what I want is, before wrapping up, so that wraps up everything you need to know about the writable streams from the docs. We have seen how to handle the events, how back pressure works, what are all those confusing properties really mean, and how writable streams are everywhere, not just files only. So that's it guys about this one. So in the next video, we will jump into the readable streams, which are just as important. We will start reading data efficiently, and guess what? We will combine them with writable streams later to do some really cool stuff. So that's it guys. So hit that like button if this helped clarify things to you, and subscribe so you don't miss the next one. Thanks for watching. I will see you in the next video. Hey everyone, welcome back to my channel Leela Web Dev. Today we are diving into the world of readable streams in the Node.js. How they work, why they are powerful, and how they handle the large files efficiently using the chunks and also the back pressure. So this video is a continuation of our previous session on writable streams. If you missed that, check the link in our playlist so that you can have an idea about the writable streams also. Now in this video we are learning about the readable streams. So let's clean up first the project about this one. So right now here I am having test.txt writemore.js file, which we have did it, right? So I will move these two files into the writable folder. So I have created a new folder, and I am moving these files into the writable folder, and I am creating another folder that is nothing but readable folder. So in this readable folder we will try to write the read thing. So let's try to implement setting up the thing. So here I will create a new file that is nothing but readbig.js file. So anything, okay. So this is our file and I'm adding it. Let's import the fs module, require fs, and here it should be node fs / promises. Okay, first we need to read the file. So first of all we need to read the file. For reading the file, let's say that we are having this writable test.txt file, right? So let's try to run this one again so that we can have the file. Now what I will try to do is, here we are having node write more.js file. So it is taking some chunks of file. So it has written 2 seconds. Okay, fine. Let's copy this file and I would try to paste it here, so that what I would like to read this test.txt file. So it's a pretty huge file. Okay, fine. Cancel. So now we have a test.txt file. I need to read this file. So how can I read this file? First of all, let's try to open the constant file handle, or otherwise let's try to create an immediately invoked function that is nothing but like this. Okay, and here I need to call it, and here I need to keep the async. So this is our function, and here I am reading file handle read is equal to await fs dot open, and I am opening this one file path, that is nothing but the test.txt file which I would be trying to read it. So this is the file I am reading it in, and so now we are opening the file with an read flag for reading. Now let's create a readable stream from our file handle. So now here for reading this one, so what I would be trying to do, constant stream read is equal to await, sorry, not await, file handle read dot create read stream. So I will be creating a read stream directly. So I have created a read stream. Readable stream normally emit events. So if you want to get the chunks of data, we should listen to the data event. So let's try to listen to the data event. That is nothing but stream read dot on off data, and you would be getting the chunks here. Okay, chunk, and I will be trying to do the console.log of chunk. So you will be getting each chunk. So fine, that's the thing. So now let's try to run this one. Let's go here. I will be doing the CLS. Let's go into the readable, and here I will be reading node read big.js file. So if I try to read this one, so you will be able to see each one, you will be able to get a buffer. Okay, each log shows a different chunk. Instead of loading the full file into the memory, we get it in a manageable pieces. So now what is the size of the each chunk? So let's find out this one. So what is the size of the each chunk? You will be able to see 65,486, something like that. So what is the size of the each chunk? So let's try to add here console.log chunk dot length. Oh, sorry. Chunk dot length. So now if I try to do, so here you will be able to see it is around 65,586. So by default the chunk size here is 64 KB. So because fs dot create read stream sets the high watermark to the 64 into 1024. So that is around, if you try to open the calculator, or otherwise I will try to open the Chrome, more than the writable stream it will be. So the internal buffer for this one, let's try to go to the Nodejs. Let's go here and open the docs, and let's go to the fs module, that is nothing but file system, and here you will be having a create read stream. So here if you try to see create read stream and all those things in the options. Okay, so here in the options somewhere you will be able to see high watermark. Yeah, this is the high watermark, and default is 64 into 1024. So the watermark for this read stream is 64 into 124. So if you take 64 into 124 means how much it will be? It is 65,536. exactly these many bytes it will be having. Okay, it sets the, by default it sets the high watermark to the 64. Let's verify. We have verified that one in the Node.js docs also. So now whereas this if we compare this one with the stream.writable, where the default is just 16 KB only. So if you want to change the high watermark value, we can change it for this one. So for example, let's say that here if I want to change the high watermark value means, so here I can give high watermark to 400 bytes. Okay, if I try to give it with the 400 bytes, and if I run this one, okay, you'll be able to see the 400 bytes only. So it is taking around 400 bytes. It's taking too much time, so let it take. Yeah, so the last chunk, the data is only 90 bytes only, so you will be able to see the 400 bytes of data. So now the chunks will be 400 bytes, so we can reset it back to the default one, that is nothing but 64 KB. So I am resetting back. Okay, so fine. So now what I want to do, so we got the chunks of data. So we need to write the read chunks to another file. So now let's copy the contents of our source file into a destination file using a writable stream. So first of all, what we need to do it is, so here we need to create a file that is nothing but destination.txt file, something like this. Or otherwise there is no need. So it will be created, right? So here let's try to create a file. Constant file handle write is equal to await fs dot open, and here I will be having a file destination.txt, and I will try to open this one in write mode. If the file doesn't exist, automatically the file will be created. And here I will be creating a constant stream write is equal to file handle write dot create write stream. So we have created the write stream for this one. So now we know that, so whenever we get the data, okay, so we need to write that one into here. So we got the chunks of data, that is nothing but the buffer we are getting, and here I can simply use stream write dot write of chunk. That's it. So let's try to see whether we can able to do it or not. So if I try to run this one, done, finished. Within fraction of second it is finished. And if you try to see it here, destination.txt file has been created just as same as the test.txt file. If you try to observe the file size of this one, I don't know whether you are able to see the file size or not. Yeah, here exactly the file size is 3.7 MB and 3.7 MB. We are able to see the test file and the destination file is one and the same only. Both should match exactly. And just like that, we have successfully copied a file using streams. So, but hold on. So this is not an optimal. Why? Most hard drives in our system can read faster than they can write, causing a memory buffer buildup called back pressure. Node will keep buffering unread chunks in memory, just like what happens in a tight for loop writing too fast. To simulate this, let's create a much larger file. I already have a much larger file. That is nothing but you will be having file huge.txt file. Let me copy this one and I will paste it here. So it will let it paste. So it is around 5 GB. So this file, let's try to write it in our destination file. So now, so I am creating, so it has generated around 5.07 GB of file is there. So now let's try to copy this big file using our stream based solution. So let's go to the back to the readbig.js file and now change the file of this one, source file handle read, that is nothing but what is that one, file-huge.txt file. So now I will be trying to open that one which contains 5 GB of data. So now keep an eye on our memory usage in the activity window also. Let's try to go here, activity window, and here I will be trying to keep this one also. So let's try to minimize this one, and here I will try to rewrite this one. So now if you try to check it here, it is going to 37 sorry, so where is that one, Nodejs runtime. Yeah, the disk in this one, it is going too much. So it is going on increasing. The disk and all those things, it has went away. So now because we are reading it quickly, okay, we are reading and writing it. So now because while we read quickly, we are not waiting for the write to finish before reading is done. See here, memory has went away. So now here when we are writing here, so this internal buffer has only 16 KB, and this at a time it is sending 64 KB. The remaining data is stored in the memory and it is trying to write all things. When the buffer is more, it has to drain it. So now it has to, so we are not waiting for the write to finish before reading the next chunk. Even though this completes fast, we are still under back pressure. Okay, so when you try to take it larger files, it will have a back pressure. So now here we are able to see 5.07, it is completed very quickly. So to handle this property, what we need to do, we need to pass the read stream when the write buffer fills up and resume it after it drain. So I will try to explain you this one in our upcoming video. So how to handle this back pressure and all those things here in the stream. So this is all about the stream read data. So as far as well, what we have learned in this one, you learn how to read the data in the chunks and also how high watermark affects the buffering. And we will try to learn about the memory issues with the back pressure control. So if you found this video helpful, don't forget to like, subscribe and hit the bell icon for more deep tech tutorials. Catch you in the next one video. Don't miss it. That next video we will try to handle this back pressure, how we can do it. Thank you guys. Hi everyone. In this video we are going deep into the world of Node.js streams. We will look at how to handle the massive files, gigabytes in size, using streams efficiently without blowing up our memory. We will even simulate writing 1 billion lines to a file and see how streams can help memory usage incredible low while doing a heavy lifting task like that. Let's jump right in. So for this one, we already have in our previous video a massive file that is nothing but file-huge.txt file. So that file size is around 5.07 GB. Okay, so here we are so we need to read this one. Let's read this massive file back and copy it using a read and write stream. So we renamed the file, so like file-huge.txt file. So now let's try to write it here. So that looks simple, right? So now here let's go into our code. Yeah, so here we have written something like fs.open. So this is all the create write stream we have written. This looks simple and it is, but when I ran this first time, it totally crashed my computer. My memory usage jumped to over 1 GB, and so all this will happen. So depending on the system what you are trying to use it. So now in order to what is happening here, so we didn't handle the back pressure, a key concept when dealing with the streams. So let me show you how we can properly handle it. So now here let's say that here we are having a stream.write. So it will be going on writing the stream.write. So what we will try to do it is if not of, okay, stream.write of chunk. So if returns false means, then that means the buffer is internal buffer is full. So then what we need to do, so we need to pass this one. So I will be passing stream read.pass. So we have passed the thing. So now it will stop buffering the data. So what we need to do, so automatically what I will try to do it is, so here what I can do it is, so here finished. So let's try to do stream write dot on off drain. So when it is drained, okay, so then what I can do it is I will try to do stream read dot resume. So we'll be having a method that is nothing but resume. Automatically the stream read will be resumed. So now when the buffer is completed, so it will send you a something like end thing. We will try to see afterwards that one. So now what is happening here, so when the write chunk returns false, we call the stream read.pass to stop reading more data. Then we wait for the drain event, which tells us the buffer is ready again. Once drained is completed, we resume reading by using the stream read.resume. So this way we let Node.js handle the flow of data smoothly without overwhelming the memory, without using more memory. So the result of this one is memory usage stayed at just the TMB and we copy 10 GB of file. So now if you try to do the same thing, Node.js read big, so the memory will stay like this only. If you try to check the activity monitor, let's try to check it for the node. I am trying to check it for the node here. So the memory remains something like 20 MB, something like this only. So it will be slowly writing the data. So this is how it will be writing. As you can see now, after completion of this one, let it take time. So now it has been finished. So after it has been finished, if you try to see both the files, it is in the same size only. If you try to check it, refresh, so it is 5.07 GB and also it is also 5.07 GB only. So as you can see, both the source and destination files are exactly 5.7 GB, even down to the last 411 bytes we didn't lose a single byte also. So now that is things. Now think about this one. So we are dealing with files here, but streams are not just for files. They can be used for network requests, messages, even database queries also. With streams you can handle now 10 GB, 100 GB, even terabytes of data, all with minimal memory usage. So that is the main thing. The goal is not to avoid 100% CPU. The goal is to keep the memory pressure low. That is the main thing. So that is how you use the streams the right away, handling massive files without killing your RAM. In the next video, what we will try to do it is, we are going to filter the chunks in real time. For example, extract only even numbers or prime numbers from the stream before writing them to a new file. So like that we will try to do it. So now what I want to do it is, so that's it guys about this one, stream.write, and what we have learned about this one. Make sure to hit like and subscribe so you don't miss this type of things. See you in the next video. Thank you. Hey everyone, welcome back to my channel Lila Web Dev. Today we are diving into the Node.js streams, specifically how to handle a massive file, something like, let's say that 1 billion numbers or something we are having it, right? But here is a small twist. So we have already seen about that one, how to delete, but we are only going to extract the even numbers out of that big file, so and write them to our new destination file, all while keeping our memory usage minimal. So and trust me that trying to open that file in Visual Studio Code totally crashes, but with streams no problem. Let's get on to it. For example, let's say that you are having a file which is an file underscore huge, which is a 5 GB. So when you try to open this one in Visual Studio Code or something other, any other editors, your total system will get crashed. Why? Because this total file, what it will try to do, it will try to load it in the memory and then it will show it in your Visual Studio Code. So now if you are, this means it will be taking 5 GB of your total RAM or memory. So that doesn't make sense. Instead of opening the entire file at once, so we are going to use the Node.js streams to read it one chunk at a time. So now for example, let's say that if you are having like this, means let's say that we are having a readable. Normally you will be able to know about this cat, okay, file underscore huge. If I try to press enter, see it is going on reading the data, showing the data, but I can do parallelly my work, whatever the work I want to do it, I can do it. This is possible only through the streams. So the cat is using behind the scenes streams and it is sending you the chunks of data so that it is going on showing the data using the less memory usage. Okay, so that means instead of trying to drink the whole thing at once, it is like, this is like sipping from a fire hose. So efficient and also controlled. So that is what the streams will try to do it. So running this command shows us some of the file contents using a stream like approach. Notice how our system doesn't freeze, everything works as expected. That's because cat is reading and printing it incrementally. So that is the main thing which you need to do. So now what we need to do, so our goal is read the file chunk by chunk. Okay, so right now we are having this code, right? So our goal is to read the file chunk by chunk, file underscore huge.txt, extract only the even numbers from it and write those even numbers only to the file. So that means totally if you are having an even numbers means, so one alternate numbers always will be a even number. So that means if you are having 5 GB means the destination file, the resultant file will be something around 2.5 GB, half of the file. So how can you determine even numbers? A number is even if number mod 2 is equal to 0. Simple. If the remainder is 0 when divided by 2, it is even. That is the main thing. So now we are having a file underscore huge.txt file. Since we have 1 billion numbers or something like that, we are having it, and every other number is an even, the result will be something around 2.5 GB. I told you, right? So the destination file will end up with an, if it is 1 billion numbers means it will be 500 million even numbers, right? It's half of the things it will be. So that is one thing. So now let's try to get it into the code. So first let's get into the code, and first we need to read a chunk and convert it into a string. So here we are having the chunk. So if you try to print the console.log of chunk, so let's try to show you the chunk value, and instead of taking the file underscore huge, I will take simple file. So then afterwards we can use the file so that you can able to see it clearly, or otherwise you can use the file underscore huge also, that's not a problem. And here if I try to show you the code for this one, let me show you the code for this one, how it will handle. Node read big, yeah. If I try to show you, it is showing you the buffer. Okay, so it is showing you the buffer of data. So now it is showing you the buffer of data means what you need to do. Generally, as we discussed, that the buffer data is nothing but an hexadecimal digit of a binary digit. So that means each value, each number is an hexadecimal digit. So it's a binary value. So now let's try to convert it into a string. So here I will try to do chunk dot to string of, so you can mention optionally UTF-8. By default it will be UTF-8 only. If you don't mention it also, it is a UTF-8. So now if you try to do the same thing for this one, CLS, and now you are able to see the values, we are able to get the values for this one. So what I need to do, I need to get this all the values as a chunk. So here it is displaying all things. So let's try to get the chunk. So how can I get this one? So here I can do constant numbers is equal to chunk dot to string, okay, dot split. I can use the split and I will be using with a single space. So fine. Let's try to console.log of numbers. So what does this split do? The split does nothing. So what it will try to do, it is, for example, let's say that if you are having a 1 2 3 4 something like that, means then it will try to split it. So if you go here CLS, so if you are having here, so let's say that constant s is equal to, okay, 1 comma 2 comma 3 comma 4 comma 5. So you are having it something like this, okay, oh sorry, so you are having something like this, syntax inspected, okay. So let's say that you are having a string like this, okay. So now if I try to split it with a comma, then let's see how you will get an output. So you will be able to see that 1 2 3 4 has been, we got it. So if you are having the space also, one and the same only, so you need to split it with the space. So that is the factor what we are trying to do it. Now we are splitting with this one, and let's try to see the output for this. So here I will do the node read big. So here you will be able to see it has been divided, but one empty space we are getting it here. So why we are getting this one empty space every alternate time? So let's try to see this file for that one. So that means we are using two spaces. If you go to our writable and writemode.js file, so here we are using one space here and also another space here. So that's why we are getting two spaces. So now if I try to run the same thing here, see here now you are able to see all the values, we are able to get it. But here one problem is there. If you try to observe carefully, the first digit is not looking correct. The first digit of each chunk, the first data is not looking correct, right? The first number is not looking correct. I don't know. So sometimes you are getting single digit. So single digit only all the time I am getting it. I don't know. The first number is not looking perfect. So what could be the reason? Let's try to see it. So now if you are not getting correct, means let's try to check it. Numbers of 0. Let's try to check the 0 of this one. So if you try to check the 0 of this one, and also if you are getting something like this one, means, so if you are getting here something like this one, means maybe the last number also is not looking nice. So what will happen? Let's try to see here. So numbers of I will try to check numbers dot length -2. So the before number I will check it, and also I will check the number of length -1. So whether these two are correct or not. So here I will try to show you console.log division. I will keep it. Let's see this one. And if we run this code, what will happen? Let's see. So CLS, and if I try to run this one, see the first number 448063 and the next number is not, it should be 5556, it should be, it is not there. So here this one is matching 998 and 9999, so it is matching. So that means it is the exact number is there, but number for some values the number is not there. For some values we are able to see the exact values there. So this is because what is happening is when the buffer is trying, when the stream is trying to read the chunk of data, so 65 KB is a 64 KB is the maximum high water limit for the readable, right? So if you are able to get high water limit reached, means the half of the digits are getting sent to the next chunk, or will be sent in the next chunk. So that is the reason. So the number is splitted into two parts. In the first part is coming in the first chunk, and second part is coming in the second chunk. So it is something like a 8-digit number, right? Each one will take the 1 byte. That is nothing but the 8 bits. So that is the reason it is taking like that. So now in order to check this one whether it is working properly or not, so that means if I try to print the number of 0, it will match here. So console.log numbers of 0. Okay, so now let's see whether we can able to get it or not. Let's try to see. So here if I try to print it here, the first one will be always correct, right? So the first one, so here you will be able to see 10,948. Okay, fine. So file descriptor, we are not closing the file handle, so that's why it is showing you. Okay, fine, that's not a problem. And if you try to check it here, so what is that I am trying to show? Numbers of length minus 1, numbers of 0, it's correct one, right? Let's go down. Yeah, so now these two, okay, these two, whatever you are trying to check it, these two you need to keep it here. So that means 71 and 72, and this 4 you need to keep it here, 63 and 64, and here this 8 you need to keep it here, 647 and 648. So like this, the first value and the last value, so it the first value of this one is nothing but this a part of this, so that's why it is getting truncated. So now if you try to check it here, so we need to handle that first and last numbers, and we need to find the even numbers. So let's try to do it in the next video. So you hope you understood about this chunk thing, how the chunk values is getting differentiated in the buffer, in the streams, while we are trying to get the chunks data in the buffer. Hope you understood about this one. So I will try to we'll try to solve this issue in the next video. So that's it guys about this one. So if you have any doubts or any suggestions, please post the comments below to this video, and if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. Today we are diving into a super important topic for anyone working with large files in the Node.js: how to properly handle the split characters when reading streams chunk by chunk. So if you try to see our code, so right now the code which we are trying to see, the chunk and all those things are splitted. Now if you see the output also, so it has been splitted. So let's try to understand about this one. So how to properly handle the splitting of these chunks, and also why this happens, everything we need to understand it. It sounds tricky, but by the end of this video you will understand it completely, and we will even walk through how to solve the code also. Let's try to see it. So now let's go. So when we read a data from a file in Node.js using streams, the data comes in chunks. This one you already know. These chunks are called as a buffer. There is nothing but array of bytes. So here if you try to observe carefully, let's say that you are getting it as a buffer. So imagine that, let's go to our paint. Yeah, here I will try to write it. So let's say that we are getting it as a byte. So you will be having 1, 2, 3. So going on, you will be getting around 32,182 or something like this. Okay, let's say that this is an array. So this is the chunk of data which you will be getting it. Why? Because so this one is around the read chunk, it is around 64 KB. Let me tell you, it is 64 KB. That means around in bytes, if I try to tell you, it is around 65,000 bytes, right? So maybe I am thinking 65,000 bytes, something like that. So as I already told you, first we need to understand how the buffer works. So I want to tell you how the buffer works. So let's Control Z this one all. So let's say that you are having an array. So 1, 2, 3, something like this. Okay. So this is an array, and each representation of this one is nothing but an 1 byte. Okay. This is a 1 byte. So 1 byte, it is nothing but it is represented using 8 bits. So 1 byte means nothing but 8 bits. So that means it is something like the one representation, it will be happened in something like 0, 0, 0, 0 and 0, 0, 0, 1. So this is the representation, and the second one will be represented comma 0, 0, 0, 0, 0, 0, 1, 0. So like this the array will be. So if I want to talk you about the raw data, so the chunk will be the buffer data will be stored in this format. So this is 4 bits and this one is 4 bits. Okay, and here it is 4 bits and this one is 4 bits. So I was trying to explain you that, so this chunk, this buffer will be using the encoding format UTF-8. Here 8 means each character. Okay, so you need to understand each character will be represented using the 8 bits. Okay, so if you are having 1, 2, 3, 4 something like this, means then each character will be represented with an 8 bits. So if you are having 32,810 means, so each one, this one will be stored in 8 bits, 8 bits, 8 bits, 8 bits, 8 bits. Okay. So now this is how you will be having. Now there is no way that in the buffer, so we are using the UTF-8 format, and also the buffer inside the Nodejs, it will be using the Unit8 array. Okay, it is a Unit8 array. It is a special type of array which stores the 8 bits of data. That is nothing but zeros and ones. So now here think that, so there is no way to split these two. So for example, let's say that it is having an index of 0, 1 and 2 means, so either 0, 1 and 2 will be splitted, okay, or otherwise 0 will and 1, 2 will be splitted. There is no meaning that half of this 2 will be splitted, something like a 1 and half. There is no meaning. That means, for example, let's say that this 2 means, so it is something like 4 zeros and 0, 0, 1, 0, right? So don't think that the chunk will be divided in between this one. The chunk will be either divided here or either divided here. So that is one thing you should understand. So if you are taking Unit4 array means, then it will be divided. So if you are using UTF-4 or ASCII, something like that, any other whatever it is, 4-bit saving means, then it will be divided. So that for those type of things we need to put a lot of effort to add those things. So you need to combine that values, and you need to do it, append those values and all those things. So that is the thing. Okay. So now let's say that imagine you are having a reading a numbers from a file. So these numbers could be something like let's say that you are having 1, 2. So here you will be having 1, 2, 3, so on you will be going, and here you will be having a 32,182. Let's assume that. Okay, I told you that this one is an 8-bit, 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 and also this one is an 8-bit. Each character is a 1 byte. Let's assume. So 1 byte means why I am trying to tell you is 1 byte means nothing but an 8 bits of data, 8 bits of binary data. So now at the last chunk by this 32 thing, so here 65,000 I am trying to tell you, right? 65,000 bytes. Okay, 65,000 bytes means, if you want to convert into a bits means into 8, try to make it as an into 8, then it is around 63 million bits. Okay, so now each chunk will have a 63 million bits. That is nothing but it is equal to the 63 million zeros and ones. So from 1, 2 and 3, if you go on to 32,000, so let's say that up to 32, each one is a character, let's assume. So up to 3 or 32, the 63 million bits has been completed. And what will happen? So up to here it will not care, the stream will not care about this complete number. So each one it will treat it as a separate character only. Okay. So the data comes in chunks. These chunks are buffers, array of bytes. So now, and the next chunk may contain, and this chunk, the next chunk, whichever the chunk you are getting it. So let's try to remove this one all. Let's assume that, so the first chunk of data you will be having in such a way that, so 1, 2, 3 and going on, it will be having 32. Okay. So here you need to have 182, right? In the next chunk of data you will get that 182 and comma, and you will be able to get all the remaining numbers. So here also you will be able to see the 64, and here you will be able to see the first value will be 370, like that it will go on. So here the last number and the first number is the combination. Okay, you need to understand here. So 32 and 182 are not separate numbers, they are parts of one number. So if you combine these two, 32,182, so we just split a number in between the two chunks. So now this kind of split can happen anywhere, start, middle or end, and unless we fix it, our program going to misinterpret the data. So let's go deeper and understand why this. When you're reading from a file, the stream gives you chunk based on the buffer size. I told you, right? The 64 KB. So each character is an 8 bits and each chunk is just a set of bytes. So the stream does not know or care if it's splitting a number in half or not. So that is the main thing you will be having. Okay. So now let's so why is happening? So Node.js, normally the buffers are actually Unit8 array of 8-bit unsigned integers. So that's what I am trying to tell you. And here if you are having a buffer, let's say that if you are having a buffer means, So now here you are having a buffer, so 1 comma 2. So let's say that this is a buffer means, so how the buffer will be saved is 0 0 0 0 and 0 0 0 1, and here 0 0 0 0 0 0 1 0. So this is the buffer. So in the buffer, instead of showing this all the binary digits like this, it will show it in a hexadecimal format. Okay, so 8 bits, so it will show it as in 2 hexadecimal digits. So that is the reason you will be able to see. So this one will be buffer, it will write it as in buffer and arrow mark, and 4 digit, this one comes with the 4 digit, and this one comes with the 4 digit, there is nothing but 1, and here also 4 digit, and this one will be around 2. Okay, so this is the buffer which you will be able to see. So this is how it will be displaying you. For example, if it has a 1 here, means the first 4 digits it will become 1 and 1 2. So each ASCII character is also 1 byte, that is 8 bits, and each buffer element is also a 1 byte, that is 8 bits. Streams send chunks of these bytes, but they don't guarantee whole logical units like numbers. So a number like 32,000 could be split into 32 in one buffer and 000 in the next buffer. So that's it. So now, so how we can fix this one? So now what I want to tell you about this one is, so now what we need to do it is, so here we need to check in our code that, let's say that we are having a 1 2 and going on, okay, here having going on 32 is there. Okay, and here you will be having another one, something like 182, and come like this, it is there, right? So first of all, we need to check in our code that, so we need to, last element we need to take and we need to keep it as an leftover or splitted. Okay, split, the split in the variable we need to add it, and we need to check that after the next chunk when it is coming, we need to check that the first element plus 1, it is matching with the second element or not. If it is matching, means that no splitting has been done. If the splitting has been done, means the leftover chunk which we have got it from the first chunk, the number which we have got it from the first chunk, we need to append that one. So these are all as a characters we will append this one and we need to combine it. So that is the thing which we need to do it. Or otherwise here also you can check it, the number, the last number which we are having it, subtract -1 and we should get the previous number. If we get the previous number, means then this last number has not been splitted. If we are not getting last one, means then the number has been splitted, so we need to add the number. So this is how we need to check the code. Leftover captures any split number at the end. On the next chunk we need to prepend it to the beginning. So that is the main thing which we need to do. In this way we guarantee that every number we process is whole and never accidentally split across the buffers. So that's it, guys. So before wrapping it up, streams read in bytes, chunks of data, characters are 1 byte, UTF-8, buffers don't care about the logical boundaries, you need to manually manage the split data to chunk edges. So but now you know exactly how to do that one. So if you found this one helpful, don't forget to like the video, subscribe to the channel and leave a comment with any questions. Want to see how to filter the this one all even numbers, we'll try to do it. Thanks for watching. I will see you in the next one. Hey everyone, in today's video we are learning how to extract only the even numbers from our huge file containing the numbers, and also we will try to manage the back pressure, optimize performance and all those things by using the readable streams. We'll implement it. So let's say you are reading a large file that contains numbers. So we are reading a large file that containing number. Each number is separated by a space. Now here is the catch. So when reading this file in chunks, a single number can get split across 2 chunks. That's what we call a character split issue. So that one also we have learned. Why the characters will split also we have seen it. Because each character is an 1 byte, that is nothing but 8 bits. So if you are having a chunk size of around 64 KB, so if you are having a 6-digit character, so 6 characters are there in one chunk, means so you can split it, can get split in 3 or 2 4 something like that, it gets split. So that's why we need to catch that last number and we need to combine it with the first number in the second chunk, so that we cannot miss any numbers. So let's try to implement that issue. So we add the leftover split here, okay, chunk at the beginning of this. So now what we try to do it is, so we got the numbers So we have learned about this one all. So where the split is happening, let's try to check it. So first of all, what I would be trying to do it is, so we are able to get the data. So now we got the numbers. Okay, so we got the numbers. So let's try to implement this number. So first of all, let's get the first number and also a second number. So here what I will be trying to do, constant first number. So first number means nothing but you will be having in the numbers of 0. So that is the main thing. So this is all, it will be in the characters. I am converting into a number, and I will be having the second number. Second number is equal to plus numbers of 1. So we got the first number and second number. So how we can able to know that the first number is not the actual one, it has been splitted or not? So how can we able to know it is, if first number plus 1 is equal to second number means, then we can able to understand that that number is not splitted. So if it is not equal means, then we can able to understand that it is splitted. So let's try to understand. So now here we can have another one also, constant last number, okay, is equal to numbers of length minus 1, numbers dot length minus 1. And also here I can do constant second last number. So I can also have a second last number and plus numbers of numbers length minus numbers dot length minus 2. So these are the last number and second last number. So what we need to do it is, so first of all we are having a chunk of data, let's assume. So let's try to, I will try to show you in Paint so that you can able to understand it clearly. Let's say that we are having a chunk of data 1, 2, 3, going on, you have a 32, okay, like this in first chunk. So this is total number of 32,182. So here you will be able to get it 182, and here you will be giving 32,183, like that it will be going on the thing. And here you will be having 32,181. Okay, so the first chunk will be delivered the first time. So when you are trying to get the data from the stream, the first chunk will be delivered, and I am taking the last number and also the second last number, and I will try to do it last number minus 1 is equal to second last number means, then the split is not happened. If the split is happened means, what I will try to do, I will try to remove this one and keep it in one variable. The last number I will keep it in one variable, that is, let's assume that it is a split. So after keeping the value, so this entire thing I will try to calculate the even numbers and all those things, finish. So this number is kept aside. So I will be removing this one from an array. Next, when we got the second chunk, okay, I will try to take the first number and I will try to check that whether this first number plus 1 is equal to second number or not. If it is not equal means, then we can able to assume that this one has been splitted. We already have the splitted value from the previous chunk. So I will try to append these both the things, okay, and I will replace it here with 32,182. So in this chunk only I will try to try to add it, and here the last chunk also I will try to check it and I will remove it and I will add it in the split. So like this it will be going on happening. So now what I want to do it is, first I need to take this one and I need to add it. I need to pop that one. So let's go here. So here I will be going into this one. So the last number we are trying to do it, right? So if last number minus 1 is not equal to second last number, okay, if it is not equal to second last number means, then what I need to do, so then what I need to do, split is equal to, so I will be having a variable here, let split, okay, let split is equal to empty. I will be having it like this. And here what I would be trying to do it is, so here the last number is this one only, right? So here you can have a numbers dot pop. So I am removing directly numbers dot pop. So I am removing it directly, and I will add that split is equal to last number. So I will add that number. That's it, finish. So we got the split, okay. So before we got the split, what we need to do, we need to calculate the first number also. So the first number means, so we need to check in such a way that if first number plus 1 is not equal to second number. So if it is not equal means, then first number and second number is not equal. So then if you are having a split means then you need to combine the first number with the split and you need to add them. So here you can add in such a way that if split is there, so you need to check that if split is there, the first time you will not have a split. So that's why I am trying to tell you. So numbers of 0 is equal to, so here I can do split dot to string. So I will convert it to string and I will use the trim, okay, plus, so here I will add, or otherwise there is no need to add this one, and here I can use first number. So the first number which we are having dot to string dot trim, okay. So this is the method which we are having it. That's it. So now we got the number also got added. So now what I need to do, I need to capture the even numbers for this one. So here once this one is finished, so here I will do numbers dot for each. So you can use whatever the thing you want. So numbers dot for each, and here I can check that if number mod 10 is equal to 0, then what I can do, so I am taking only the 10 decimal number. If not of stream right, if not of stream right dot right of, so we need to write the value. So here I can use something like plus, and here number plus I am adding the gap actually. So if it is not equal to, then I will do stream read dot pass. That's it. So that's it. So now what we are trying to do, we are calculating the, we are taking the first number and we are adding it if it is split is there means, and we are removing that from the last number. So that's it. So now if you try to check it, so I am using the test.txt, and here if I try to check it, the output, let's try to check this output. So here let's go into this one and we will be having let's say that git repair markers. Let's try to check it. Somewhere we'll be having open in, yeah, open in Explorer. Let's go to the Explorer and I will open the command prompt for this one. Let's go to the readable. Yeah, I will open the command prompt. Oh. So I have opened the command prompt. Is it opened or not? It's taking some time. Let it take. So it has been opened. Now what I want to do, so here let's try to write node read big.js file. So now it has been converted. Now if you try to check the destination file, so let me open this destination file, show more options, open with, where is this open with, sorry. So here I can have open with, and here I will try to open in the Visual Studio Code. Let me open this Visual Studio Code. If you try to check the output for this one, so all the values are nothing but ending with 0. So that means we are only getting the values which is divisible by 10 only. So if you try to write it with the 2 means automatically you will be able to see the 2 value. So for example, let's say that if you try to change the value that even numbers means, so here I can write that if it is mod 2, okay, then you will be able to get the node read big.js. So now it is taking some time to write it. Yeah, fine, it has written. Now if you try to take cat destination.txt file, so now here you will be able to see 584, 586, 588, 590, 592, 594. So we are able to get only the even numbers. So now from the huge file also using this stream thing, so you can able to extract only the desired even numbers. So this is how we will be splitting the values. So that's it guys about this one. So before we run this one, so like this we need to do it. So after running your script, what we need to do, we check the output file, all even numbers are not, we check the file size. So we'll check the file size also. So here this one is around 3.7 MB and this is 1.85 MB, exactly the half is there. So that is, this is also proves exactly as expected. So now what we have done, so if you want to check the timing also, you can check it, so it's not a problem. So here what we have read, so now here you can write console dot you can take console dot time, oh sorry, console dot time finish. Let's try to take it. Let's see how much time it is taking. So when that everything is completed on drain, so here stream read. So when the stream read dot on off end. Okay, so we are not, so stream write dot on finish will not be, event will not be fired. Why? Because we are not we are not using the stream write dot end. We are writing stream write dot write. But when we are using the stream read dot read, so here we are using stream read dot on data, right? When the stream read entire thing is finished, end will be fired. So here you can use this one directly. So control dot time end. Now if you see CLS, so now you will be able to get the total time, how much time it has been. So 1.796 seconds it has taken. So this is how you will be implementing this one. So now what we have did, everything you have understood about this one, how to extract the event numbers from a set of file using the streams, and also both readable streams and also writable streams. If you found this useful, smash the like button, subscribe for more development content, and let me know in the comments what you are building with the Node.js. So catch you in the next video. Fine, bye. Hi everyone, welcome back to my channel Leela WebDev. In today's video we will see about the readable streams, the Node.js documentation, what it has given. So now we have already explored the writable streams, right? And now it's time to complete the readable streams also. So now here let's try to open the Node.js documentation, what they have given. Let's try to see. Let's go to the docs. So now here we need to go to the streams. So here this is the streams, and we have completed about the writable streams. Come down. So these are all the properties we have seen, and now this is the readable stream. So here you'll be able to see the readable stream about this one. So now readable streams, just like the writable streams, these are the way to handle the data efficiently in chunks. They allow us to read the large files or responses from HTTP servers without loading everything into memory. And depending on what you are reading, files, HTTP requests or response, the readable stream behaves like a little differently. So here you will be able to see the HTTP responses on the client, whereas the writable streams you will be able to see the HTTP responses on the server. The same thing. So read streams like this, in all these places we will be using the readable streams, they are saying. So now the interface is defined by the stream.readable class. So normally if you try to see, there are two reading modes, it seems. For readable streams there are two reading modes. So what is this reading mode? So two reading modes, that is nothing but flowing and also paused. These are the two modes which you will be having. That is the main thing which you need to understand. So readable streams in Node.js have two modes, paused mode and also flowing mode. By default all streams will be in paused mode only. So that's why when you create a read stream, it will be in the paused mode. So here somewhere they will be writing in flowing mode. So these modes are object mode, readable stream, regardless of whether it is flowing mode or okay. So all readable streams begin in a pause mode, but can be switched to flowing mode in any one of the following ways. So that is the thing. In paused mode, so if you want to read the stream reading method must be explicitly to read the chunks of the data from the stream. So now if you want to switch from paused mode to the flowing mode, so we need to add a data event handler. So just like how we have added, or otherwise you need to call the stream.resume method. This one also we have seen, and we need to call the stream.pipe method to send the data to a writable stream. So we haven't learned about this pipe method, so I will try to explain you about this pipe method in our upcoming videos. Just keep it aside for the time being. So these are the three ways which the readable stream will be converted from the paused mode to the flowing mode. By default, when we start a readable stream, it will be in the paused mode. So the readable stream can be switched back to the pause mode in any of the following ways: by calling the stream.pause mode, or otherwise you can remove by calling the unpipe method. Okay. So the only way which we know is the paused mode only, which we have seen it. So when the stream is flowing or when the stream is coming, we are reading the data. So if you want to stop the data from reading, means we need to call the stream.pause, which we have did it. If the stream.write returns false. So now this is all they are trying to give you about this one. So if a readable switch is switched into flowing mode and there are no consumers available to handle data, the data will be lost. This can be occur, for instance, when the so this is all common. So now they are trying to tell you. And the another one which they are telling is there will be 3 states for a the 2 modes of operation for readable stream. So there will be 3 states. One is the readable flowing. So if you want to get this property, means it is telling the readable flowing null means it hasn't started. Readable flowing, if it is false, means so it has been flowing but it is paused. Readable flowing true means it is flowing. So here you will be able to see the readable flowing is null means no mechanism for consuming the stream data has been provided. So that means any of the 3 ways, something like data, stream.resume, stream.pipe. So nothing is provided, so that's why it will be in the null. So therefore the stream will not generate data. While in the state of attaching listener for the data event called readable.pipe method or so something like this, these all means then it will switch from readable flowing to true. So then it will convert to true. Why? Because flowing state is, or otherwise if you have paused that one means then it will be false. So that's the thing. So this is what they are trying to tell you, and they have given some simple example. So here you need to understand another one. So while you are writing the readable streams, you need to choose only one API style. So what is this one API style? Either if you want to read the data, you need to use the on-off data event or on-off readable or pipe or async address. So this is the thing. So any one only you need to use, on-off data or on-off readable or pipe or async. So using a combination of these all the things, if you try to use it, means then it will lead to a initiative behavior. So it will not be expected as expected. So that is the main thing. So the readable stream API evolved across multiple Node.js versions and provides multiple methods of consuming the stream data. So choose any one of the method of consuming data, or you should never use multiple methods to consume data. So here you know about this on-off data. On-off readable is also same like this event only data. We'll try to see it down. And pipe we'll learn about this one, or async iterators. This is the thing. So here the readable methods and events and everything is derived from the readable class. Let's try to see. Close. The close event is initiated just like the writable stream. Whenever the file descriptor has been closed means then this close event will be fired. Data event you haven't seen. So whenever you want to read the data means that you need to emit this data event. So then only you will be able to get the data. Attaching you need to attach a data event listener. So then you need to read the data. End. So when the read stream has been ended means this end event will be emitted. So then you can attach this event listener and you can able to get the data, execute the logic. Error means if any error occurs in the readable stream means then this event will be fired. Pause. The pause event, this one is emitted. This pause event will be emitted when you call the stream.pause. So when we will be calling the stream.pause, then this pause event will be emitted. So this is the readable event. This readable event is emitted when there is a data available to read from the stream up to the high configured high watermark. So normally the readable stream, the high watermark is 64 KB. So when the data in the internal buffer reaches 64 KB, then the readable event will be emitted. So then you can able to read the data. So this dot read, if you want to use it means then it will be reading the data. So that is one thing. So if the end of the stream has been reached, calling stream.read will return null and trigger the end event. So now that's it. That's it all. So the resume event, you know about this resume event, and destroy event. So destroys the stream. So here closed. So it will return true if it is closed or not. Destroyed means if it is destroyed or not. Is paused means if it is paused or not. Pause means you can pause the stream. Pipe we'll try to see about this one. So you can apply pipe only to a readable stream. So you cannot apply to a writable stream the pipe thing. So when this will take the destination will be always a writable stream. So when you use the readable stream dot pipe of writable stream means whatever the data is coming here, everything will be written in the writable stream, handling all the back pressure and everything will be taken care by that one. So there is no need to write all the code which we have learned up to now. So that is the main usage of this pipe. So always the pipe should be applied to a readable stream only, or duplex stream or transform stream also you can use it. Just I am trying to tell you where the duplex stream is a combination of both readable and writable. So I will try to I will explain these all the streams in the upcoming videos. So now here we will try to see about this one. So now here we will be able to see something like readable dot read. Okay, we haven't seen this one. Now the read means nothing but it will read the data from the internal buffer and return it. If no data is available means then it will do like that. So you can practice this all the things, so then you will be able to understand. If you practice these all the things, then you will be able to understand these all things. Readable, so these are some experimental things. So here you will be able to see some readable length, readable high water mark, and these all the things. Resume and set encoding. If you want to set the encoding, these all the encoding. So these are all unpipe. If you want to remove the pipe means you can use the unpipe. Unshift, this is in the old Node.js version, we will be using this one. So these are all methods. Okay, wrap. So these are all methods which we can use it. Okay, so these are all experimental thing. So which are coming in the experimental. So map means, so you can in the chunks, whatever the chunks you are getting in the thing, you can filter over this one, which we have applied the filter, right? The same thing you can apply over the chunks which we have applied. This for each loop we have applied it, right? So you can apply the filter or map. These are all the things you can apply. So this is all for each, we have applied the for each loop, so which we have seen it. So these are all just how we can see it. So these are all that some means it will stop immediately if the stream if the match is found. Fine. These are all array methods only which you will be able to see. Flat map. These are all experimental mode which you are getting. So still it is in the stability, it is in the experimental mode only. Reduce. These are all array methods. Whatever the array methods are there, they are applying it. So this is basically the readable stream. So almost all the things we have completed it. We have covered in our readable stream thing. Hope you understood about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. So now let's try to, in this tutorial, what we'll try to do it is, we will try to implement or otherwise copy a file without using the streams. And then we will try to implement using the streams, not Node.js streams. We will try to implement our own streams. So that means implementing our streams. Up to now we have consumed the streams. Now we need to implement our own streams. How to implement it? So before implementing our own streams, so how we can copy a file in the Node.js without using the streams, let's try to do it. So I will try to explain you this one in this video. So that means in this one we will learn how to copy the files. But what is the twist? We are going to do it without using the streams. So in this video we will walk through reading and writing files in a naive way. So that means in a primitive way we will try to see it. Running into some serious memory issues, understanding execution time versus memory usage, and wrapping it with some golden nuggets on algorithm complexity. Let's try to do it. These are all the things. So first one, what I will try to do it is, so here we are having a simple thing. So let's try to open the copy. Oh sorry. Let's try to close these all the things. Okay, I will try to close these things. Let me close. So here I will be creating in the streams, I will be creating a new folder that is nothing but copy. Okay, in this copy folder I will create a new file that is nothing but copy.js file. So just we need to copy so one file from source file to the destination file. So for this one, what we will try to do it is, so now also, so we will either use a small text file or paste a bunch of text to make it little bigger. For now, let's keep it reasonable. So we'll try to copy let's try to take a simple file that is nothing but what we can say is in writable. So we will be having a text file, right? So now let's try to copy this one, okay, and paste it here. I'm pasting it here, test.txt file. So I have pasted it here. Let's try to close it. Let's see how much file size it is. Streams in the copy, if you try to check it, test.txt, it is around 3 MB I am thinking. So let's check the properties for this one. So if I try to check yeah, it is around 3 MB. So it's just a small file. I am copying this one. So let's go into this. Okay, so now let's try to write the code. So here I will be constant fs is equal to require of fs/promises. So I will be using this one, and I will be using the AF function that is nothing but immediately invoked function async of like this, and here I will write it like this. Now let's try to implement it. So now here I will create a destination file. Destination file is equal to fs or otherwise await fs dot open of, so here I will write destination file, or otherwise text-copy .txt, and I want to open this one in a write mode. So this is a simple way how we can do it without using the streams. Now read the source file. So here I will be using constant result is equal to await fs.read file, and in this one what I will be trying to do, so I need to copy the test.txt file, okay, which is of around 3 MB. So now here what you will be trying to, I will try to explain you this one all. So now here what we will do here, so what we would be trying to do it is, so here I will try to copy destination file. Let's try to see the console.log of results. So what would be the output for this one? Okay. So now if you try to see the console.log of result, so here we are using the read file. If you try to use the read means, then it is different thing. It will use the, no, so if you use the fs.copy, so you can say that simply copying from this to this one, right? We can use fs.copy. So don't use that fs.copy. Why? Because that fs.copy still uses the streams behind the concept. So that's why we want to implement the concept without using the streams. So that's why I am doing this scenario. If you use fs.copy means that one behind the scenes it will use the same stream concept only. So that's why. So let's try to see what could be the output for this one. So let's go to the copy, cd copy, and here I will write node copy.js file. So here the read file has given you completely 38844 something like that bytes of data. So that means the complete data is written as a buffer. So now what we need to do, so we need to write that buffer in the destination file. So that means here I can say that destination file dot write. Okay, so write, it will take the buffer. So here I can do the result. So directly buffer you can write it, and here I can use the await. That's it. So now if you try to do the code for this one, so immediately the file has been copied. So here what we have did, so first of all we have used fs.promises to work with the files asynchronously. So this is the concept. So first we open the destination file we are writing, then we read the source file using the fs.read file. Finally we write the destination to the finally we write the result to the destination file. So that is simple, and it works this one like this. So now if you run this, now here we have just once this one we have just copied the file. That's it. So now let's talk about the real world usage. So this approach reads the entire file into the memory at once. For small sizes like test.txt or something like that, this is fine. But what happens if you try to something bigger? Let's say we have a file something like a big file which is around 10 GB or 5 GB more. So what will happen? Let's try to see it. So 5 GB or 10 GB more file we have in our let's say streams in the readable. So file hyphen huge, I think it is around 5 GB. So let's copy this one and let's go to the copy, and I will try to paste it here, file hyphen use, and it is copying. So now let's try to copy this file hyphen use which is around 5 GB. So let's try to copy this one. So go into our here, and here I want to change it to file hyphen huge.txt file. So let's try to run the code. So now if you try to run the code, boom, so we got an error. So it has crashed with an error like file size should be greater than 2 GB, and even if it doesn't crash, your RAM will suffer. Let's test the next one. So now what we need to do, it is telling that the file should not be greater than 2 GB. Okay, so fine, let's try to take it file which has an 1 GB file. Let's go to our streams, and in the writable, so we have a file which is around test-1 GB, which is around 1 GB of data. So let's try to copy this file 1 GB. So let's copy this file and go to our code, and here I want to do test-1 GB. Okay, test-1 GB.txt file. So this is the thing. So now we have updated it, and now here what I want to do it is, so next I want to do console.time of copy, and I will try to do console.time end of copy. So I will try to keep these two things. Okay, done. So now fine, so let's try to copy this one. So now if I try to copy this one, how much time will it take? It has to cover something. Oh, it is taking so much time for me. Let's try to see it. So it took around 4 seconds to copy the file. So let's try to run it again. So if you try to run it again, let's try to see it in the activity monitor what it is happening. See, it has went to 1 GB. So the memory has went to 1 GB. If you try to see it again, the memory has been went to 1 GB. It is going. So 1 GB it is going, and that means what it is doing. So it is copying the entire file into the memory and it is doing it. So fine. So now here, so what we have did, the problem with this approach is, okay fine, it is working, but it is using a lot of memory. It fails with the large files, and also it is not scalable. Even if it takes under 1 second or something like under 5 seconds, the space complexity is terrible. It takes about 1 second, the time complexity is less, but the space complexity is terrible. So that means it is taking too much memory. So as developers, especially in performance critical tasks, we should care about two things. One is time complexity and another one is the space complexity. Time complexity means how fast our code runs, and space complexity means how much memory it uses. Here the time complexity is 5 seconds, okay fine, so 1 GB file means that depends on your system, and the space complexity is taking is around 1 GB. So that's a linear complexity, something like big O of n in both time and space. Now if we copied a file twice as big means we need twice the RAM. This is often why we often refer to as big O of n notation. So big O of n means something like linear, big O of n square means it is quadratic. So like this big O of log n means logarithmic. So we use this to benchmark the performance of the code, not just for interviews, but to write better, faster and learning software. So fine, so that is all about the theory. So just I want to tell you, so if you want to learn more about these algorithms and data structures, means as a developer, as a programming skills, in order to improve your programming skills, these things are must. So these algorithms and data structures, these concepts will teach you how to write efficient code, how to manage your resources better, how to analyze the trade-offs in performance. So that's it guys, what I want to explain you about this concept. Without using the streams we have did it. What is happening? It is doing more tasks, okay. So it is taking more memory, and also it is taking the space, the time complexity also. It's fine that one, but the space complexity it was terrible. So that means what at the end of this session, what I want to tell is, yes, you can copy the files without streams, but it is not ideal for the larger files. Your RAM usage explodes. It crashes beyond 2 GB. If your file is about 2 GB means it crashes. Always consider the space and time complexity also. In the next video, what we will try to do is we will try to achieve the same concept by implementing the streams on our own. We will not use the Nodejs streams. We will try to implement our streams on our own, so that we will be implementing our own streams. That's it guys. Make sure to like, subscribe and hit that bell icon so that you don't miss these all important concepts in the Node.js. Let me know in the comments, have you ever run into memory issues like this while working with the files? So drop your thoughts or questions below. See you in the next one. Happy coding. Hey everyone, welcome back. In this video, we are going to build our own mini streaming system in the Node.js, but without using the built-in stream module which is available in the Node.js. But we will manually read a file chunk by chunk, write it to another file, optimize the memory, and even handle the gigabytes of data like a pro. Let's jump right in. So normally when you read a file using fs.read file, okay, so here what you're trying to do, you are loading the entire file into memory. That's fine for small files, but something like 10 GB file means it's a disaster. You could crash your app with memory overflow. So what is the solution for this one? The solution is nothing but streams. But what if we want to build our own version of stream like behavior? So how we can do this one? So let's try to do it. Let's start coding our own stream like solution using just the file system module. First we will open a source file for reading and destination file for writing. So for this one, what I will try to do is I will comment out this code. So here in this one, I will create new one, that is nothing but async, and here this is our self calling file. Okay, done. And now in this one, first of all, what I will try to do, I will create I will open a source file for reading and also a destination file for the writing. So let's try to open the source file is equal to await fs.open, that is nothing but let's say that the source file, right? We are having a test.txt which is a small file, and this will be open for reading, and the destination file which I will try to open fs.open. Here I can do test -copy in the write mode. That's it. So now we are using the fs promises version to keep these things async await friendly. Now let's read a chunk from the source file using the read method. So here if you want to read it means, so here constant read result is equal to await. So here we need to do the source file dot read. So this is the method, and let's try to console.log of read result. Let's try to see the read result for this one. So here I will close it and I will run node copy, and here this gives us a buffer typically around 16 KB. It's not the whole file, just a small chunk. This is how we reduce the memory usage. So now the read method is returning you a buffer which is about 16,384, that is nothing but 16 KB. Now we need to loop over this process, read a chunk, write it to the destination, repeat until there is nothing left to read. So for this one what we can do it, so here let's go into our code. So try to remove this one, okay, and what I will try to do, so here we got the read result. So totally we got how much, 16,384. So if you want to get the bytes read means, so here you can use something like read result dot bytes read. So if you try to see it here, that is nothing but bytes read and buffer. This is an object. Now if you try to see, the total number of bytes it has been read is the 16,384. Okay, fine. Let's go here, and what I will be trying to do it is, so I will what I would be trying to do it is so now here what I would be trying to do it is, so let's try to do something like I will take the let bytes read is equal to -1, okay, while bytes read is not equal to 0, okay, not equal to 0. Then what I would be trying to do, so here I would be trying to take the constant read result read, and I would be getting the bytes read. So here I can do bytes read is equal to read result dot bytes read. So I will copy again, and here I would be trying to do that await bytes read dot write, not byte read, destination file. So I need to write in destination file dot read result dot not to string dot buffer. So the entire buffer I would be trying to write it. That's it. So now here we have written the code. So now let's go into our code, and here let's try to copy it. So it has been successfully copied. If you try to see the code here, this is the test.txt which is 3798, but when you try to see the test-copy, it is about 3824. So the file sizes are not matching. So now, so we have written simple and efficient. We keep going, we hitting whenever the bytes read is equal to 0, which means that we have reached the end of the file. So fine. Now if I try to open this one, what is the file size difference and all those things? So let's try to open with notepad, let's say notepad or anything. So I will try to open this one, and here I will be trying to see at the bottom of the file, okay, I will be trying to see at the bottom of the file. So here it is working fine. Let's try to open this one in our editor. Let's try to see what could be the issue in this one. So here this is the file which I would be trying to open, and here if I go to the bottom of this one, so here you'll be able to see a extra data, something like null is appearing here. So why it is happening here for this one? So you might be noticing weird null characters at the end of the file copy. That is because when we do the last read, the buffer might not be completely filled, meaning some of the bytes are just zeros. So for that reason, what we need to do, so let's try to console the bytes. Okay, sorry, let us console the buffer. So console.log read result dot, okay, let's try to read result it. That's it. So now if I try to copy it here, so here at the last you will be able to see all the bytes we are getting it as 0, and here also so totally we are getting 16,384 bytes, but here the buffer field is only 5,000. So that means remaining data everything is 0, and here also it is 0. So that means if the buffer is having some empty data, means it is filling with the 0. So what we need to do here, So we can get the read result dot buffer dot length. So if you try to check the buffer dot length, so here let's try to do the console dot log read result dot buffer dot length. Okay, so now here read result dot buffer dot length, if you try to check it here, let's try to copy it. So here all the time you will be able to see here the 16,384, the buffer length is always 16,384. so now here let's try to write it here. So what can I do for this one in order to clear off this one? So here, so this is the entire code. Okay, fine. Now what I would be writing to do it is, so bytes thread we got it. Now here let's say that here this is the thing. Okay, if bytes read is not equal to read result dot buffer length. Okay, read result dot buffer dot length, always it will be 16,384 only. So if it is not equal to this one means, so we need to get the index not filled. So index not filled is equal to index not filled. Okay, sorry, index not filled is equal to read result dot buffer not slice. We need to find the index of 0. So we need to find the 0 where it is there. So now we will try to create a new buffer. New buffer is equal to buffer dot alloc of the new, with the new memory I will be trying to create index not filled. So now here you will be having 5882, you will get the index. I am creating a new buffer with that memory size. So now what I will be trying to do, so here I will try to copy the entire thing, read result dot buffer not equal to, so here I need to copy only part of the buffer. So dot copy of, so I try to give the new buffer and up to from where to where it will fill 0 source index and 0, and the total number what you need to fill is the index not filled. That's it. So it has been copied, and here I can do something like, I will copy this entire thing and I will copy the new buffer into this one, or else part it will be something like this. That's it. So now here what we have, we only write the meaningful part of the buffer, no trailing nulls. So let's try to test it. Let's test it out. So now here I will try to run this one. So entire thing has been copied, and if you try to see the file size for this one, so here if I go here and show more options and refresh this page, so we are having test and also the test hyphen copy. So why it is not getting copied again? Bytes read is equal to this one, when bytes read is not equal to here, and read result dot buffer dot index of 0. Okay, destination file. Let's try to open this test hyphen copy and let's try to see the trailing slashes is there or not. If I try to open and if I go down to this one, okay, still trailing slashes are there. So what could be the reason for this one? If bytes is not equal to, if bytes read, so this is the only thing, right? If byte reads is not equal to read result dot buffer dot length, okay, then constant index not filled buffer dot index of 0. So here I am filling it, and read result dot buffer dot copy, and here, oh sorry, here I need to use the new buffer. So here you should store it in the new buffer. So this new buffer I need to use it. So this is the mistake, my mistake only. Let's try to see it here. Yeah, if I try to copy and if I see the here, so it is exactly the same. The file size now it has become exactly the same. So what will happen here, the thing is, so if you try to take it anything, so something like you are having this one, right, file hyphen huge, if you try to take that one also without any problem, the file will work. So here if I try to take it as source file hyphen huge, so not a problem, not at all, it will be a problem, it will not throw any error. So it will try to read it, and if you see the activity monitor also, so it is taking around, memory is around 12 something like that. So the memory is also efficient. So now here when we run the script, the copy is successful and clean, no weird characters, nothing we are having. When we copy text is about something like it will take around 30 MB of memory, maximum 20 MB it is taking in our thing. So that's a huge win compared to the loading. So the traditional fs.read file method is faster but uses too much gigabytes of RAM, not scalable. Now let's we have tested with our file huge thing, which is about 5 GB. This might take us few seconds, but again memory stays at around less only, so 17-20, maximum 20 KB it is taking. So that's a huge accomplishment. So that's it guys about this one. So it will take some time depending on the system. So my system is slow, so that's why it will take so much of time. So we have just created a custom stream like system. We don't push data into memory and then pull it out like node streams, but the concept is same. And then, so like node streams, but concept is same. So we read a small chunk, we write it and we repeat until it done, all without blowing up our RAM. Of course, this is a simplified version. In production, you should wrap everything in a try-catch blocks and handle errors properly. But the takeaway here is, you don't need node streams to build something powerful. Sometimes a bit manual control goes a long way. That's it guys about this one. In the next video, we will do the same thing using the Node.js streams and see how piping can make this even easier. So make sure to subscribe and hit the bell icon. Thanks for watching. Drop a comment if you want the full code or have any questions or something like that. Don't forget to like, share, and I will see you in the next one. Happy coding. Hey everyone, welcome back to my channel Lila Web Dev. In this video, we are going to take a deep dive into the Node.js streams. Especially what we will try to do is copy files using the streams and piping. So we will walk through the concepts like flow mode, memory usage, execution time, and also what really happening behind the scenes when you use the pipe method. So let's try to understand this one. So previously we have manually read the file using data event. So using this, what I want to say is using these all the things to write the stream. So previously we have did it using the data event and all those things, right? So when you try to use the write mode, I will try to open that one. So here we will be having write mode. Yeah. So this one we have used using the data event and we have did this one all. Okay. And read mode also we have used the data event and like that. So that approach works but requires us to handle memory pressure, back pressure, pause, resume logic. It gets complex. So when you are trying to write these all the things in the readable stream or something like that. So whatever the things we are trying to do, those all the things. So here we are concentrating on the drain event, end event, and also the data event. Everything we are taking care of that one all. So everything we are approaching this. So now let's simplify all of this using the Node.js built-in pipe method. So for this built-in pipe method, so what we need to do, let's try to do it. So here we have did this copy thing, right? So this entire thing we have used our own stream without using the Node.js streams. We have implemented the streaming architecture. So instead of using that one, we will use the Node.js streams, but we here we will use the pipe method. So I will comment out this entire thing. Okay. And here the same thing I will try to implement it, but this time using the Node.js streams and also that too pipe method. So here I can use something like the same thing, async. Okay, I will call the self method. So that's it. So now here first of all we will create a read stream. That is nothing but what I can say is, so constant read stream is equal to, so you can create it like anything. So fs dot create read stream. Oh, we don't have an fs or what at the top. So we have an fs. Okay, it needs to have. So fine, let's try to create a source file. Constant source file is equal to, so that is nothing but what I can do it is await fs dot open, and I want to open the source file, that is nothing but test.txt. so let's say that test.txt, and I want to open it with a read mode. Same thing. So what we have did it here, where is this one? Yeah, I will try to open the source file and also that's the destination file. Just I will try to copy and paste it here. Yeah, this is the thing I will try to do it. Fine. Now what I will try to do, so I will try to create a read stream. Constant read stream is equal to source file dot create read stream. So we have created a read stream, and constant write stream is equal to destination file dot create write stream. So now here we have created a read stream and also a write stream. So now instead of having the data event and all those things copying, so what you can do it is you can just simply read stream dot pipe of write stream. That's it. So now you can call only with just one line, read stream dot pipe of write stream. Node handles all the heavy lifting for us, reading, writing, pausing, resuming, and also managing the back pressure. You can only call dot pipe on a readable stream. So you should call the pipe method only on a readable stream, and the destination must be writable. So this must be writable. If you accidentally try piping into a readable, it will throw an error. That is one thing. So now you can chain pipes too. But if you are doing that, the middle streams must be a duplex or transfer, because they act as both readable and writable. So here it should be, so what I can do is, so here you can have a duplex stream, something like that, dot pipe of duplex streams or something like that, you can use it. Okay, but here the middle must be act as a readable and writable. So this is something. So you can chain all the writable streams also, you can chain it. So that is what I am trying to say. So now let's try to run this one. Let's see that whether it will work fine or not. So now let's try to benchmark this one. So here I will try to do node copy.js. If you try to see, the file has been copied. If you try to see here, the test-copy and this one is one and the same only. So now let's try to do some benchmarking. Behind the scenes, the pipe listens. Sorry. So we will try to use the console.time, that one. So here I can use something like here I will start stream copy. Okay. So here I will start the stream copy, and when this one is writing is completed, so when the read stream is end, then I will try to end the stream copy. Fine. Let's try to run this one. So now it has taken around 40 milliseconds. Now if I try to make it as an big file, so which is a test-1 GB. Okay, source file is test-1 GB. Let's see how much time it will take. So if I try to run this one, let's see the activity manager also. So it will take some time to copy. So here if I search for the Nodejs, it has taken only 6 seconds. So it has, let's try to take the node and try to run it again and see how much time it is taking, this activity manager. See, the Nodejs is taking around 20 MB only. So that means the memory issue and all those things has been solved. So now it has taken only 4 seconds. If you try to see the here, so it is exactly the same bytes it is having. So we saw speeds of around 4 seconds or something, with memory usage around 20 to 30 MB, a huge improvement over the non-streamed approach. But sometimes the test timing was inaccurate. Why? Because we measured the time before. So sometimes we will be able to get it. That depends all entirely on the system. So how your system is performing, something like that. So now behind the scenes, what it will happen is that the dot pipe listens to the data, writes to the destination, and pauses or resumes the stream automatically. We can observe the stream state using the readable flowing. For example, let's say that here you can have something like readable flowing. So we will try to use this one. So readable flowing. So now here you will be having an what I am going to say is null. So now it has been started. So if I will try to do the readable flowing. So if you try to see here, now if I run this one, so here null, and also next it is a true. So that means the first time it is null. So that means the readable has not been started. So that's why it is doing readable flowing as null. When it is initially it is null, meaning the stream is idle, and after piping it switches to true, which means it is in the flowing mode. So calling unpipe detaches the writable stream and pauses the reading. So if you try to do the unpipe, so for example, let's say that here I have unpipe read, and I will try to check the what I mean to say is readable flowing. So here calling the unpipe method on the readable stream, so pauses the reading. If you repipe again, it resumes. So if you try to check it here, the output for this one, so here it has been unpiped, false. So now if you want to start it again, so you can use this one again. So here, and again you can console.log of this one, so that it again turns to true. So this is the thing which I would be trying to do it. So first one will be in the null state. Okay. So then I am starting the thing. It will be in the true state. Why? Because it will be in the readable flowing. And again I have unpiped it. It will be in the false. And the last again I have resumed it. So it will be in the true. So this is how it will be happening. So if you try to see, the same thing. So null, true, false and true. So null, true, false and true. So the same thing has been happened. So that is the main thing. So these events are you. So here what I can say it is, so now, so you will often use the end to trigger the cleanup. So production consideration. One drawback of pipe in production is error handling. Errors on either stream won't be propagated unless you listen for them explicitly. So that means, so you need to listen for the read stream dot on off error and write stream dot on off error. So we need to write it and we need to handle the error manually. So you must manually destroy the both streams to avoid the memory leaks. So that is also one thing which you need to understand. So that's it guys about the stream piping concept which I would try to explain you. So to recap, pipe simplifies the file copying, automatically handles the pause, resume and back pressure, chains with the transform and duplex streams, readable flowing shows the stream state, use events like pipe, unpipe and like that. In production, handle errors manually. We should handle the errors manually. So now I hope that you have a solid understanding of piping with the Node.js streams. If you enjoyed this breakdown, hit that like button, subscribe and leave a comment. And if you have got any questions or want more deep dives like this. Thanks for watching. I will see you in the next video. Hey folks, welcome back to my channel Leela Web Dev. Today we are diving into the Node.js streams and discussing why you should stop using the pipe in production. So why we should not use the usage of this pipe in production, we'll try to see, and instead switching to something new better than the pipe is pipeline. So we also look into an older tool which is called pump, how errors are handled in the streams, and finally how to create your own custom streams like writable, readable, duplex and transform. These are all the things we'll try to do it. So let's see about this one. So if you have ever used streams in Node.js, you have probably seen this pattern. So like let's try to see this one. So yeah, here. So if I try to remove this entire thing, okay. So normally if you are trying to see this one, so normally what you will try to do, you will try to open these things. You will create a read stream and also you will create a write stream, and you will try to do read stream.pipe of write stream, so that the read stream, whatever the data is there, it will be copied into the write stream. So fine, this is fine for basic use, but here is the problem. What happens if an error occur in any one of these streams? So if any error occurs in the read stream or write stream, something happens is, then what we will try to do? So .pipe does not handle errors or cleanup streams automatically. So it will not do the handling the errors or cleaning up the streams automatically. It will not do it. If write stream emits an error or gets closed, read stream just keeps on going, wasting memory and potentially leading to leaks. So that's the thing. So here is the better way. Node.js introduced a new one that is nothing but a pipeline method. So let's try to see about this one. Let's go to the docs, and here in our let's say in our streams, so you will be having about the pipeline. Okay, so pipeline, yeah, here. So pipeline, if I try to click on this pipeline, so here you'll be able to see, so the pipeline, and here you'll be able to have a source, destination and options also you'll be able to pass it. So now here signal argument, and it has been history, it has been added in 15.0.0. okay, so now here pipeline API you will be able to see stream.finish. So this is the pipeline. So pipeline, if you try to check it, also supports a signal, and here the pipeline is there, pipeline streams callback. So this is the pipeline. So normally, so a module method to pipe between the streams and generators, forwarding the errors and properly cleaning up, and provide a callback when the pipeline is completed. So this is this method. It is used to pipe between the stream and generators, forwarding the errors. It will forward the errors and properly clean up. It cleans up and also provide a callback when the pipeline is completed. So that is the thing. So it has been introduced in something around added in 10 version. So like this, it has been added, going on added, supported for web streams also. So this method does the same thing as pipe, but it has a built-in error handling and also a cleanup. So for writing this code, so what you need to do here, the same code which you are trying to write it, the same code. So we need to constant So here you need to get it, pipeline is equal to require of streams. Okay, stream. So you need to get the stream I think, I don't know, I remember exactly. So stream, fine. So now you have created write stream and also you have created the read stream, right? So instead of using this one, so what you need to do it is, instead of using this one, so what you need to do is, so here we have used this end and all those things, right? So instead of using this one, so here you can use the pipeline of, so here you will be having, first one is the read stream, okay, and the next one you will be having is the write stream. So the next one will be a error handling, okay. So this is our error handling. If error is there means, then you can console.error pipeline, pipeline failed, and here you can write comma error, you can mention the error. Else means you can do console.log pipeline success or succeeded, something like that. So as you can see, we pass all our streams into a pipeline, whatever the streams are there. So in between this one, if you are trying to use it, it should be a duplex or a transform stream. At the end you should have a write stream. So in between, if you add a write stream, so this data will be copied into this write stream, and this write stream does not send any data, so this write stream will not be worked. So as you can see, we pass all our streams into pipeline, and it automatically wires up all the pipe logic plus cleans up if any streams fail. This is a must for production. If a stream crashes, like due to network hiccup or something like that, it cleans up and prevents the memory leaks. So that is main thing. So key point is automatic cleanup, error forwarding, and cleaner callback. So that is the main thing. So normally before we don't have this pipeline. So what we have used it is, we have used something as a pump. So pump is an npm package. So if you try to click here, pump, it has been developed 5 years ago, I think. So let's try to see it. It has been published 7 months back. Okay, so this pump is a module. Yeah. So here this is a small module that pipe streams together and destroys all of them in one of them if one of them closes. So here this is same thing only. Instead of using the pipeline, we will be using the pump, source and destination, and here you will be having an error. That's it. So now here when destination is closed, pump will destroy source. So this is how you will be able to have it. So before using this one, so we had to rely on a package called pump to handle this one. So the same thing, the pump also does the same thing only. Pump made things safer than pipe, and it is still used today. In fact, it has over if you are able to see 36 million downloads or something like that, you are having it. So 40 something around it you are having. So it is having so many downloads, this one weekly downloads you are having it. Fine. So now quick recap, what I want to do it is, so if you are using with the pipe, automatic error handling will not be there, automatic cleanup will not be there, but the native support will be there. Whereas for the pump, automatic error handling will be there, automatic cleanup will be there, and native support will not be there. Whereas for the pipeline, automatic error handling is applied, and also automatic cleanup is also there, and also there is a native support in the Nodejs. So there is one thing which I want to tell you. Another useful tool before closing I want to discuss with you is, that is nothing but finished. So we have seen it at the bottom only. We have seen one finished. I will try to show you finished. Stream.finished. So this one is also one of the important thing. So where is stream.finished? So now what does this one do? Stream.finished function from the stream module. It comes from the stream module. It tells you when a stream has been finished reading or writing or had an error. So that is the main thing. So that means you can use create read stream. So for this one, so here you need to provide readable stream or writable stream, anything. So when the stream is finished, it will tell you when it has been finished. So whatever the things you want to do it, you can do it. So here you can use something like this. So here you can use this one, and you can use the read stream, and here it will tell you, and this should be imported from the finished, and this should be imported from the stream. So here you can able to see finished. Yeah. So this is also one concept. So it will tell you when the stream has been finished. This can be useful if you are working with individual streams and want to manage cleanup manually. So that is the main thing. So now that is all about the thing. So this is all about the pipeline concept which I want to tell you. So next we will try to create our own writable streams. How we can create our own stream. That too writable stream, we will try to see it. So to wrap up things up. So what we have learned in this one is we have used the pipeline instead of the pipe. For old versions we will be using the pump package. So the finished thing also we have learned it. So when to for stream lifecycle management. So whenever the stream has an error or it has been finished, means if you want to do cleanup manually, means we can use this finished method. And we have avoided the memory leaks by cleaning up the streams. Understand when to use the writable, readable duplex streams. So that one all coming next, we will try to do it. So if you like this deep dive, hit the like button and don't forget to subscribe so you don't miss the next episode where we implement custom streams from the scratch. Thanks for watching, and as always, keep building awesome stuff. See you in the next video. Thank you. Hey everyone, welcome back to my channel. In today's video, we are diving deep into the Node.js streams again, but we'll be having a twist here. We are not just going to use them, we are going to build our own very custom writable stream from the scratch. Up to now we have used our the Node.js streams, but we will try to develop the own streaming thing. By the end of this video you will understand how writable streams work under the hood, how to implement one using the JavaScript classes. Let's try to see it, and how to handle important events like train and error correctly. We'll try to see it. So this one will be two sections in the video. So let's get right into it. So first of all, we'll try to set up the environment. So for this one, what I will try to do it is, so here I will create a new folder. So new directory. So this one will be a custom writable. Okay. So this one is a custom writable. And in this one, I will create a new file that is nothing but custom writable.js file. Custom writable.js file. So this is our custom file. Fine, done. Okay. So now what I want to do it is, so in this one, so this is our thing, right? To build a custom writable string, first of all, we need to import the writable class from the Node.js stream module. So here constant is equal to require of stream. So we are importing it from the stream. So here you will be having the writable. So not only the writable, you will also have a readable, and also you will be having the duplex, and also you will be having the transform. So these all the things you will be having it, but this time we are concerned only with the writable thing. So there are 4 primitive types of the streams in Node.js, as I already told you: writable, readable, duplex, and transform. So we will explore each of these things in the future videos, but now in this video we will target only about the writable string. So we are trying to write about the writable. So whenever you are trying to create a writable stream, so we will be having a file, and using that file handle we will create the writable stream using create write stream, right? So under the hood it will be using this stream only, but there we are using the FS promises and we are trying to do it, but under the hood it will require the streams and it will try to do it. But here I am trying to use the writable stream. Okay. So for writing your custom writable class, so first of all we need to define our custom class. So that is nothing but class file write stream. Okay, and this should extend the writable. So if you want to use this one, so we need to do it like this. So this is our first one. So here you need to have a constructor. Okay, so here you can pass the options. So here I will be passing the first one is the high watermark. Okay, so by default I can keep it as in 16 into 1024. And the second one which I want to pass it is the file name. Okay, so these are the two things. So we need to call the parent constructor, and we need to pass the options. That is nothing but high watermark. Okay, and I will store it in the variable this dot file name is equal to file name, and I will create a file descriptor also. fd is equal to null. So which on opening this file name, it will have a unique identifier, that is file descriptor. So if you try to open, the Node.js documentation, I will try to show you clearly. If I try to open a Node.js documentation, yeah. So here this is our API for stream implementers. So for example, if you go to the top, to the here, so we have learned about the writable streams, consumers thing, and also we have learned about the readable streams also. And here we need to learn about the duplex stream. I will try to explain you. So these all the things are also we have learned it. So duplex thing and all the things I will explain you. And here this is the thing, API for stream implementation. So first one we are learning about the writable stream. So this is our API for stream implementer. So we are trying to implement our own stream. So the node stream module, which I have shown you, the stream module is designed to make possible to easily implement streams using prototypal inheritance model. So here we have written our own class that should be extended writable, and here we need to have a constructor, so which you will be having a high watermark, and also the options you can pass it. So here we are passing the high watermark. First of all, a stream developer would declare a new JavaScript class that extends to one of the four basic stream class like writable, readable, duplex or stream. Make sure they call the appropriate parent class constructor. So that's it. So now we have extended our streams. So we should keep in mind what the options should be provided. These are all the things we need to do it. So now whenever you have created a writable stream, so right now we are targeting writable stream, right? So when you are trying to create a writable stream, so first and should you need to implement any of this one method. So write v or final. So the new stream class must then implement one or more specific methods depending on the type of string being created as detailed in the chart below. So that means here we need to create write one or more. So that means we need to create write ev final like this, either write or write ev or anything. So we need to implement any one of the methods or all the methods. So for reading and writing means we need to do it all these things. For right now we are concentrated on this one. So let's try to see. So the implementation code for a stream should never call the public methods intended by used by the consumer. So I will try to show you this one. So you should never call these events and all those things. I will show you these all the things. I will try to explain this one. So that's it. So now we have created our constructor. So in our code, if you try to see, we have created our constructor. So we have sent the high watermark. So that is nothing but the maximum size of the internal buffer for the writable stream. And also we are sending the file name, so which we are trying to store it in our property. So fine. So the second thing which I want to tell you is that, so a few things must be remembered to note when creating a custom stream class is, so we need to use the super method to call the parent constructor. So I told you, right, don't manually emit the built-in stream events like drain, error or finish. So these are the things we have learned. If you try to check it on our thing, so if you try to check it, so here in our code, in the writable, if I open this write more.js file, so here we have used this drain, finish, these all the events comes under writable streams, right? We should never call these things in the built-in streaming events. Like in this class, you should never call those drain, event, error or finish these things. And also we should not override the write method. So you should not write this write method directly. Instead of this one, we should write the underscore write. I will try to show you that one. So the write method, we should not directly override the methods like stream methods will be there, right? Stream.write, stream.end. These things we should not override it directly. Instead of that one, we should override using the underscore write. So these things I will try to explain you. So these are the main things which you need to consider while we creating our own streams. So implementing the construct method. So the next one which I would try to explain you is the construct method. So for many simple cases, it is possible to create a stream without relying on the inheritance. So now here, so what you need to do is, so we will be having a construct method. So this construct method is called just after calling the constructor. So just after calling the constructor immediately, so this construct method will be called. So this is the one thing which you need to consider. So this construct method will be having underscore construct. Okay. And this one will have a callback. So this one will have a argument, there is nothing but callback. Okay, so this is how the syntax will be. So here you will be able to see the construct and you will be having a callback. So here whatever the initialization and all those things you want to do it, so here you can do it. Normally what we will be trying to do it is, so here we will be trying to open the file and we will try to do it. So here what we can do, so we got the file name, right? So here you can create fs.open. Okay, so for this one what I can do it is, so here constant fs is equal to require of fs. So I will be using the fs here. So this is the callback version. So fs.open and here I will be passing the file name. So I am using the file name, and I would be opening in the write mode. So now here you will be having a callback method. There is nothing but error, and also you will get a file descriptor. So now you got the file descriptor. So just you can tell it. So if an error is there, so we will try to capture that one. So this dot fd is equal to fd. So we can capture that fd, and I am trying to store it the file descriptor. That's it. This is where you initialize your file descriptor. If fs.open fails means, so then if error, so if any error is there means, then we need to do some action, okay, or otherwise we can do it like this. So now that is about this one. So now must and should we need to call the callback thing. So if you don't call the callback thing means nothing happens, so it will not go to the next one. So must and should. So for example, let's say that here finish it, right? So here you need to call the callback, and if an error occurs means, then we need to call again the callback, but you need to send the error inside this one. So it will take, everything will be taken care by the stream. So every time whenever you are trying to do it, so whenever the construct is there means, at the end it should call the callback method. So otherwise the stream will not go into the next method. So that is the thing. The callback here is super important. We need to consider it. If you delay calling it, says with a set timeout or something like that, node will buffer incoming chunks until it is called. This is how back pressure is managed. So here you need to call the callback method. So must and should you need to call it. Somehow you need to call it. If an error occurs means, you need to pass that error as an argument to the callback. So fine. So now we have constructed and all those things we have done, right? So let's try to create the test this stream. So I will try to create a file. So there is nothing but constant stream is equal to. So we'll try to do it in the next video, this one all. So this is the basic things about the constructor and also the underscore construct. So these are the basic things which you need to understand. So we have created our file stream. So what we have did here, in order to recap once again, so we have used the stream, we have imported the stream, and in that one we have taken the class writable. So whenever you want to try to implement your own stream means, so we need to extend the writable, and this is our constructor. So whenever you create an object for the while stream means, so here you will be creating the constructor will be executed. So first and should you need to call the parent constructor, and here I am storing the file name and also the file descriptor. So underscore construct will be executed soon after the constructor has been done. So in this construct it will have an argument that is nothing but a callback. So now whenever here we are trying to open the file name in the write mode. So if an error occurs means, we need to send that error to the callback. If everything goes well means, so then here you need to store the file descriptor and you need to call the callback. Here calling the callback is super important. Why? Because if you don't call the callback means, it will not go to the next step. So it will wait, the stream will wait until the callback is called. So that's why you need to call the callback. So that's it guys about this one. So now what we will be trying to do it is, so here common mistake is, you should never emit the internal events like drain yourself. So node handles this automatically. So don't override the write, always use the underscore write method. So these things I will try to explain you. So that's it guys about this one. So hope you understood about this. So in this video I helped you understand streams better. So subscribe for more content like this and leave a comment if you want a full series on Node.js internal, something like that. So thanks for watching and I will see you in the next one. Happy coding. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in this video we will try to enhance this custom writable stream. We'll try to do it. So we have created our constructor method and also the construct method also has been completed. So now whenever you want to use this our custom writable stream, then what you will try to do here, let's try to say that. So here you will write in such a way that constant, so you will write stream is equal to, normally the file which you are trying to open it, you will try to open it here and you will try to create a write stream. So instead of doing that one, what we will try to do, so just directly we will use file write stream and we will pass the file name. So file name is ours is test.txt file. So let's say show. So this is our write stream. So now, so we have created our write stream. So immediately the constructor and construct will be open. So now, so whenever you want to write it, so you need to call the method stream.write. So here you need to send the buffer data. So buffer dot from, here you can write this is the sample text. Let's say show. So normally this is our sample text, and here whatever the stream you are trying to write it, you will try to write it here. So now whenever you are trying to call this write method, so here what will be the method it will be executed. So here normally the writable inside this one you will be having a write method, it will be executed. So normally if you want to write your own custom means, so here what you need to do is we need to implement the write method here. So in this one it will take the three parameters, that is nothing but chunk and also the encoding, and the last one is the callback. So callback is the must and should we need to do it. So here we got the chunk. Okay, so if you try to check the chunk for this one, so let's try to console.log of chunk, so whether we are able to receive it or not. So if you go into here and if you try to run this custom writable string, so node custom, here you'll be able to see that we got a buffer. Okay, so we got the buffer, so we got only one buffer. So why we got only one buffer? So that is nothing but, so this is the matter, this is the content, we got it, but remaining two buffers didn't get executed. So why? Because so here when the write is finished, our logic and everything, whatever the logic we are trying to write it, whenever it is finished, so we need to must and should we need to call the callback. I told you, right? So we need to run the callback, then only the second stream.write will be taken into consideration. Now if you try to see here, see this time 3 buffers has been came. So that means here whenever you are trying to call the write method, so underlying this underscore write method will be executed. So the chunk and the callback we need to call it. So here what we need to do, so normally here we need to write it to our screen. So here what I can do here, whenever I am trying to write it, fs.write of, so we need to pass the this.fd file descriptor, and also we need to pass the chunk. Okay, so whatever the chunk we are having it, I will try to pass it here. Okay, so now what I can do here, we will be getting the error, and here console.log of error. So just we are trying to do if any error is there. So just we have written it like this. Now whenever you are trying to write the node here, so now we got the null here. So but now this error is there, right? So we got the null error, we didn't get any error. Now if you try to open that text, if you try to see here the test.txt file, so here you will be able to see the only one time it has been written. So why? Because so this one why it has been written like this is, so why it has been written is, let's try to check it. So whether we haven't written the callback, I think so. Okay, we have to call the callback. So callback, let's try to check it now. I will run the node.js here. So now 3 times null has came. Okay, let's try to open this one. See here, this time this has written 3 times this one. But here we are trying to implement the stream concept, but here the handling of the back pressure and all those things is not being happened. So whenever you are trying to send the content, automatically we are trying to write it into the file. So this is not an ideal behavior. So we need to handle the back pressure and the memory usage. So if you are having chunk of file, large GB of file, means the same thing which you are trying to do it instead of doing it with the streams concept. So for this one, what I will try to do it is, so here I will try to maintain a this dot chunks is equal to an empty array. I will maintain it, and I will get the chunk size also. This dot chunk size is equal to 0. So this is our chunk size and this is the chunks. So here I will try to check it. Okay, whenever you are trying to write it, so here I will try to push that chunks dot push. We are having an error, right? So I will push that one into the chunk. Okay, and I will try to calculate the chunk size plus is equal to, and I will try to get the chunk dot length. So that one will be chunk dot length. So we got the chunk size and chunk length, and here I will try to check it with the if this dot chunk size is greater than or equal to this dot writable, this dot writable high watermark. If it is greater than equal to writable high watermark, means then I need to write this entire thing inside this one. Okay, so then only I need to, until then I will try to save it in the chunks in the memory, in the buffer only I will try to save it. So here if not of error, if error is there means, so if error is there means, then I will try to return callback of error. I will pass the error so that it will throw the error, or otherwise what I will try to do, I will try to make the chunks size to 0, and I will try to make the chunks this dot chunks to empty array. Okay, and the callback we will call it. And if it is not happening means, just we will try to store it in the chunks and we'll call the callback. Okay, so we are not writing into the file. So whenever the data we got it, we'll try to write it in the file. So now let's try to execute this one. So if I try to execute this code, what will happen? So nothing is happening, and if you try to see here, the entire content has gone. So now the file has not written anything. Still we are trying to send the buffer data, but the content is not writing. So this is happening because what is happening is, but we haven't reached the high watermark. Why? Because here we are having only 3 contents of text is there. We haven't reached the high watermark. So because of this reason we are able to see. So here I will try to console.log this dot chunk size. Okay, and here I will try to do console.log this dot writable high watermark. So let's try to check these two things. So whether we have reached it or not. And if I go here and if I try to do the same thing, see here the chunk size is getting on updating, but our writable watermark is 16,384. That means around 16 KB. So but we haven't filled it, so that's why it is not writing into the file. So now here what we need to do it is, so at the end when it is finished, okay, so at the end when it is finished, so here we will be having a method that is nothing but underscore final. Okay, so underscore final, and here this one you will be able to get it. So if you try to read the documentation for this one, so let me read the documentation for this one. So if you try to read the documentation, you will be having an underscore final. The final method must not be called directly. It may be implemented by child classes, and if so, will be called by the internal writable class methods only. The optional function will be called before the stream closes, delaying the finish event until callback is called. This is useful to close resources or write buffer before a stream ends. So here this one will contain only the callback. So what we can do here, so this one will take the callback. Okay, and here we need to write the fs.write. So why? Because so whenever we are trying to close this session, so we need to call it here fs.write of error. Okay, so now we are having the chunk. Oh sorry, we should not write the chunk here. So the complete chunks we need to write it. So here we need to write in such a way that buffer.concat. So we need to make it like this, buffer.concat of this dot chunks. So entire thing I will be writing. Why? Because last the chunk will be written here. So now here this dot chunks. In the same scenario we need to copy this one fs.write. Okay, so you will not get the chunk here. So fs.write. So this is the thing which we will try to do it. And here, so now what we will be trying to do here in this one. So if error is there means just you will return callback of error. Okay, and if nothing is there means then what you will try to do. So here you will try to just callback. So just you will send the callback. Okay, that's it. So now if you try to check the custom writable, so here we are able to get it, but if you try to see the output for this one, still we are not getting it. Okay, so why we are not getting this one is, so final, in order to get this final, so at the last when your stream is finished, we need to call with an end. Okay, so then only this final callback this final method will be called. Now if you try to run this one, so now here if you try to see the output, see this time the content has been written. So this is how we will be implementing our custom thing. So custom class will try, custom writable class will try to implement. So here if you try to recap what we have did it, whenever you are trying to write the stream.write, so the custom write method, so the write method will be executed, and here I am trying to check the chunk size so that if it reaches the high watermark, then we are trying to write it into the file, and we are making the chunks empty and chunk size of 0. So when the stream is ended, so we are calling this final, automatically the final callback will be, final method will be called, and here I am trying to write the remaining chunks whatever it is remaining, and I will try to send the callback. So that's it guys about this one. In the next video we will try to use this custom writable stream, and we will try to implement our writemore.js file which we have did it to write the numbers. We will try to do it in our using this custom writable class. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video, and if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in the previous video we have learned about the custom writable stream. So let's try to enhance this a little bit. So we have implemented our construct method and also the write method, and also the final method also has been implemented, and here we are trying to write some data, and when the stream is finished, so we are trying to tell that stream is finished. So here the final is there. So if you try to open this one and if you try to run this one, so stream is finished it is saying. So fine, but here we have not an issue. So here we need to close the file when the stream is finished. So how we can close the file? So here in this finish we cannot able to access the file. So how we can finish it is, so we have another method that is nothing but destroy. Okay, so this is the destroy. So if you try to open the Nodejs document, I will try to open it in the Chrome. I will take this Chrome. Let's open the Chrome, and here you will be having the Nodejs, and in this Nodejs if you go to the docs, and here you will be having the stream, and if you go to the writable streams and duplex streams, and here stream implementers implementing a write stream, and here you will be able to see a destroy, and the destroy is taking error and also a callback. Okay, fine, let's go here and implement the error and a callback. So we need to call the callback here. So now if this dot fd is there, okay, if this dot fd is there, then I would try to close f dot close of this dot fd, and you will be getting an error here, and in this error, so I will return the callback. I will return the callback of error. Okay, or otherwise else means then you can just call the callback. Okay, nothing is there. So that's it. So we have implemented our destroy method. So let's see that whether the destroy method is coming or not. So console.log destroy, destroy. So fine, let's go here and we'll try to do this one. So stream is finished and also it is destroyed. So now here we are able to successfully implement our custom writable stream. So now this one we can use it in anywhere in our when we are trying to write the writable streams, we can use it anywhere. For example, let's say that we have implemented our write-more.js file, right? So this is our writable stream, so which we have created. So we have created a write stream, and I was trying to do the loop, and I am sending it to the stream.write and everything. We are sending it on the drain. I am stopping it here. On the drain I am trying to do it, right? So this entire thing we can take the code and we can implement with our own custom file stream. So here I would try to paste it. Okay, so this paste thing is finished. So if I come down, so this is our async, and there is no need to open, and there is no need to use the Node.js create write stream. So here you can use the file write stream of file name. We need to send the file name, and that is also test.txt, and almost it was same. Okay, so here I have implemented it. So let I is equal 0 before buffer.end stream write many j is equal 1 and drain and everything. So this everything is correct, and file handle there is no need to do the file handle, and finish is done. So that's it. So this like this we can implement it. Now if you try to see the output for this one, so let's try to see this one. So it is trying to write the buffer here. So this is all coming, how many times the stream is trying to write it. So here somewhere we have written this one, right? So draining, how many times it is trying to drain. So this is how we can do it. 236 drains it has been done. So for example, let's say that here how many writes it is trying to do it means. So here we can take it this dot writes count, this dot writes count is equal to 0, and here you can take it with so when we are trying to write it means, so here when we are writing this one, or otherwise we can do it here. Okay, so we can do this dot writes count plus, that's it, finish. And when this entire thing is finished, when this entire finish means, so here I will try to write console.log this dot writes count. Okay, and here I will try to remove this buffering and all those things. So just I don't want to use this J. So now if I try to show you, so then it's started. So here the same 237 you are able to see it, right? The same 237 it is printing. So this is how you will be able to see the writes count also. So whenever the buffer is getting full, then only it is trying to write the buffer. So now, so we have implemented our own thing. Okay, now let's try to see the memory pressure, how it is handling the memory pressure. So if you go to the task manager, okay, I will try to take the node, and this time I will give some little bit bigger, okay, 0 and 0. And here in our task manager, let's go to our node custom writable.js file, and here I would try to search the node, and here you will be able to see the memory is only, it's taking 40 MB. So it is around 40 MB it is taking. So it may take some time to run it, but it is not exceeding the memory. So the memory is in control. So here 2678 and it has been gone. So that means it is taking around what I mean to say is memory 40 MB it is taking. The execution time it is taking 13 seconds. So don't think that it will take 13 seconds. So it depends on the system and the number of cores and the type of process it is running in the backboard by the OS. So my system is little bit slow, so that's why it is taking so much time. For you it will be finished in milliseconds only. That's not a problem. There is no need to worry. There are multiple processes that are running in my system, and the execution time is also taking less only, and the memory usage is also taking less only, and the CPU usage is also less only. So this is how we will be maintaining. So this is how we will be writing our custom writable class stream in the Node.js. So here what we have did, so we have used our write stream, and we have used fs, and we have created a class which is extending writable, and this is the constructor, and this is under construct method, so which will execute immediately after the constructor initialization is completed. So here whatever the state initialization and all those things you want to do, it means you need to do it in the construct. And this is the main method, write method, so which you are, whenever the stream.write is executing, so this is the method which will get executed. And here the underscore final also we are trying to do it, and here underscore destroy, so this one will be executed at the time, so when the stream has been finished. And this final means when you are trying to call the stream.end, then this final will be executed, and at the last, so you will be able to get a finish event. So here this finish event will be executed. So don't ever call here the event listeners like this.emit or something like that. That is not a good practice. That's a bad practice. So here if you go to here, so let's try to check the implementing our own writable stream. So what are the things implementing a writable stream? So here if you try to check it, so we have used this underscore construct with a callback, and we have used underscore write with the chunk encoding callback also we have used it. So write ev also is one of the things, something like an write only. So here destroy we have seen it, final we have seen it, and errors also we can able to handle it, and they have given one example. So decoding buffers they are trying to give it. That's it, finish. So now we are going into the writable stream. So this is how we will be implementing our own writable stream. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video, and if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys. Hello everyone, welcome back to my channel Leela Web Dev. In today's video we are diving deeper into the Node.js streams. So always all the video we are diving. So specifically we are going to implement our own custom readable stream using the Node.js readable class. So now this builds off our last video where we implemented a custom writable stream. So if you haven't seen it, so I will link up it here so that you can check it, that one. But today's it is all about reading the data from a file through a stream we create ourselves. So let's not waste any time, let's jump into it. So let's go here, and I would be trying to create a new folder that is nothing but custom readable. So here it's a new directory. Oh, it got stuck, I don't know. So let's try to right click again, new directory, and there is nothing but custom readable. Okay, so I will be creating a file that is nothing but new file custom readable.js file. That's it. So this is our custom readable file. Most of the things what you are trying to write it, everything one and the same only. So now we have created a folder custom readable JS file also you create. Let's open this file in your code editor. Now we will need a couple of node core modules, that is nothing but custom constant, so readable is equal to require of stream. Okay, so this is the stream which we need to require, otherwise you can have it okay at the top. We got it right. So in this one you need to have only the readable. Okay, and we need to have constant fs is equal to require of fs. That's it. So these are the two things which we needed. So let's go down. So in the same scenario, how you will be having, so let's start by requiring them. So now let's build our custom readable stream class. We call it as in file read stream class file read stream, and then it will extend read stream extends the readable. Okay, that's it. So now what we need to do, we are passing up, now we need to create our constructor. Okay, constructor, and here I will be passing the high watermark. Okay, whatever things are there, and also the file name. So I will pass the file name. So this is our constructor, and we need to call our super, that is nothing but super of high watermark. I will pass it. And what we need to do, so here we need to create our file name. This dot file name is equal to file name, and the file descriptor I will keep it as a null for the time being. That's it. So now we also store the file name and initialize the file descriptor to null. So what we need to do, just like our custom writable stream, the underscore construct method also is used here to perform async setup logic like opening a file. Let's try to implement that one also. Underscore construct. So here I would try to open a file, that is nothing but fs dot open, and here I would be trying to open the file name, that is nothing but this dot file name, this dot file name, and here this one I need to open in a like this, and you will getting the error, and also the fd you will get it as a callback. Now here if error is there means, then what you need to do, so this construct will take the callback, and you need to return with a callback of error. If it is not there means, then you need to store the fd is equal to fd, then you need to call the empty callback. So this is all the common thing which you will be trying to do it. So construct is also completed. Once the file is opened, we store the file descriptor and call the callback to indicate the stream is ready. So now the another one is implementing the read method. The read of size, so this here it will be taking read with an argument of size. Method is the heart of any custom readable stream. It tells the stream how to get the data. Let's implement it. So here you will be having the read of size. Okay, and this one will be our read of size. So here it will take the size of the argument. There will be no callback here. So what we will be trying to do it is, so here let's say that here I will be having a constant stream is equal to new file read stream of, so let's say that you will be passing the file name of around text dot or otherwise, okay, text dot txt. Okay, so you are passing a file. So here what we would be trying to do here, so stream dot on of data, if it is there means, then what you need to do here, you will get the chunk. Okay, and the chunk you will be having like this. Okay, so the test.txt or text.txt is from the writable, so we are having test.txt, right? Let's try to paste it here. So paste it here, and I would try to, so here I will try to close this one all, cancel and close this one all. So here it will be test.txt. So let's try to execute this one. So here I will be trying to go to cd custom readable, okay, and I will run c custom readable.js file. So here nothing is happening. Okay, if I try to do console.log chunk, okay, so if I am trying to do the console.log of chunk, so now what will happen, let's try to see it. So if you try to run this one, so nothing is happening. Why? Because in the read we are not sending any data. So if you want to send any data means, just you need to push buffer dot from of, let's say, string. Okay, so now you will be sending it like this data. Now if you try to run this one, see what will happen. So it is going on sending the data, right? So why? Because so whenever it is going on pushing it, again it will come to the read, so it will push it up to when it will happen. So when you are trying to push null, so when you push the null, then the stream will be stopped. So here if I try to run it, so now the stream will be stopped. So this one, that means what you need to understand here, when you are trying to implement the read method, so always when you are trying to push the data, you need to push it so that this event listener will handle the data. When you are done with the reading means, then you need to push the null. So that is one thing. So here what I would be trying to do it is, so here I will create a buffer, constant buffer is equal to, so here I will try to create a buffer and will try to send the data. So like this you will be having, for example, let's say that we can't do anything, stream.on of data. Okay, so here you can go on send the data, and whenever it is finished, so we cannot do anything. So here this dot push of null, so like this only we need to take it. So null means it will not send it, and when the stream.end is finished, so stream.on of end, so when it reaches the end, so then you can say that console.log streaming is done. So this is the thing. So here if you try to check it, so you will be able to see directly the streaming is done. Why? Because so we are not able to read the data. So here if I try to run it, console.log reading means, so here if I try to show you, so streaming is done. So why? Because it is pushing the null data, so that's why the streaming.on of data is not emitting. So this is how we will be writing. So now what we need to do in this read method, so we need to read the file. Okay, we have opened the file in read mode, right? So we need to read this file. So when it reaches the end of the bytes, then what we need to do, so then we need to push the null, so then this one will be finished. So this is how we need to push it. So in the next video we will try to implement that read method, and also the destroy method also we'll try to see it, and we'll try to see at the bottom also how the reading stream will be implemented. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video, and if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome back to my channel, Leela Web Dev. So now we are trying to implement the read method, right? So as I already told you that read of size method is the heart of any custom readable class stream. It tells the stream how to get the data. So let's try to implement this one. So here I have told you this dot push of null means the reading of the data will be stopped until and unless when you are trying to push it all the time the read will be called. So here I can call constant of buffer. So here I will try to create a buffer, and I will allocate a size of the same size which we would be trying to do it. So we need to send the data as a buffer, right? So that's why. So I would be trying to read it. Okay, fs.read, and here I need to send the file descriptor, and also here I need to tell the buffer in which it needs to fill, and 0 where it needs to start it, and the size, total size it needs to, and the position is nothing but null. So this is the thing, and here you will be able to get the error and also the bytes read. So you will be able to get the bytes read. So this is the syntax for this one. So if I try to hover here, you will be able to see fd buffer offset length, the total length how much it needs to take, offset is nothing but 0, length, and the position, read position from where we need to, null means so from where it has been stopped it will take it, callback is nothing but the callback. So here I can write if error is there means then I just, so here we cannot call the callback, so here we need to call the destroy, so automatically it will be destroyed. So error, so we can send it with an error, and if nothing is there means then what you need to do, so if here you need to see that bytes read, so if anything has been read or not, if bytes read is greater than 0, so that means something content has been read. So then what I need to do here, I need to push this dot push off. So here we need to sometimes we have seen in our readable stream, sometimes we are getting the null values. Why? Because for example, let's say that here by default readable stream, sometimes we will be getting the null values at the time, right? For example, let's say that here we know that the readable stream has an internal buffer of around 64 KB. Let's say that this file size is around 16 KB only. So the remaining 64, in that 64 KB, remaining 40 KB or 38 KB will be filled with the null values. So null values or zero values, it will be filled. Null values only it will be filled. So in order to remove those all the things, what we need to do here, we can use a method that is nothing but now the buffer which you are having it, right? So here we are having this buffer. So the buffer, so now here we need to fill it with buffer dot subarray. Okay, we can use the subarray and 0 to bytes read. So here I would be trying to delete this one all. So now I am trying to take up to the only bytes read only. So now we got it, or otherwise what you can do here, how much is there bytes is read, we are trying to push it into the buffer. We are trying to push it into the read, or otherwise, so if nothing is read means then we will be pushing only the null value so that it will be stopped. That's it. So this is the read method. So what we are trying to do here, we are trying to read the file. So with the file descriptor, buffer 0, size and null. So when we got the bytes read, so that means for example, if the file size completely bytes read means it will be 64 KB. It is greater than 0 means entire buffer will be sent. And sometimes it will be reading only 38 KB means only the buffer I am filling it with 38 and I am trying to send only the 38 only. So that is the thing we are doing it here. So here buffer dot allocate of size means, so here we are allocating a buffer of the requested size. We are calling fs.read to read the data into the buffer. If we successfully read the data, bytes read will be greater than 0. We push a subarray to the stream to avoid the trailing zeros, which we have learned it in our previous videos. If you don't have an idea means just visit my previous videos so that you can able to understand about the readable stream and how it behaves while reading the data. So now if there is nothing left to read means then we will push the null to signal the end of the stream. So that's it. So now what we need to do, so if you don't use a callback, we don't use a callback to report errors in read like we did in the construct. Instead we call that this.destroy of error. So now we need to clean up. The next step what we need to do is we need to clean up with the destroy method. Now let's implement the destroy method. It is called automatically when we destroy the stream manually or when an error happens. So here what I can try to do here, so underscore destroy. Okay, it has two parameters, that is nothing but error and the callback. So this one will have a callback. Now here we will be trying to do something like, if the file descriptor is available, if this dot file descriptor is available, then what we will be trying to do, so we'll close the thing and here I will call this dot fd. Okay, and here what I can do, so we will be having a close error. So whatever the thing you will be having, so you can do it, the close error, and here I will be calling the callback with an error or close error. Okay, so whatever the error you are having it, I will be trying to send it. If the file descriptor is not there means then I will call back of error. Okay, so whatever it may be, we will be trying to send the error, or undefined means nothing is there means nothing will be sent. So fine, so this is all the destroy method. So here we are trying to read the data, so everything is coming and we can able to see the chunk data also. So let's try to do it. So test.txt file is there, so let's see that whether we can able to read the data or not. So now we are streaming, we are listening to the data, so that is nothing but it is pushing the data everything, and here upon finishing the streaming, so it will be done. So just run the script here. So let's go to our code here and I will be clearing this one all. So let me maximize, yeah, so I will be reading node custom readable.js file. So if you try to see here, the streaming is done. So all the bytes you are able to see, this all the buffer data we are able to see and it is reading. Okay, so at the last you will be able to see 5832 bytes only read, but we will be having 16,334 bytes, right? So what is happening, the remaining bits means, so what is happening is, so remaining bits are filled with the trailing zeros. So because of that reason we are trying to use that subarray concept. So now what I will be trying to do here, so here if you want to check what is the data it is trying to get it in, so let's try to go here into our code and here I will try to convert it into chunk.toString. Okay, by default it will be UTF-8 only. So let's try to see. If you don't, so if I try to read, see everything is getting printed. So here this is all it is getting printed. So we have printed up to around 500,000 I think, I didn't remember exactly. So 500,000 we are trying to do it. So that is the thing, it is printing it. So now you are able to see the file contents and all the things. So let's say about small details what you don't want to miss it. So here before closing up, what I want to tell you is we have used a subarray, buffer.subarray we have used it, 0 bytes read we have used in order to avoid the trailing null characters or empty buffer space. End event only fires when we push the null. So this end event will fire only when we push the null. high watermark, our custom stream uses the default 16 KB, but Node.js built-in. Okay, so this one will be only 16 KB, but the Node.js built-in fs.create read stream uses the 64 KB, whereas this one is using 16 KB only. So you could modify in the constructor options, high watermark, you can modify it. That's not a problem. So that's it guys. If you want to use it in your custom stream, so for example, let's say that you are having a readable stream, right? So here, if you want to use it for this read big thing, so instead of implementing the Node.js strings, if you want to implement your custom stream, means you can totally do it. Just plug it into your existing pipe, everything logic, or use it custom readable stream like we did before. Everything will work. So it's not a problem for you. Okay. So now a word of caution. What I want to tell you is, before closing of this one, in production, you probably don't want to reinvent the wheel. So whatever the readable and writable classes available by default with the Node.js thing. So Node.js natives create read stream and create write stream are there. So you can it is well tested and efficient and as a battle hardened. So you can use it without any problem. By implementing our own custom readable stream is a great learning exercise, first of all, and sometimes necessary for custom resources like APIs, in-memory stores, or special binary formats we need it. So that's why we have learned this one. So finally, I encourage you to check out the Node.js documentation. So let's try to open the Node.js documentation. And before closing of this one, so just I will try to show you the Node.js documentation. So we are learning about the readable streams. So let's try to see stream implementers, and this is our implementer readable stream. So we have checked these all options. So if you want to send these all options, these are all the options that are available. And here, what are the methods we are having it? Underscore construct, we have learned about this one. So underscore read also we have seen about this one. Destroy we have seen. Push we have seen. So when we want to error handling and all those things, so how to error the handle this thing, this dot destroy. So counting stream they have given how to handle the errors and all the things. That's it. So readable stream implementing is finished. So implement duplex stream is the next topic which we want to discuss it. So it breaks down everything in the Node.js we covered today. The purpose of underscore read, push logic, proper use of destroy, and options you can pass it in the super. Everything is there. So that's it guys about this one, and that wraps up how to implement our custom readable stream in Node.js. So we have looked at file reading, memory management, internal buffering, and also the error handling. If you found this video helpful, give it a thumbs up, subscribe for more deep dive videos, and let me know in the comments what would you like me to cover in the Node.js. In the next video, we will move on to duplex and transform streams. So stay tuned for that. Until next time, happy coding. Hey everyone. Welcome back to my channel Leela Web Dev. In today's video, we are going to dive deeply into a real and cool and powerful concept that in Node.js, that is nothing but duplex and the transform streams. So what is this duplex? First of all, in this video, we will try to learn about the duplex thing. We will start by understanding what duplex streams are, why they exist, and how they are different from readable and also have writable streams. And we will implement our own custom duplex streams from the scratch. At the end, I will show you how duplex streams lead us directly into a transform streams, which we will cover in our next video. Let's try to see it. So let's start with a simple theory real quick so that you can able to understand it very quickly. So you know that duplex stream is just a combination of a readable and a writable stream. So that means if you try to see here, so you will be having a duplex stream here. Okay. So this is our duplex stream. So here is the thing. What is the thing is there are two parts which are completely independent to each other. So that is nothing but the duplex stream has two internal buffers. So one is this one. So this is readable. Okay, readable buffer. Let's say. And this one is a writable buffer. So these two buffers are independent to each other. Okay. So this one is a writable buffer. Okay, writable buffer. So let me write this one. Writable buffer, and here also I will write it like this. So this is our buffer, readable buffer and also readable. So it has two separate internal buffers. One is used for reading and another is used for writing. Unlike readable or writable streams, they only manage one buffer. So normally the readable streams and writable streams, if you try to see, they will manage only one buffer. A duplex stream manages both. These two parts can interact with different sources or in destinations. For example, reading for a file and writing to a network socket, something like that. So that means these two buffers are independent to each other. They are not connected to each other. These two are independent to each other. So that means, for example, you are having a file something like file1.txt. Let's assume that file1.txt. Okay. So this is the file. So just it can the stream. So here you will be pushing the data. Okay, you will be pushing the data into this one, and readable stream, and here whenever you are trying to emit the data, so event the data, so the readable stream, the data will be exposed here. So this is completely different. And the writable data, so how you will be having this writable data, so here, so you will try to write the data, stream dot write of data, something like that, you will try to write the data. Okay, so whenever you are expecting, whenever this buffer is full, okay, so whenever this buffer is full, so whenever you write this data into this ones, so you will get the data, right? So here you will get the data, so you can write it in your own file2.txt, so you can write it in your own, or otherwise you can send it to the network socket or something like that. So whatever the things you want to send it, so you can do it. These two are completely independent to each other. So normally, why does this duplex exist in the JavaScript? So if you try to go to the Nodejs documentation, so this is our duplex thing, right? A duplex stream is one that implements both readable and writable. So the best example for this one is TCP socket connection, which we will try to cover in our upcoming series, the Node.js, after completion of the streams. So this TCP connection, we will try to use it, this duplex stream, because JavaScript does not have support for multiple inheritance. So normally the duplex class, so that's why the duplex class is extended to implement a duplex stream, as opposed to extending the stream.readable and stream.writable class. Normally the multiple inheritance in JavaScript, it is not supported. Example, let's say that I will try to create a folder here, duplex, so that we can able to write the code. So here I am creating a new directory, so duplex, and in this duplex I will try to create a new file, custom duplex.js file. Okay, so in this one, so normally if you want to add the stream, so class duplex stream, so let's say that if you want to add a duplex stream extends, so you want to extend both readable and writable, right? So this is not supported. So this is not supported. Why? Because JavaScript does not support the multiple inheritance. So here what we can do, what we are trying to do, so because of this one, a new one has been introduced, that is nothing but duplex class. So the duplex class prototype typically inherits readable and also parasitically the writable, but instance of will work properly for both base classes due to overriding on stream.writable. So here, so duplex, it needs to extend the duplexes so that both the things will work. So the things you will be having a separate high watermark, that is nothing but readable high watermark, writable high watermark. So different cases are there. Let's try to see it. So now whenever you want to create a stream that supports both writes and writes, means then you need to extend from duplex. So let's try to implement a custom duplex stream step by step. So here I will be writing the duplex stream, so it should be extended from the duplex. Okay, it should be extended from the duplex, and that duplex comes from the constant duplex is equal to, and this one should be constant duplex is equal to require of stream. Okay, so now we got the duplex. So here you need to understand one important thing, and also let's import the fs also. Constant fs is equal to require of fs. So now you need to understand one thing. So here the same thing happens. So we have imported the required modules. Now we need to create the custom duplex class. So here I have created the custom duplex class, which should extend the duplex. So now what we need to do, so normally it will have a constructor. So that's a normal thing. So you will have a constructor, so which you will try to give the constructor. But in this constructor you will be having varieties. Varieties means nothing but the options will be different. So you need to, so as I told you right, duplex is nothing but it's a combination of both readable and writable class stream. So here you need to give readable, okay, readable high watermark or something like that, it will happen. So let's try to take it. So yeah, readable high watermark. So you need to have this one, and you need to provide the writable high watermark also, high watermark, and you need to provide read file name, okay, and also the write file name. So these are the things you need to provide it. So these all things, so whatever the things are necessary, you need to provide it. So now we got this one all. So what I can do here, we need to call the parent constructor. So here I need to pass the readable high watermark and writable high watermark. So I have passed it. And the last one, what I need to do it is, so here I need to do this dot read file name, okay, is equal to read file name, this dot write file name. So if you need it means you can use it. So if you are not using anywhere means, so just you can. So here I need to create read fd file descriptor, which should be null, and another one is this dot write fd, and this also should be null. So this is the setup for basic setup for the constructor. So I told you, right, this one is a duplex stream. So if you try to go to our Node.js documentation, at the top, if you try to see our implementing our own readable and writable stream, so you will be having a table structure, right? If I try to explain you, yeah. So if you are going to implement a duplex stream, means both reading and writing means, so you need to implement read method, write method, and also final method. So these all the methods should be included. So any of the methods all methods should be included. So that means you need to implement the read method for implementing the readable stream, write method for implementing the writable stream, final means when the stream is ended. So like this we need to do. So destroy method we need to do when the stream is everything is completed. So that means we need to implement both the readable and also the writable stream. So now in the next video what we will try to do is, we'll try to implement the both readable and writable stream in the duplex stream, so that we will check the output also. Hope you understood about this basic setup, and also you are able to understand there is readable stream. So in the next video what we will try to do is, we will try to implement this duplex stream and we will try to see the output also. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hey everyone, welcome back to my channel Lila Web Dev. So we are learning about the duplex stream. So we have implemented the duplex stream, the constructor part. Let's try to implement the remaining part. So you know about the duplex stream, that it is a combination of both readable and writable. So in order to implement the readable and also writable stream, so we need to have a read method and also a write method should be implemented. Let's go to the writable class. First we'll try to implement the writable. So if you try to go to the custom writable thing, I will try to show you. Here we are having a code in such a way that we are having a chunk and chunk size, right? Let's try to write this one also. Why? Because we need to implement the writable also. Now the chunks and chunk size is also there. Now in the construct I need to open both the files, like read file and also the write file I need to open. Let's go here and implement the underscore construct. You know that underscore construct when it will be calling whenever right after before the constructor has been executed. Now here let's try to open the fs.open. So I want to open the file name, that is nothing but this dot read file name, this dot read file name. Okay, I want to open it in a read mode. I will be getting both the things like error and also the read fd. So that is nothing but the file descriptor. If error is there means just I will return callback of error. That's it. If error is not there means then what I need to do, just I need to go this dot read fd is equal to read fd. Now I have opened this one. Now I should not call the callback immediately. Why? Because I need to open the write file name also. Let's try to open the write file name, this dot write file name. I need to open it in the write mode. Okay, and I will get the error and also the write fd. And in this write fd what I would be trying to do, the same thing. If error is there means I would be trying to call this one, and I will save that this dot write fd is equal to write fd. Now I will call the callback. Okay, this is the thing which I will be trying to do. Now the underscore construct is also created. Now we have created we have opened a file with read mode and we have opened a file with a write mode. Let's try to copy this read mode file, that is nothing but custom writable. We have written all this code, right? Let's go to duplex stream and I will paste it this entire file, so that this file we will be reading this one for reading case. Cancel it and let's go here. And now we have implemented this one. Let's implement the custom writable thing, write method. So the same thing. So this entire thing what we have did it up to here, we can copy this entire thing and we can paste it here. That's it. So the write chunk file has also been executed, but here we need to go writable high watermark and all those things is there, but here we need to write the write fd. That's it. And remaining all is one and the same only. We will be calling the callback and all those things. If you go to our custom readable, which we have learned it, the custom readable thing, that is also one and the same thing only. So here you are having the read method let's go to the custom duplex and you can implement the enter read method. That's it. So here, but we need to take the read FD. Other than that, everything is one and the same. So we are pushing the data and all the things we are doing it. Now in our custom writable field, we will be having a final thing. We need to implement this final. Why? Because when the stream is ended, we need to write it into our file descriptor. So write FD. That's it. Now here we have called the destroy method, right? So we need to implement the destroy method also. If you want to implement the destroy method, means underscore destroy, and you will get it the error and the callback. Okay, error and the callback. Sorry, callback. Oh, sorry, callback. Whatever thing you want to do it, you can do it. So that is nothing but this destroy thing. If you are getting any error, means you can call back. Okay, we need to call the callback of error. That's it. We have finished this destroy method also. Fine of callback destroy method. Yeah, we have implemented the write method, read method, and everything we have implemented it. Now it's time for us to call the duplex stream. So let's try to call the duplex stream. Constant duplex is equal to new duplex, and we need to pass the file names. File name. Oh, sorry. Write file name. Write file name. It should be write.txt. We will try to do it. And the read file name. Read file name should be test.txt, which we have copied it. That's it, right? Let's try to see. Yeah. So we got the duplex. We have implemented the duplex. Now we have implemented these all the things. And now we have implemented these all the things. Let's go. So we have passed the duplex thing. So now first of all we need to read the data. If you want to read the data, means duplex dot on off data, you will get the chunk, right? That is nothing but the chunk we will getting it. And just I will try to do the console.log of chunk dot to string. Okay, it will come, the buffer will come. So I am converting into chunk of string. Now if you try to run this one, custom duplex. Okay, let's go to the cd duplex cls. Okay, let's try to run custom duplex. Now here you will be able to see the constant write duplex has already been declared. Why? Where it has been declared? Duplex stream. Okay, at the top duplex is there. What we can do it is duplex, or otherwise we will keep it as a stream in order to have a naming issue. We will try to do it here, and here I can call it as a duplex stream. This is the thing which we need to call it. Now let's go here and let's call it duplex is not defined. Okay, I saved it, right? Yeah, duplex stream. And here what is it? Is it asking? Okay, here you need to import the duplex. Now let's go here and let's call this one. See, it is reading the entire data. Now it is reading the entire data. The streaming is doing. Now if you want to write to it, means now what you can do here, let's go at the top, and here what I can do, duplex dot write of duplex. Oh, sorry, it's not duplex. So let's try today it is a stream. I kept it as a stream. Normally it is a duplex. Buffer dot from of new text string or something like that. I will try to use it. Okay, now you can go and write like something like this. At the last you can do the end, duplex dot end. You can call it like this. So now if you try to see the reading and both the running, it will be done. So here you will be able to see the reading, and if I try to show you the file also, the write.txt file also has been created, and you will be able to see the data which we have trying to write it. Everything has been written. So this is all about the duplex stream. So this is how we will be implementing. Now here is where things gets interesting. Now you understood about the duplex thing. If you take the duplex string and make the written data become the source of readable data, then you have built a transform stream. That means, for example, let's say that you are having this readable stream, right? These both are completely independent to each other, which we have discussed it. And now you are reading the data from a file and you are sending the data. And here also, whatever the data you are getting it, you are writing into this one, and you are sending the data into this one. You are writing in some separate file. For example, let's say that you are getting it, you are getting data from something like this, and you want to write it to a file. Means instead of writing to a file, you send it this one as a source to the readable stream. Okay, so that means whatever the data you are getting it here, you are sending it to the readable stream, so that you will be modifying the data and you will be sending it, right? This is called as a transform stream. Okay, so now whenever you write it, you can read back, but altered. So transform stream means altered data. Transform streams use cases where we will be using it is in the compression, encryption, decryption, uppercasing the text, filtering data. So like this, if you pass the data through it without modifying it also, it is still a transform stream, but we just call it as a pass through stream. Okay, so that is one thing. So in the duplex, what we can do both read and write, and in the transform stream, it is both are linked to each other, but here both are independent to each other. In the duplex, data flows through is unrelated, so here write and read everything will be done. So like this we will be having. So in the next video we will try to learn about this one. So in summary, what I want to do is duplex streams are like the foundation, two independent read and write streams, whereas the transform stream is built on top of that by linking the writing data to the readable data. Okay, by letting you manipulate the data in between. So that is called as a transform stream. In the next video, what we will try to do is we will build a custom transform stream that encrypts and decrypts data. It will be a practical and hands-on, so make sure you subscribe and hit the bell icon. So thanks for watching. Drop a comment if this helped you, and feel free to ask questions if something didn't click. See you in the next one. Thank you guys. Hi guys, welcome to my channel Leela Web Dev. So in this video we will learn about the final stream type, that is nothing but transform stream. So have you ever wondered how to modify the data on the fly while reading or writing the files in the Nodejs? So today we are diving into the transform streams, the superhero of the streaming when it comes to the encryption, compression and much more. I will show you how to build our own file encryption and decryption stream from the scratch. I will try to show you that one so that you can able to understand how in which ways we can use the transform stream. So alright, let's have a quick recap about this one. Node.js, normally we know that it has 4 types of stream. That is, one is a readable stream, writable stream, duplex stream, and the last one is the transform stream. Transform stream is somewhat special. It reads input, modifies it and sends the result to the output, all in a streaming way. Think of it as like a factory conveyor belt. Raw data goes in, gets processed and comes out transformed. You can use it for encryption, compression and even real-time translation also. So now let's try to see about this one. Let's build our mini encryption system. So we'll try to read a file, encrypt its content using a custom transform stream, write it to a new file and then decrypt back again using another transform stream. So here is the full step. So let's try to see it. It is very simple, don't worry. Just we need to have a knowledge on the streaming mechanism. That's it. Let's try to see this one. So here I will be creating a new folder. That is nothing but new directory, transform. Here I will create a first one is the encrypt.js file. Okay. Let's try to add this one. Yeah. So now here what we need to do, constant. So you already know about this one, is equal to require of stream. So we need to not stream. We need to import this one. In that we need to have it. We need to require transform. Here I will do something like class encrypt stream extends the transform. So we need to extend the transform. Okay. Now what we need to do here, simple thing. So in order to have a transform thing, what we need to do is we need to have a transform _transform. Okay. And here this one will take the chunk, and if you want you can pass the encoding and also a callback. Let's say that we got the some data. Okay, let's say that we got some data. What I want to do, I want to convert that one to a what I mean to say is we got the buffer. I want to convert into a something like step by step I want to convert. Let's say that you are sending a string and I want to convert that one. Let's say that I will console.log of chunk. Okay, I will be having a chunk. Now I need to pass the stream. Let's say that we are having a file here, that is nothing but, let's say that test.txt, and here I will be having, so Leela web dev. This is the just text we are having. I need to encrypt this text. What we will try to do, first we will try to open the file. So file handle is equal to, so await fs, so we need to fs dot open test.txt, and I need to open it in a read mode. Okay, and here we will be having another one, write file handle, and this one is read file handle. We'll try to have it read file handle, and this one is write file handle, and this one also same thing, await, and here I will do something like decrypt. Okay, decrypt, sorry, yeah, encrypt. We are encrypting, right? I need to encrypt the text which is having that one, so I'm opening this one in a write mode. Fine. So now let's try to see here what I was trying to do. I am opening this one, let's say /promises. Okay, this one goes away. Now we need to open the read stream. Constant read stream is equal to what is that we need to do? Read stream read file handle dot create read stream, and constant write stream, what we can do, sorry, write file handle dot create write stream. So we got the write stream. So let's try to use the pipeline. Okay, normally what you will try to do, so here you will be having this one and you will get the error. So if error is there means, then you will try to do console.log error in copying, oh sorry, error in copying, or otherwise else means console.log copy completed, something like that. So this pipeline we need to import it. Where could this pipeline will come? That also comes from the stream, I think, pipeline, yeah, and hopefully this one goes away. Let's try to run this one. Let's go to our command prompt. Here I will go to transform, and here I will write node encrypt.js file. So when I try to run this encrypt.js file, it is saying await is only valid. Okay, so these are all the things we should be having in an async. Okay, and here I will try to copy this entire pipeline, and here I will paste it here, and let's try to do the async. Okay, this is a simple code. Let's see the normal way how we are trying to do it. Node encrypt.js copy completed. If you try to see here, so we are able to get the encrypt.txt. Automatically it has been copied into this one. So what I need to do, so we need to pass it to the transform stream. So this is our transform stream. We need to pass it to this one, and we need to encrypt the file, and we need to send it to the write stream. So for this one what I can do it is, so here constant encrypt stream is equal to new encrypt stream, new encrypt stream. So we have called this one. So what can I do here? So I will be just using this encrypt stream, and I will be passing it to the write stream. That's it. Let's try to see what will happen. So here it is saying new encrypt stream. It cannot able to class encrypt stream extends the, here this is the only thing, right? Oh, so two names are there. So transform stream, I will try to keep it as a transform stream. Okay, and I will use it directly here. Now hopefully this one will work, the name conventions. So now here you will be able to see the buffer has been sent, and if you try to check the test.txt, so sorry, encrypt.js file, sorry, encrypt.txt file, so nothing has been written. Why? Because so this transform stream is not sending anything, just we are consoling.log of chunk. Let's try to do it to convert it to a console.chunk to string, so that you can able to see what is the type of data we are getting it. Now if you try to check it here, so here we are able to see that is Leela web dev. So that is nothing but this one is Leela web dev. Now what I want to do here, I want to encrypt this one. So if you want to encrypt this one means, so what can I do? So I can get each chunk. Here I can get the each chunk, Okay, I can get the each chunk and I can do chunk plus 1 so that it will be incremented. So Leela WebDAO means it will be incremented. For example, let's say that here let encrypted is equal to empty, okay, or otherwise let's encrypted is equal to buffer dot alloc of chunk dot length. Okay, now what I want to do here, for let I is equal to 0, I less than chunk dot length, I plus plus, and here what I want to do, it is encrypted of I is equal to buffer dot from, not buffer dot from. So here what I would be trying to do, it is chunk of I, I plus 1. Okay, I can do it like this. And now what I can do here, I can do console.log encrypted. Let's try to check the encrypted one. So what is it has been encrypted, and here you can console.log of chunk also. So I have encrypted the code. Let's try to see. So now if I try to encrypt this one, console.log, okay, somewhere I have made it wrong. Okay, fine. Now let's go here, say ls, and what I was trying to do, so here it has been updated. So let's try to do the toString so that we can see what it has been updated, what it has been transformed. Dot toString. Now if you try to see the output for this one, see here it has been updated. It has been updated to some gibberish. Okay, so L, the next number is M, E, F, E, F, L, M, B, exclamatory. So like this, some random data it has been transformed. So what I will try to do here, we need to send this encrypted data to the right stream to write it in the right stream. So what can I do here? Just simply, so what can I do, it is I can send this dot push. Okay, you can push it to the encrypted like this. Then we need to call the callback. Okay, that's it. Now let's try to see whether we can able to send it or not. So copy completed. Let's try to open the encrypt.txt file. If you try to see here, the entire thing has been written here. The another way which you can do it is, instead of writing these two things, so you can also write callback. You can send the encoding and also the encrypted. So here if you don't have anything, error, it is an error. So you don't have any error and encrypted you are sending it. So this also works without any problem. So if I try to do this one, copy completed, and we are able to see the encrypt.txt file. Fine. So now we are able to do this one. So now we need to decrypt it. So how we can decrypt this one? The entire code I will copy it. Okay, let's go to here and I will create a new file that is nothing but decrypt.js. So let's try to add it and let's try to copy everything, and here I will do it is an decrypt. Okay, decrypt, same thing will you, instead of that one we will do it as a -1. So again we are reverting back, and I think everything is there, but here we will be having encrypt.txt file, and here we are having decrypt.txt file. I am opening it in that one. So here read handle, so here you will be having decrypt stream and read stream, transform stream. Okay, everything is perfect. So decrypt stream we are doing it, everything is going on perfectly. Let's try to do this one. So now here instead of encrypting I will be using decrypt. Now if I try to do, so module decrypt.js, what it is saying, so here encrypt.txt it is there, decrypt.txt write mode we are opening it. Fine, everything is on the right mark only. What is that? Cannot find module decrypt.js file, transform node decrypt, so decrypt stream. Okay, we are having this one, and the spelling is okay, decrypt, we have a spelling mistake. Let's go here, and I have removed this p, so let's try to run it. Copy completed. Let's go to our decrypt.txt file. If you try to see here, the exact thing has been converted. So whatever the encrypt.txt file you are having it, that encrypt has been encrypted and decrypted. So this is how we will be using the transform stream in order to encrypt or compress whatever the things you want to do, whatever the logic you want to do, you can do it like this. So that's it guys about this transform stream. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hey everyone, Welcome back to my channel Leela Web Dev. In this video we are wrapping up our Node.js streams, but don't worry, you will be seeing a lot of more of streams about this one throughout this series of this Node.js. So today I am going to leave you with some final notes, diving into super useful feature called object mode, and we will explore real world packages that make the most out of the streams. Plus I will show you how you can continue learning and mastering the streams beyond this course. So far we have mostly dealt with the streams that handle binary data. So buffers chunks of data, zeros and ones like this we handle, but streams can also operate in what is called as an object mode. So I will try to show you about this object mode. So if you go to our documentation, if I open this documentation and here if I go to our streams concept, let's go to our PQRS, here streams concept. Here you will be able to see the streams and all the things in an object mode. Okay. Up to now we have seen about the binary mode only. So this is object mode. So now all streams created by the Node.js APIs operate exclusively on strings buffer like this, right? Strings and buffers are the most common types used with the streams, and binary data like this also we can use it. So here it is possible streams work with other types of JavaScript values. Such streams are considered to operate in object mode. Streams instances are switched into object mode using the object mode option when the stream is created. Attempting to switch an existing stream into an object mode is not safe. So for example, if you are having a readable stream or writable stream, and if you want to convert it into an object mode from the binary mode, means then it should not be done. So while creating the stream only, we need to make it as an object mode. So here if you are having the object mode, means then you need to consider that the high watermark value, it will be a 16 here also, instead of having a 16 KB. So at a time the buffer will store 16 objects. So let's try to see a simple example for this one so that you can able to understand it. So here I will be opening here, I will be creating a new folder, new directory, object, okay, object mode. So now if you try to see here, so here I will create a file, object mode.js file. Normally what you will try to do, here we will create constant is equal to required of stream. So this is the normal stream which we will be required, and here I will be using a readable, fine, right? Now I want to create a readable stream, so custom readable stream. So okay, read stream extends readable constructor. So you will be having a constructor, and here you need to pass the options, and I will be sending that options to here. That's it. Okay. So now we have a read stream. So let's try to create a read stream here. Constant stream is equal to new read stream, and here you need to pass the so if you don't pass it anything, okay, let's try to keep it like this only, empty object. Okay. So now here what you will try to do is stream dot push off, okay, buffer. So you need to do buffer dot from off hello. So like this you will push it, and at the last you will push stream dot push off null, so that the stream will be finished. So here at the end what you will try to do, so in order to read the stream, so stream dot on off data. So whenever you are having the data, you will be able to get the chunk, okay, chunk, and here you can write console.log chunk, okay, oh sorry, not chunk, here chunk, fine. So when the stream is done, stream dot on off end, so here console.log stream end. So this is our simple readable stream. So now if I try to execute this one, so let's go into the object mode. Okay, so you will be able to see node object mode.js file. So you'll be able to see that the buffer, we are able to stream the buffer, and at the end we are able to see the stream end. So now if I want to send instead of sending this buffer thing, I want to send an object where it can be used when you are trying to send a huge data. So here I can say something like id name, and name is Leela Web Dev, let's assume. Okay, now the same thing I want to send it, the object I want to send it. So if you want to send it like this, then what will happen? Let's try to see it. So here we are getting an error that the chunk argument must be a string or an instance of a buffer or unit array. So that means it should be a string or a buffer or a unit array, but you are receiving an object. So this is not possible. So for that one, what we need to do is we have an option that is nothing but object mode to true. That's it. Now here, if you try to do it, now you will be able to see the entire thing. You will be getting it as an object. So here you are streaming the object. So like this, instead of having the class also, what you can do it is, so here you can create something like new readable. So here you can add it like this also, new readable. This also works on the same way. Instead of having our own custom class, something like that, this also works in the same way only. So this is how we will be doing it. If you want to write your read function means, so here you can use the read function and you can implement it. So if you want it, something like this. So fine. In object mode, a stream doesn't deal with binary data. Instead, it moves the full JavaScript objects around. This is incredibly useful when working with massive JSON data sets, like streaming query results from a database. So in this streaming database, it will be useful. So remember high watermark. So we know that high watermark, right? It controls how much data can be buffered internally. In normal mode, it is about 16 kilobytes, but in object mode, it changes. It is the number of objects instead. So high watermark 16 means 16 JavaScript objects. So that is the concept you need to understand. So it is a small but crucial difference. The rest of the stream behavior, events, methods, flow controller, everything remains exactly the same. So that's it. So where we will be using this in real world use case, the streams and all those things. So one is the thing which we will be using in the real world is the pg-query-stream. If you try to check it, this is our node package, okay, npm package. So this is, now let's see a real world example. So pg package, this is the thing. This is a companion package called pg-query, and that gives you stream results in an object mode. So if you try to see it here, this is our stream, okay. So here you will be able to see you are connecting, and here you will be able to see the new query stream. So here we are querying that one new query stream. So now we are querying that thing stream, and when the stream.on append, and we are trying to pipe stream, this is the readable stream, and json.stringify. So we are trying to do JSON stream. It says transform stream. JSON stream is a transform stream, and it is converting and it is sending to the process.standard output. Okay. So this is how you will be thinking. Here, instead of fetching 1 GB of users into a memory at once, we stream each row as an object. This keeps memory usage super low and efficient. So one of the best ways to master streams is to read the source code of the popular packages. Let's try to see about this one. So if you try to see about this one, let's go to the GitHub of this one. Let's say, okay, repository. This is the repository. Okay, fine. So here, if you try to check, this is the code. Okay. Now, so now here, if I try to open, so whatever the thing you are having, let's try to check it. So here packages. Let's try to see. So what is the code we are having? pg, let's say lib index.js file. Just I am trying to see here. So we don't have anything here. Let's go back. I will try to open the pg query string, and here this is the source we are having, and let's go to the index.txt file. See here, it is trying to take the readable stream, and here it is extending the readable, and it is trying to write it, and here it is taking the constructor. So super of options, it is trying to send the options, the same thing which we have did it, the destroy, the read method. So everything it is trying to do it. So this is how we will be implementing. Okay, so you will see that query stream is extending. These are all the things we are able to see it. So this will teach you how real world libraries handle the stream. Other stream based libraries are also there. So concat stream, busboy, stream search, like this you will be able to see. So many things are available. Okay. So we have seen something like file uploads in the Express.js. You will be probably using the Multer. So Multer is built in the top of the lower level faster package called the busboy. So that also uses the streams thing only. So this is all about the concept. This is all the thing. So we have covered now the object mode also, real world usage, pg, query, stream, busboy. These all the things also, package also I explained you. Streams are very powerful, and the more you work with them, the more natural they will feel. So don't just stop here. Read the docs, play around, break things, rebuild them. That is how you will be mastering the Node.js stream. So that's it guys about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about the another concept in the Node.js, that is web streams. So this is same like streams concept only. If you try to see here, you'll be able to see about this web streams API, right? So what is this web streams API? So now we have learned about the streams API in the Node.js. Then what is this web streams API? What is the difference between these two? So is there any difference, or is these both are one and the same only? So before that, you need to understand one thing. What the streams, these are things which you are able to see. The streams are designed for only Node.js environment. If you understand carefully, these Node.js streams and also the web streams are two different implementations of the stream API, each designed for their respective environment. Node.js streams something like it will work for only the server side, and whereas the web APIs browser side, it will work the web streams. What happened is the Node.js streams and all those things solely developed in the using the C++ environment. Whereas if you want to learn, if you want to implement the same streams concept in the JavaScript, that means in the browser side, so we need to use the web streams API. So here you will be able to see about the WHATWG. So this is a standard organization which sets the rules for the JavaScript language. So the JavaScript language, when the Node.js has designed the streams concept, so the JavaScript they also implemented for this the web streams concept, so that the Node.js also is designed in the JavaScript, right? So that's why it is also using, it is similar to the Node.js streams, but emerged later and became the standard API for streaming across many JavaScript environment. So for many JavaScript environments, you'll be using the streams API concept. So fine. So the environment which you understood is that it will work in the Node.js side, streams API, and this works in the browser client side plus modern runtimes also. So the classes which we have in the Node.js streams are something like readable, writable, duplex, and transform we'll have. Here also we'll have it as a readable stream, writable stream, like that. The syntax for the Node.js stream is something like event based or class based, whereas for this web streams API it is a promised based. I will try to show you about this one. So it is all promised based, and back pressure it will be handling. So pipe, you will be having a pipe to option, and common usage will be fetch API, streaming API in browser, something like that you will be having. So if you want to learn about this one is web streams API. If you try to search in the Google web streams API, so the Mozilla documentation you will be able to see everything. Okay. So here you will be able to see the fetch from the network whenever you are trying to get the data from the network. So that it will process the data and it will send you the streams thing. So this is how you will be having the same thing, the same concept. You will have the same concept which you will be trying to implement it. So for example, let's say that the first concept which we will try to learn it is the readable stream. Okay, so we'll try to see the example, simple example of readable stream both in Node.js and web browser, so that you can see how they differ. First of all, we will create a readable stream from pushing the numbers 1 to 5 every second. So we'll try to implement that one. So here I will be creating in web stream, and in this one I will try to create a new file node readable, okay, .js file. So this one is related to node. So for this one, what I want to do, so here we need to import the readable. So understand carefully, here we need to import the, so require of stream. So here I will be using the readable. So this is our readable, and if you want to implement means, so same you will be using the number stream, whatever the name you want, you can use it, extends the readable, and here you will be having a constructor. Okay, and you will be sending the super. So if you are getting the options means, then you need to send the options. If you want to send any options means, you can send the options. And here what I want to do is this dot current is equal to 1. So current number is equal to 1. That's it. Now whenever you are having a read function, so for implementing the read function you need to use the underscore read, not read directly. In underscore read, what I will try to do, so constant constant this dot constant number is equal to this dot current plus plus. Okay, so I will be trying to use the plus plus. So then if number greater than 5, then what we need to do, so if number is greater than 5 means, then I will push the null, this dot push of null. So that's it. So else if it is not there means, then I will try to do constant str is equal to, so num dot to string plus slash n. So whatever the thing you want, you can give with slash n. Just I will try to use slash n. Sorry, n. So fine. Now I will be pushing console.log, pushing. I will use the template literal concept, and here dollar of str dot trim. Just I was using like this, so there is no need to use, and I will be pushing this str. That's it. So this is our common read concept. Okay. So now here what I will try to do, here I will create a constant stream is equal to new number stream. We don't have any options. So here I can use stream dot pipe. So I can use directly the pipe, and what I want to do, so here I need to send it to the standard output. That's it. Standard means to the output. So now if I try to use this one, so cd web streams, and in this one node-readable.js. So here pushing one, so pushing 2, so here 1 2 3 4 5, we are able to see that to the process standard output. So if I remove this one, then you will be able to understand clearly. So here if I run this again, so here we are able to see 1 2 3 4 5. So we are pushing it like this. So fine, right? So now you are able to understand this one. So this is how we will be doing the thing. So here we extended the readable and override the read method. This dot push pushes the chunks. When done, we push null to signal end of the stream. we pipe it to the process.standard output, that is nothing but a console. So fine. So now you are understood about this readable, what I want to say is custom readable stream. So the same thing if I want to implement in the website, so how I can implement it. So let's try to go it here, and here I will create a file. So web-readable.html. So this is the browser side, right? So I will be creating HTML file, and here I will be using the HTML5. Okay, and here I will use something like div readable stream. The same thing if I want to implement it here means, so I can use a script concept, and in this script what I would be trying to do, so here first we need to create a readable stream. Okay, so here I will be creating something like constant number stream is equal to new readable. Okay, so we need to use the new readable stream. Okay, here you will be able to see, and we need to pass the options. So here in this one, so what you will be having is, okay, I am having script to show script. Okay, so what you will be having is, so here when you are trying to create a readable stream, so now here instead of having a constructor, you will be having a start method. Okay, and the start method will have a controller. Okay, so which define the stream. So now here I can use a count is equal to 1. Okay, I will be having a count. So here I will be running the set interval. So here I can use constant interval is equal to set interval. So for every 5 seconds I need to send the data, right? So here I will be using comma 1000 second. So for every second I will be sending the data. Fine. So here same thing, if count is greater than 5, then what I need to do it is I need to close it. So controller dot remove, not remove, close. Okay, we will be using the close, so it will close the stream. Else if it is not there means, then I can also clear the interval also. Clear interval of interval. Fine. So you know, else if it is not the case means, then what I need to do, so here I need to create the chunk. So let's say that chunk is nothing but constant chunk is equal to, so here I will be having a dollar of count. Okay, dollar of count, and what I will be trying to do here, slash n. I will use a slash n so that we can get it one by one down. So here I will be using the same thing, console.log push off like this. Okay, so pushing. Now here what I will be trying to do is controller dot enqueue. So here we will be using the enqueue. So it will push it, the chunk dot trim. So here whatever the chunk you are having, I am trying to push it, and at the last I will be doing the count plus. That's it. So now here, so we have implemented the thing. So whenever you are trying to push it means, so here you need to add enqueue, So whenever you want to finish this one means we need to use the controller.close. That's it. Now in order to use this reader, what you need to do is constant reader. Whenever you get a readable stream, so you need to get reader is equal to new number stream. So we got a number stream dot not reader, get reader. So you need to has get reader. So fine. So we got the reader. And what you can do it is, so here you can use a read stream. So here I can use async function read stream. So just I am using a method. I'll be calling the read stream here. Read stream. Okay, I'm calling this method in this one. So I can use something like while of true. Always I need to read this one same like event based. So here you will be having a constant. So you will be getting something like a done and also a value. Okay, and here I will be doing await reader dot read. So whenever it will try to read each chunk of data, and when you get it done as a false means another set of data is there. As soon as if you get the done as a true means, then you can break it out. So if done is coming means, then you can break it out. So if it is not there means, then again you need to loop over and it will call it. So here I will be doing the console.log. So here I can use something like received, and here I can use the value. That's it. Oh sorry. So dollar of value, I can use dollar of value. That's it, finish. Now you are calling the read stream. So this is the implementation of this one. So if you try to implement here, so let's run this one. So I am running this one here. If you go here into the console, so just I am consoling it one, right? So here you will be able to see the pushing and received, pushing and received. Pushing means nothing but the readable. So it is trying to push it here one by one. If you want, you can remove this one. So here I can get the streaming thing. So here if I try to click reset on this one, received 1, received 2, received 3, received 4. So like this stream of data we are able to receive it. So now here what we are trying to do, the code if you try to observe carefully, the same thing, the concept is one and the same only. So we create a readable stream with a start method, the controller.enqueue method to push the data. So we have used the text reader because stream data works with binary data. So we read using a render method. So that's it. So now if you try to understand the Nodejs and all those things, so in our Nodejs, for creation of this one, we have used the class number stream extends readable, but here we have created using a new readable stream. The difference. So when we want to try to push the data, here we will be using the this dot push of null or this dot push of str. We are pushing it, and here we are trying to push only the controller.enqueue. And if you want to end the stream means you need to close it. Here you need to push the null. And if you want to consume, so we need to use the pipe or dot on of data like this we need to use. But here if you want to consume the data means we need to use the promise based await this read. And encoding needed means so no buffer is native. And here if you want to encode it means, so for example let's say that here you are having this one. So if you want to send it to any pipe stream means, then what you need to do, so here we are writing, and so if you want to send this one to some other thing means, then what you need to do it is, so here we cannot pipe it to writable. Why? Because this is not encoded. So by default I am sending it here like this. So if you want to encode it means, then you need to send the encoded data, and here you need to decode it and you need to use it. So that is the main thing. So that's it guys about this concept. So hope you understood about this readable web streams. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. Today we are diving into readable web streams in the browser and how to stream data from a custom Node.js server without using the Express.js. I will try to use it. So we will implement a browser side fetch API that reads a stream chunk by chunk and build a custom backend that streams data using Node.js built-in HTTP and also stream module. Let's try to build this one step by step, and by the end you will be able to stream text like a pro. So normally what is a readable web stream? A readable web stream let you consume the data chunk by chunk as it arrives without waiting for the whole thing to download. It is perfect for streaming large text or JSON data, real-time data feeds, and reducing the memory usage in the browser. So we will fetch from a server that sends data slowly and display it live as it streams in. So let's try to create a simple server. So I will be creating here a server.js file. Okay. So let's try to create this one. So file server.js file. So here I am creating a simple thing, and in this one, so let's try to require http is equal to require of http, and we'll be and we need a readable. So readable is equal to require of stream. So fine, right? So this is what we will be having. So let's try to create a server. So these all things don't need to worry. So we will learn about this one also when we are learning the http. http.create server request of response, and here if request.url is equal to /stream, okay, then we need to do the logic. So here we need to implement the logic. Let's say that we will be having a words in such a way that constant words is equal to, so here I will be having hello subscribers, welcome to, okay, Leela web dev. So let's see that this is the data which we want to send it. So this is the words. Let's say these are the words which I need to send it to the stream. So fine. So I'll take let index is equal to 0. Okay. So here I am creating a stream server. So for this one, what I can do, constant readable is equal to new readable. So you can also use it like this also, new readable, and here I can use the read method. Okay. So this is also another way how we can implement it. Instead of class also you can do it like this also, not a problem. So here what I will try to do, if index is less than words dot length, okay, if it is less than means then I will try to take the constant words is equal to, so here constant word is equal to, so here I will take words of I++. So this is what it will happen is, so it will take the 0 value and it automatically will increment it. Okay. So now I++, or otherwise something like not I++, index++. So fine, index will be updated. Now what I will try to do here, I will try to push set timeout off, and here I will push after some time. That is nothing but this dot push off, this dot push, I will push the data, that is nothing but word, and that to 1 second. So for every second I will push it. So if index is large there means then I will push the null, this dot push off null. That's it. So this is our simple server. Okay. And here after pushing this one all, what I need to do, so here right, so readable is finished. So what I want to do here, so let's try to write response dot write head 200, and here we need to do content text slash string, and also here we need to use the transfer encoding, not binary, it's a chunked, okay. And the another one which I want to say to tell it is access, okay, access control error origin star. Yeah, so this is the data which I want to send it. So here I will try to push it to the enter, and this one also enter, and here I will try to close this one, and here also this one also I will try to do it. Yeah, so this is the write head, and now what I would be trying to do, so here I need to send the data. So we got a readable, and I would be trying to send it through pipe of res. So the response is nothing but our writable stream, right? So that's why I am writing that one. That's it. So if there is nothing is there means, so then for example let's say that if you are having nothing is there means, so that means if the URL is something else means, then what you will try to do, response dot write head of not content 404. Okay, so you can say whatever it may be you want to have. So just I will try to send it as in 404, and I will try to end the stream. So response dot end and not found. That's it. And here what I will be trying to do, so we got the server dot listen of port is nothing but here 3000, and console dot log, oh this one should be listen, here I will be trying to write console.log listening on the port. So this is our simple code which I am trying to write it. So now if I try to now let's try to, so we haven't used the just native Node.js, I have written it. We simulated a delay with set timeout to mimic the streaming, and we have used this transfer encoding chunk ensures that the browser knows knows to expect a stream. So now let's go to our browser file, that is nothing but fetch.html. So in this fetch.html, so what I would be writing, right? So we will be writing the code. So HTML, okay, and here I will be writing okay, there is no need to write here. So let's go here, write the script code. So here I will be writing, so just I will take h1 here, waiting for the stream, and let's try to write the script. Okay, so this is the script code which I will be trying to write it. So now here let's say we will be having let's say that we will be having a function. So just we'll create a function, async function stream the text. So this is the function, simple function. So let's try to take the response is equal to like this, and that is also stream, so it should be listen to the 3000. Okay, so we got the response. So this response, if you try to see it, so let's try to run this one. So here we are having this one, right? Node server.js file. So let's say stop it and cls node server.js file which is listening down the port 3000. Fine, and here we are having the response. So let's try to console.log of response. Okay, let's try to see the response, and if I try to run this one, run fetch.html. okay, so this is waiting for the stream. So here let's go to the console, and here if I try to refresh the page, enable, so what is this? Okay, I am not calling the stream text, right? So let's try to call the method stream text. Okay, let's see the output for this one. So if I try to see the output for this one, let's see the output for this one. So we are able to get the response. Okay, and the response.body, it is a readable stream. So fine, right? It's a readable stream. So now if you want to readable stream means, so how can you read this readable stream? By using the method that is nothing but getReader. So let's try to do this one. So here we got the response. So here constant reader is equal to response dot body dot getReader. Okay, so I would be getting the reader. So we got the reader. Now what I would be trying to do, so let's try to take the output also. Output is equal to document dot query selector of output. We got the output. So first time the output dot text content is equal to empty. So first I am removing this one. So now here while of true. So now when I am trying to inject, so here constant done. So you will be having two values, that is nothing but done comma value, and here I will be trying to await reader dot read. So let's try to check the console.log value, console.log value of value. So I will try to show you what could be this value. Okay, if done is there means just we need to break it. If done, then break. That's it. So let's see the output for this one. So if I try to refresh this page, so here we should be able to see it is coming as an unit 8 array. So we are getting the data as a unit 8 array, and it will break for some time. Okay, so this is the unit 8 array. So that means it is something like a binary data. Okay, hexadecimal representation of this binary data. So what I mean to do unit 8 array, so we need to decode this one. So for this we decode in our thing, what I will be trying to do it is, so here I will be using constant decoder, new text decoder. I can use the new text decoder, and we got the value. Okay, so we got the value, and here I can write in such a way that output dot text content plus is equal to, so I need to add it. So here decoder dot decode, so it by, or otherwise you can also use the decode stream. So we also have another method that is nothing but decode stream. So we don't have this one. Okay, fine. So decode stream, decode of value, and also I can use the option something like stream true, so that it is expecting the stream. That's it. So then afterwards So when this one is completed, so when this while everything is completed, then I will try to tell stream is complete. Fine. Let's see the output for this one. So if I try to show you the output for this one, let's refresh this page. And here if you try to see hello, so here you will be able to see hello subscribers, welcome to Leela Webdo, and the stream is complete. So if I try to refresh this page again, so the streaming is coming. So like this you will be able to get one by one the data. So response.body.getReader gives us access to the stream. We decode each chunk and update the UI live. The user sees data as it arrives word by word. So that is the thing. So when you run this node server and all those things, so you'll be able to see it. So before wrapping up, just a few lines of code we have implemented a native streaming Nodejs server. We have used the web streams and the fetch API. Okay, fetch API to consume the data in real time and delivered a responsive user experience. So that is the thing how we will be doing the Nodejs. So here we are creating just a simple API which is streaming the data, and here we are trying to get the streamed data. That's it guys. If you liked this, don't forget to hit like, subscribe and share the video. So if you have got any questions, drop them in the comments below. Thanks for watching and see you in the next one. Hey everyone, welcome back to the channel. In today's video, we are diving into a writable web streams, a powerful feature of the web streams API. If you ever wondered how browsers handle writing large chunks of data efficiently, say saving files or sending data over the network, writable streams are a big part of that one. So don't worry, I will be telling you a beginner friendly only if you are new. So we will break it down step by step and show you a clear example using real code in the browser. Let's jump in. So the first things first, what is a writable stream? So you will be having doubt. So what is a writable streams? Here I have the definition. In simple terms, so what can I tell you is, let's try to have a software. Yeah. So in simple terms, a writable streams lets you send data to a destination chunk by chunk. Think of it as writing like writing a book one page at a time. Each page is a chunk of data. The browser takes care of buffering and writing it efficiently. This is super useful for things like writing to files in some environments, sending large amounts of data to a server, streaming video or audio uploads. These are all the things. Now let's see how to create and use one of the things. So let's try to create it. So let's write a custom writable stream in the browser that logs each chunk to the console. So let's try to see it. So for creating this one, so what we'll try to do, so here I will be having an HTML, and in this one I will writing the script code. Okay. Here for creating a writable stream, so what we'll do, constant writable stream is equal to new writable stream, and here in this one, so we will be having start of controller. Okay, so we will be having a controller. So here console.log, let's say that writable stream started. So this is something like the basic one. Okay, so this is the thing. So writable stream start. Let's try to remove this one. Yeah. So the next one, which you will be able to see the write. So whatever the thing you will be getting here, you will be getting it as a chunk comma controller. So this is the thing which you will be getting, and here also you can able to see console.log. Okay, this one is an object, right? Comma. So here I can write console.log of here writing chunk. Okay, writing chunk. So if you want, you can also print the chunk also. It's not a problem. That's it. So we have another one that is nothing but close of controller. And in this one, what we will try to do, so here you can write console.log of. So here you can say stream closed. So stream closed. So when the stream is closed, you'll be able to see. And the last method which you'll be having is an about of controller. So this is the about, and here whenever any error occurs or something like that, so we will be having a reason for this one. Sorry, here you will be having a reason or error, let's say. So here you can say, so stream aborted, so the error you will try to paste it. That's it. So this is how you will be having. Let's break it down one by one. So here you will be able to see the start method, and what it will try to do, it runs when the stream is created. You can set things up here. And we are having next one is the write of chunk. It is called every time a chunk of data is written. And close method runs when writing is finished. About of reason means, so runs if something goes wrong. This stream doesn't actually store or send data anywhere, it just logs it, but you will see how we can use it with a writer. So now this is the stream implementation. So if you want to consume it, now let's try to create a writer and push data into our stream. So in order to create that one, so here what you need to do is constant writer is equal to, so here you can write writable stream dot write, get writer. Okay, so this writable stream is nothing but this one which we have created it. And here you will be having await writer dot write of hello, and here you can write, here it should be a writer, and here the next one you can write it as a writer dot write of world. Okay, you can use it like this, and at the last you need to do await writer dot close. That's it. So now here you will be able to see this one. So if I try to execute this one in our Chrome browser, so let's try to see in our Chrome browser. So if I inspect the element and if you try to see in the console, okay, we need to, everything is working fine, right? Let's try to see it here again. Await is only, okay, we need to have an await. So these are all the things we need to have it in an async self functioning, and here I will paste everything here in this one. That's it. So let's try to execute this code and we'll see it again. So writable stream start, and writable stream start. So here whenever I'm trying to write it, so get writer, okay, got it, and writable stream start. So here you'll be able to see stream start, and we are trying to write the chunk, and here console dot writing chunk, it should get it right. Await writer dot write of hello. So okay, so let's try to understand this one. So get writer gives us writer object where we can use to send the data, sends a chunk into the stream. So here writer dot write means sends a chunk into the stream. Writer dot close signals that we are done writing. Each call to write triggers the write method inside our stream where we can handle or transform the chunk. So now here if I try to show you the output for this one, okay, here is not a function, writable.html something, async of this one, constant writer. What is this happening here? Let's try to see it here. I have written correctly on, right? Okay. So is there anything that other thing which I have written it here? Let's try to see it again. Yeah, here you are able to see the same output. So here writing stream start, writing chunk hello, world and stream has been closed. So we'll be able to see the output this one. So let's try to see another more real scenario. So pretending that we are sending a JSON data to a server or saving it somewhere. So for this one what I will be trying to do it is, so here the same thing what I would be trying to do it is, so here I am having a writable stream, right? So here this one I will convert it into a JSON stream, okay, and writable stream. So I will not use the start of controller and all those things. So okay, if you want to keep it, you can keep it. So we are having a write of chunk. So here what I would be trying to do it is constant JSON is equal to JSON dot stringify of chunk, and I will try to do the console.log sending JSON, and I will try to print the JSON. That's it. So this is the chunk which I will be trying to do, and here I will create the same thing, but here this time I will try to write it in this scenario. So I am creating a JSON writer which is nothing but here JSON writer, okay, and get writer. So here I am sending one by one, and I am stringifying this one all. So if you try to see the output for this one, let's try to see the same output. See the same output, we are able to see it like this. So here we are taking an object, turning into JSON and logging it. In real world use cases, this is where you would send a network request and write it to a file stream using something like fetch or response or something like that. So that is how you will be trying to do it. In the same scenario, so same thing. So you will be having like this, the same thing only. So you can do whatever the things you want to do, you can do it. So like this you will be having. So now for example, let's say that you are consoling and all those things, right? So let's say that we are having a chunk of data. Okay, let's say that here I will be trying to have the same thing. Let's say that we are having a chunk of data. Okay, I am having chunk 1, chunk 2, chunk 3. Let's say that we are having this one as a writable stream. Okay, and here no, and just I will be trying to do only the chunk. Okay, and here we are having a chunk and I am looping over one by one chunk and I am sending these all the things, and at the last I am closing this chunk. Now if you try to see the output for this one, see, sending JSON chunk 1, chunk 2, chunk 3 and stream closed. So in the future, browsers APIs like fetch also might let you stream to a request body directly using the writable streams. Some environments like Dino already supports this one. So alright guys, let's recap this one. So writable web streams let you write data chunk by chunk. You define how to handle each chunk in the write method. Writers give you a control over when and how to send the data. Super useful for large or streaming data. No need to wait for everything at once. And that's it guys, that is how the writable web streams work. If this helped you understand it better, smash that like button and consider subscribing for more dev friendly videos like this one. Got questions? Drop them in the comments and I will answer them. Thanks for watching and I will see you in the next one. Hey everyone, welcome back to my channel. In today's video, we are diving into the world of transform web streams. The magical part of the web streams API that lets you process and transform data as it flows through a stream. So we look at this, how it works, go through some simple code and I will walk you through every single step. So by this you will be ready to build your own stream based transforms for the browser or server. So now let's try to see about this one. First of all, we will try to understand what is a transform stream. So what is this transform stream? So here let's try to open something. Let's open this one. Yeah. So what is this transform stream? Let's try to have it. Wrap the text. Okay. Yeah. So what is a transform stream? A transform stream is a part of the web streams API. It is like a pipe sitting between a readable stream and a writable stream that can transform chunks of data flowing through it. Think of it as like a coffee filter. You pour water and ground coffee on the top. That is your input. And you get filtered coffee out of the bottom, That's your transformed output. The filter is between your transform stream. So that's it guys. So just it's like as a middle layer so that it can transform the data and it will send it to the output. Normally transform stream takes three main components. So it will be having three main methods. So what are those methods is, first one is the transform. And the argument for this one is chunk and the controller. So this is a required one. This is where the actual transformation happens. It is called for each chunk from the input stream. And the second one is the flush and takes the argument of controller, which is an optional one. This is called at the end of the stream, useful for final processing or cleanup. And the last one is the start controller. So it is something like a constructor called once when the stream is created. You can use this setting to things up or to start the bootstrap everything. The controller lets you enqueue transformed data or signal errors. So let's walk through a simple real world example. Let's say that whatever the text coming from a stream, so we need to convert it into an uppercase. So let's try to see it. So I am removing this one all. So here I will be creating a new file, that is nothing but file. Let's go here. I will be creating a file here. Why it is not creating file? Yeah, here file transform. Okay, transform.js file. Otherwise it will be transform.html file also, we can have it. So it is a web stream all right. So now okay, let's go here HTML. So HTML5, okay, and here I will be writing the script. So this is the script, and here I will be having constant uppercase transform is equal to uppercase transform is equal to new transform stream new transform stream of. So here you need to have a transform method. So you can have a start controller. So start controller and console.log stream started. So you can have something like stream started. The next one you will be having is the, so this one is an object, right? Yeah, here you will be having a transform of, you will be having chunk and also a controller. So these are the two things which you will be having. Now here you need to convert the chunk tree. So here you can say that constant upper is equal to chunk dot to upper case, and you can have controller dot enq, so enq, and you need to pass the upper, so the transformed thing you need to pass it. That's it. So at the end you will be having a flush. That is nothing but when it is finished you will be having it. So flush of controller, and here you can have, sorry, console.log stream ended. So you can have whatever the information you want to have, you can have it. That's it. So this is our transform stream. Now let's create a readable stream. Constant readable is equal to new readable stream, and here you will be having a read method or start method. So let's say that we will be having a start method. Let's say in the start, when the readable stream is starting, controller, okay, I will try to send the controller dot enq of not upper. So here I will send hello and world, okay, and the last one is close. So I will be closing the controller. That's it. Okay, so this is our readable stream. So now let's try to create a writable stream also. Constant writable is equal to new writable stream, sorry, writable stream of write of chunk, and you will be writing console.log output, it's a chunk. Okay, so just I am consoling the chunk, that's it. So new writable stream, that's it. So now we got the writable stream. So here what we need to do, so here we need to get the readable stream, and I need to pipe it through the transform stream, uppercase transform, and I need to pipe to the writable stream, that is nothing but writable. Okay, that's it. Pipe to writable, that's it. Now let's try to see the output for this one. So if I try to see the output, let me show you the output. I am opening here, and if I try to show you the inspect element, and if I go to the console, you will be able to see stream started, output hello, output world, and also stream ended. So you will be able to see the hello and world is in the uppercase letter. So let's try to break this down a bit. So we have defined a transform stream here. The uppercase, this uppercase is every chunk. We are having a start of controller, runs once and logs that the stream has been started. And the next method is transform of chunk comma controller. This is where the magic happens. Every chunk is turned into uppercase and pushed forward to the controller using a controller.enq. Flush of controller, so this will be executed, is called when the stream is done, and we log a final message. Then we create a readable stream that will emits hello and world. Finally we make a writable stream that logs whatever it receives, and we are using a pipe through, we connect through the transformer then to the writable. So that is the way. The output will be something like this one. So if you try to see the output will be like this. So this is all about how we will be using the transform stream. Sometimes you need to work with the binary data or encoded text. So that is where the text encoder stream and the text decoder stream comes in handy. So these are the built-in transform streams available in the WebStreams API. Here is a quick demo, so just which I want to show you. So here I will try to show you. So now here let's say that so we are having uppercase stream, right? So the default one which you will be having is the constant encoder is equal to, sorry, encoder is equal to new text encoder stream. Okay, so this is the encoder stream which you will be having, and constant decoder is equal to new text decoder stream. So these are the two streams, transform streams, which you will be having. So for example, you are having hello world and you want to pass it through the this one means, so here you can pass it through an encoder, okay, and pipe it to the writable. So now let's see what will happen to this one. So if you try to see the output for this one, see here it has been encoded, okay. So now if you want to decode this one means, so what you will try to do, again you will add a pipe through. So pipe through of decoder. So you will use the decoder. Then what will happen here? Decoder, that's it, decoder only. So now if you try to see, again the output will be same thing only. So like this we will be using our encoder and decoder stream. So where we can use these transform streams? You can use transform streams in Fetch API for streaming the large responses, browser based file processing, encoding, decoding text and binary data, building pipelines like compression, filtering, encryption, etc. Transform streams are incredibly powerful and efficient when dealing with larger streaming data. So that's it guys about this one. Everything you need, and that's everything you need to know about to get started with the transform web streams. If you enjoyed this breakdown, give it a thumbs up, subscribe for more dev content, and let me know in the comments what kind of stream you want to build with this. Until next time, happy coding. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So we are learning about the new concept, that is nothing but networking. So before we dive into the networking concept, so we'll try to learn a lot of things in the networking thing. So in our previous series, we have completed the streams concept. We have learned about the readable streams, writable streams, transform streams, and also the duplex streams. We have seen it. So this is very much important. The streams concept is very much important, as long as every backend language or the programming language, they have a support. But according to me, Nodejs has a efficient support for these streams. So if you go for Java, everything, you go Python, .NET, everything. So they have a support, but Node.js, as far as I know, it has a wonderful efficient way of handling the streams concept. So fine, so we have completed the streams concept. Let's dive into the next concept, that is nothing but the networking. So why? Because we need to develop, finally we need to develop the network apps, that is nothing but the HTTP and all those things. So before learning about this HTTP and all those things, we need to understand about the transport layer. So transport layer means, I want to say, is network layer, okay. So the total network layer, we need to understand it. So without understanding this network layer and all those things, we cannot develop a network applications. So before we dive into the Node.js code and all those things, so we need to learn about the network apps. In this series, what we'll try to learn is, we'll be learning as far as a low level where we can handle the networking using the Node.js. Okay, the low level we'll try to do it. Apart from this low level, we cannot handle that net layer using the Node.js. Up the low level, from low level onwards up to the HTTP and all those things. So as far as I know, the HTTP or the SSH, FTP, even the email protocols. So whatever the protocols we are having, the protocols and everything, so will be operated on the top of this layer only, which we are trying to learn this layer. What is nothing but the TCP layer, which I would be trying to do, UDP layer or TCP layer. We will try to learn about these all the things. Okay, so we'll start building our cool networking apps also. So let's take a few minutes to understand some core concepts about the computer science and also the network concepts. Why? Because if you have a clear understanding about this one, then only you can able to understand about the networking applications. So how the computers and the internet IP address, what is an IPv4 address, IPv6 address, what is a MAC address. So these are all the things, if you have a clear understanding only, then only we can able to understand the network, we can able to develop the networking applications. So trust me, I will make you things way easier down the line. So just we'll try to understand the network first. So if you are already aware of this IP address, router, switches and all those things, so you can comfortably skip this video. So just we'll try to learn about this, understanding the network. Let's travel back 20 years back. Okay, so how the computers or how the software will be. So 20 years back, if you travel back 20 or maybe 30 years ago, something like that, imagine you have a computer. Okay, you have a computer, and your computer and your co-worker is something around John or Liam or anyone. So okay, let's say that here you are having a co-worker. Okay, so this is one system. Let's say that this is one system and this is another system, that is nothing but your system. Okay, let's say you. So this is the two systems. Now what you will want to do, so let's say that you want to share a file to this system. Okay, so you want to share a file to this system. So how you will share a file? Remember, you are trying to do it in a 20 to 30 years ago. So what we'll try to do in 20 30 years ago, so these two are disconnected computers. Okay, these are not connected. Okay, so these two are disconnected, so these two are not connected anymore. So what will happen is, at that time 20 or 30 years ago, so maybe the people who are learning right now, maybe they were aware of or not, I don't know. So we used to have a floppy disk. Okay, so we used to have a floppy disk like this. So it will have around 1.44 MB, maybe I may be wrong or something like that. The storage capacity of this floppy disk is around 1.44 MB or something like that. At the time when I was studying, so I rarely saw this floppy disk which is having 1.44 MB. We used to carry C programming languages in this floppy disk. So fine. So these two disconnect, what we'll try to do, user will insert a floppy disk drive here. He will copy the file everything and he will take that copy floppy disk drive to way to this computer, and he will insert the same floppy disk drive and he will copy, inserting it one another. So here, back then you couldn't just click send. There are no cables, no networking cards, nothing. The only way is physically, that is nothing but floppy disk, or somewhere now you people will be aware of CD drives or USB drives. So like this we used to have like this. Okay. Imagine this system is somewhere, it is in Europe. Okay, so this is in somewhere it is in Europe and this is in somewhere it is in US, let's say. Okay, now I want to share a file from this system or from this computer to this computer. Remember, 20 to 30 years ago both are disconnected computers. So what we need to do, same process, we need to copy the same thing, the floppy drive in this system, and we need to go by flight or any transport we need to do. So we need to go to the Europe and we need to insert the floppy disk here, or somewhere we need to make the floppy disk to travel to the Europe. Okay, through the transport or anything, and we need to do it. Okay, so probably we need a plane ticket. That's it. We don't have anything, or otherwise you need to keep it in a cargo. So that is the way which we will be doing it in 20 to 30 years ago. So you imagine that if you want to share a file between two computers means, so we need to have a physical. That's it. So now let's come to now this case. Thankfully that there is no case anymore right now. So now we have a networking hardware, Ethernet, cable, switches, routers and more. So these are all the things we are having right now. So Ethernet, cable, switches, routers and more we are having it, right? But what are those all things? How do these work? Okay, let's try to see this one. So for example, let's say that you are working. So now let's go to the back to the original one. So I removed everything. So let's say that you are working in a same company. Okay, so here I am having a system and your friend is having another system. Okay, and 4 members are there sitting here. Okay, let's say that we are having a 4 members systems are there. Now what we would be having it is, now I want to share, so A, B, C and D. Okay, so these are the 4 systems which you will be having. Now I want to share the data from this file to something B system. So I want to share the file, means what we need to do, so normally we used to carry a floppy disk or CD or USB drive or anything, but that is not the case. So right now what we will be trying to do it is, we will be having a switch, so you will be able to see the switch also. So if you try to understand about the switch concept, I will try to explain you. So how the switch will look like is, in the images if you try to see in the switch networking, so it will look like a Cisco switch, something like box here it will be. Okay, so here this switch will look like something like 2 to 3 inches or something like that. So this is the switch which you will be having, and here you will be able to see we are having some sockets. So this is nothing but an RJ45 cable, it will fix it. So this is called as an Ethernet cable. So now what we'll try to do it is, let's go to our paint. Okay, now here we are having a switch will have a boxes that sockets like this. Now we will connect this switch to this one, and this socket to here, and this socket to here, and like this we will be connecting to this one. Okay, so this system we will be connecting all the 4 computers to this switch. Now this switch will act as a bridge between these 4 things, and here for connecting this one we need to have a Ethernet cable. So you people already aware of this Ethernet cable, so the present day people, and these all the Ethernet cable it will connect to each system. It will go to the central device called a switch. Okay, so here it will be having. Now here what I want to tell you is, a switch is like a traffic controller. It takes the data you send, figures out where it needs to go and sends it to there. So here whatever the data you want to send it from A, so you will be sending it to the switch, and it will figure out how you need to send the data, and it will send it to the particular device. So how this computer will be able to connect this one. So you need to understand. Here you are having this type of socket, right? The same type of socket also you will be having here in this computer also. So where you will be having this one? So for this computer, so we will be having a separate hardware called as a network card. Okay, so if you are able to understand this one, so it is a separate hardware. So this is a network card. So this will be fixed to the motherboard of your thing. So previously in our olden days we don't have this network card, so that means it is a disconnected computer. Now the network card will be there. That is nothing but called as a network interface card, or NIC. We will say it as an NIC. And this NIC network card will be attached to each of the computers. So hardware will be there. Previously, nowadays the laptops you are having it, right? It will come with a default network card. Previously, when we used to assemble the desktop PCs or something like this, we need to purchase manually the network interface card, and we need to attach to that one to the hardware. So now, whenever you purchase a network interface card, so each network interface card will be having a unique ID. Okay, it will be having a unique ID. So that means every system has a network card, and this network card and this system will have a unique ID. Okay, unique ID. So no two computers in the world will have the same IDs. So it will have a unique ID. So it will have a different unique ID. So that unique ID is called as a MAC address. Okay, so now you need to understand about this MAC address. So the MAC address doesn't belong to the system, it belongs to the network interface card. So the network interface card will have a unique ID that is called as a MAC address. Each computer displays a different MAC address. Think of a MAC address is like a digital fingerprint. No two are the same, and it helps the switch to know which computer is which. So here the switch will able to understand which computer is which. So that is the thing. So each computer will have a unique ID. This is called as a MAC address. So that is one thing. So let's say that you want to send a file from A to the B or on the same network. Now the computer, so here you want to send a file from A to the C, let's assume. Now what you will try to do, you need to send a data. So here you will send a packet. Okay, you need to understand here also. So we will try to discuss about this packet. So this one you will send it as a packet. Now packet will contain something like source. Okay, it will contain a source, it will contain a destination, and it will contain a data. Okay, the source will contain the MAC address, and the destination will contain the MAC address, and the data will contain 0 1s or some binary data it will contain. So the MAC address will be a hexadecimal digit, something like a 12-digit number you will be having. I didn't remember exactly. It's an hexadecimal. In written, hexadecimal means nothing but it's a binary data only. It is a representation of zeros and ones. So that is one thing. Now your computer sends that packet to the switch. So this packet is nothing but a combination of key value pair. It will be having a source, destination, and a data. So the computer sends that packet to the switch. The switch checks the destination MAC address. So to which destination I want to send it, it will check the destination MAC address, figures out which computer it belongs to, and forwards that packet to there. Switch reading the MAC, finding the correct port, and sending the packet. So that is the main thing it will have. And just like the computer C, the C computer gets the data fast, efficient, no floppy disk, no walking, something like that. Okay. So this setup, computer cables, a switch, and a MAC address is the basic building block of the what I want to say is modern networks. So all you need to is here to communicate with the NIC, network interface card, plus cable, plus switch, plus MAC address. That's it. So now here, and once you understand this one, things like TCP, IP address, routers, and the internet as a whole will start making a lot more sense to you. So here this is what the communication will be having within the same network, if you are having, or in the same building if you are there, if you are connected to the switch means, then you will be able to do with the MAC address. In the next video what we will try to do is, we will take this foundational knowledge and use it to build a real network applications using Node.js. So we'll try to do it. So hope you understood about this concept. So now here, if you are ready, hit the like button, subscribe, and let's keep building the network applications. Thank you. Hey everyone, welcome to my channel Leela Web Dev. Have you ever wondered how you can send a message to someone across the world in just seconds? Or how streaming a video from Europe while sitting in Canada actually works? Well, today we are breaking down exactly how the internet works. From your local Wi-Fi all the way to those deep sea cables that span entire the oceans. So let's jump in. So let's start with the first onwards. Okay, let's start small. Imagine you have a couple of computers. Okay, so you are having a couple of computers. Here one computer you're having. So the oval shape, think it is a computer, and here you are having another computer. Okay, so this is a couple of computers, and it is connected to each other using Ethernet cable. So that means directly from this network card, Ethernet cable has been connected to this Ethernet card. This forms a basic network. Okay, now it can transfer the zeros and ones binary data across the two systems. Now what if you want to connect even more computers? So if you are having couple of computers, means say in a classroom or in an office. So if you want to connect to multiple computers like this, so if you are having computers like this means, so then what you will be having? Okay, so 4 or 5 computers you are having, so then what you will try to do? So it will be having only one internet cable, right? One Ethernet cable, right? So then we will be using the switch. So every switch will be connected to this one. Okay, and whatever the thing you want to send the data, so it will be sent across the switch. A switch helps manage traffic between multiple computers on the same local network. So this is the main thing. It sends data only where it needs to go based on something called MAC address. This is all the concept which we have discussed in our previous video. So using the MAC address, it will try to send you the net data, whatever the data, but the computers all should be available in the same local network. Fine. So this is fine. All right. Now think bigger. So this is something like, okay, fine. Now think bigger. Let's have another group of computers in another room, building, or even in another city. Let's say that here you are in US, okay, and you are having the multiple computers like this. Let's say that here you are having multiple computers like this, and this is connected to a switch. Let's example, okay, and this is one box. This is one building, okay, this is one office. Let's say this is present in US. And here in Europe or anywhere somewhere you are having another office, and here also you will be having the same computers like this, and this one is also connected to a switch. All the computers are connected to a switch. Now whatever the computer you want to send the data, you can send it to only to your local network only. But now I want to send from this computer, okay, to data to the other computer present in the US. Then how you will try to do it? So that means, let's say we have another group of computers in another room or building or even another city. So that's now it's a separate network. Now it is not a local network. So this is a separate network and this is a separate network. But what if we want these networks to talk each other? So these two networks, if we want to talk each other means, then what you will try to do? You might think, let just use more switches and cables. You can think it like, but wait, imagine try to connect millions of computers directly with cables. Okay, so here millions of computers are there directly with the cables. That's just not practical. It could be messy, unmanageable, and pretty much impossible. So we add a new layer that is nothing but router. Routers sit on the top of, so this one is a switch. Okay, so router sits on the top of the switch. Router sit on the top of the switches. So this one is a router. Okay, and here also switch is there. So here the router will sit. So this is the switch, and the router will be connected to the switch. So this is the router. So they connect multiple networks together. So here the router will be connected to this router. That's it. While switches work with MAC addresses, so the switches all will work with the MAC address. So the switches all work with the MAC address, but the router work with the IP address. We'll try to learn about this IP address more in our upcoming videos. Just try to understand. So each router will be assigned with a IP address. Think of it is like a digital home address for devices. Okay. each device, whether it is a phone, laptop or a server, you will get a unique IP address. So here each one router, it will assign a unique IP address. Let's say 12.0.0.1, 12.0.0.2, 12.0.0.3, like this, everything the IP address will be assigned. So what is this IP address? Think of this IP address like your home address. For example, let's say that you are staying in Toronto, 200 Adelaide Street, Unit 5. No one else in the world has that exact same address, right? Same with the IP address. An IP address might look like something like 192.168.0.1. The first part of the IP address. So here the first part of the IP address is like the city name, identifies the network. So to which network? So here the network will start with 192.168. Here the network ID, let's say that it will start with something around 18.16.0.0. okay, let's say. So I'm trying to tell you. So the first two letters, 18.16 or 192.168, represents the city name, identifies the network. So let's say that identifies the network. And the last part, so whatever you are having, 0.1, 0.2, 0.3, this all identifies the specific device inside that network. So that is the main thing. So computers in the same network will have similar prefixes in their IP addresses. So that is main thing. So now routers don't just connect networks, they also assign IP address to the devices in their network. So here not only the router will not connect to another router, it will also assign an IP address to each device in the same network. So it will assign an IP address in the net, and they know how to route data between the networks, and also the router knows how to route the data between the networks. So now a computer in one network can talk to a computer in another network just by knowing its IP address. So this is the main concept what router will try to do it. When one computer wants to talk to another, so here when one computer, so here let's say that here one computer, so where is it? Here one computer wants to talk to another computer, means it will send the zeros and ones over the network. Those bits can represent anything. So just the network internet means nothing but it is a transfer of zeros and ones only. So don't think that it will be transferring some data or something like that. So the data is nothing but zeros and ones only, which we have learned in our buffer or the streams concept. The bits can represent anything, text message, video, images, video calls, website data, you name it, whatever. It will be transferred in just zeros and ones. That is the thing. So imagine millions of this network in around the world. So here this is one network and this is another network, and you will be having millions of networks around the world, all connected together using the routers and switches and cables and something like that. Means this massive system is called as an internet. So in simple way thing, what we can say it is an internet. Internet is nothing but the connection of over the networks, over the millions of devices, connection over the network using a specific IP address, and transferring the data. That is, data is nothing but the bits, zeros and ones over the network is nothing but an internet. Okay, but wait, there is also one more thing which I want to tell you. When you send a data to an IP address, you also need to specify a port number also. We will discuss about this port number. A port is nothing but for a computer. Okay, a port is nothing but a computer. It's like a specific door or a window in a house where different kinds of data will go. For example, port 80 or 443 means it is for websites. Port 22 means it is for SSH. Port 3000 means it is for custom apps. So the IP address is the house address, and the port is nothing but you can say it as a room number. Okay, that is the thing. Now how do you, sitting at a home with a new phone or laptop, get connected to the internet? That is where ISPs will come. So for example, let's say that you have purchased a new computer or a new phone, and I want to connect over the network here. This like this over the network, if you want to connect means, then you will get the what I want to say is ISP. So this buying a specific IP address. So this IP address which I have shown you, right, 192.168 or 10 dot something like that. So that one you need to purchase it with the companies called as an ISPs, like Comcast, Bell or Rogers. So some different types of companies are there where you can buy an IP address. If you buy an IP address means then your system is connected to over the network, so that you can send data across the world. Billions of computers will be connected, and you can communicate with the billions of computers in the world. The router connects you to the ISP, which connects you to the entire internet. So that is the thing. Here is the crazy part which I want to tell you before closing of this one. So now we are saying that the massive global network is all physically connected, right? So you may be thinking that over the cloud like this, right? The systems are connected over the cloud, but that is not the correct scenario. These are literally these all communication over the network and all those things. Literally there are cables running under the oceans from North America to Europe to Africa, Asia and Australia, something like that. So for example, if you are doing a FaceTiming to a friend in the France from California, means your voice is converted into bits and it is literally traveling under the ocean through a fiber optic cables. So that is the thing. It might sounds unbelievable, but it is true. You can even search for maps of undersea internet cables. It's wild. I will try to show you. Let's see. So here, if I try to open here, so internet cables under ocean. If you try to search it here, so here you will be able to see different types of images here. You will be able to see. So these are the cables which is connected under, which is traveling through under the ocean, and here you may be able to see the images also. So here you will be able to see the images. If I try to show you here, see, people think that the data is in the cloud, but it is not. It is in the ocean. See, these are all the cables that has been connected. So here it is showing from the year onwards, 2020 up to 2021, it has been connected like this. So all over the world in the ocean there is a long cables that are running. So now when you have a system in India or in Africa or something like that, so now you need to purchase an IP address, and this IP address is connected to the cable through this cable, and now you can communicate to entire world. That is the thing. You might be thinking I am on Wi-Fi or 5G. You might be thinking that I am on Wi-Fi or 5G, that is wireless. True, but only locally it is wireless. But your phone connects to a wireless, to a router or a cell tower, which then connects to a cables that are part of the wired internet architecture. So there is the main thing which so most of the people doesn't know that we are operating in wirelessly over all the satellites or something like that. You people may be thinking, but the internet is not working like that. It is all traveling through the oceans. Okay, so how the internet really works, let's try to have a recap. Devices connect to the local networks using internet or Wi-Fi. Switches manage traffic within the local network using MAC addresses. Routers connect different networks using IP addresses. Devices communicate using IP addresses and ports. All of this connects globally through the ISPs and undersea cables, and that's how you are watching this video right now. So that is the thing. So this is what all the things is happening. Now if you are watching this video in the YouTube right now, means this is all through the undersea cables and all those things only. And that's it guys. That is how the internet works, from your device to the entire planet, using switches, routers, IP address and miles of cables under the ocean. If this blew your mind or helped you understand the internet better, smash the like button, subscribe for more tech breakdowns, and let me know in the comments what you would like to learn the next. Thanks for watching. I will see you in the next one. Hi everyone, welcome back to my channel Leela Web Dev. In today's video, we are diving into a super important topic in the computer networking, that is nothing but networking layers. So when you are in the computer science engineering, when you are trying to learn it, you have heard about these network layers, right? So how computers communicate with each other, we have seen it, whether through your home Wi-Fi or across the internet, anywhere. So you have seen this one. Let's break it down step by step, starting from the very basics. So before jumping into the layers, let's answer the most basic question. So what is a networking? What is a networking? Networking is simply a way for computers to communicate. That's it. So you can have a global network like the internet, or a small private one at home between your laptop and phone. For example, let's say that I have connected my MacBook and iPad to the same router. They form a private network. If you are not in my network, you can't access my devices. So that's networking in simple terms, connecting machines so that they exchange the data. Now let's talk about how this connection is organized using the layers. So networking layers is the big picture. So when we talk about networking, we often hear about layers like physical layer, data link layer, network layer, transport layer, and also the application layer. What do these actually mean? These layers help us break down the complex process of moving data from one device to another. Each layer has a specific job and they work together to make communication possible. So let's walk through one by one from bottom to top. The first one is the physical layer. So if you try to observe here, so this is the box. Here you will be having the physical layer. So first one is the physical layer. Physical layer. So first one is physical layer. So what does this physical layer? At the very bottom you will be having a physical layer. This is the layer where it will be dealing with the Ethernet cables. Okay. So here it will Ethernet cables or signals, electric pulses. So whatever the things you will be having, so this all deal by this one. So something like a light in fiber cables. Okay, so it's all deals with the data. Actually you can say it as in, it all deals with the data. Data means here is nothing but zeros and ones. That's it. A physical layer doesn't understand what the data means, just its only job is to send and receive bits. So that means if a light is there means then it is a 1, if there is no light means then it is 0. That's it. So if you are connecting an Ethernet cable to your internet or something like that, so you will be able to see some light will be glowing, right? So that is nothing but if the light is there means 0 and it is 1. If there is no light means 0. If there is a light in the fiber optic cable means it could mean 1. And this happens super fast. For instance, Cat8 Ethernet cable can transform 1 billion bits per second. That is nothing but 1 GB of data per second. So that means it communicates or it transfers 1 billion bits per second through the cable. But the physical layer doesn't care about the IP address or devices. It just moves the bits. So it doesn't care about the destination, source or anything. Just its thing is to transfer the bits. That is nothing but zeros and ones. This is all about the physical layer. Next one comes is the data link layer. Okay, so next one comes is the at the top it is data link layer. So this is also important one. So just I want to try to explain you. Let me write this one. So it's a data link layer. This is where the switches come into play. Okay, switches, if switches come into play means then that is nothing but MAC address. So here you will be having all the MAC address and all those things will be taken care of this one. So here you will be having the MAC address. Here it was happens, it takes those raw zeros and ones. So these all zeros and ones it will be taken here and packages them into something called a frame. So here all the zeros and ones and all those things it will be packaged into a, it is called as a frame. So we call this one as a frame. Okay, so the data link layer, the data which we are having, it the zeros and ones and all those things it packages and frame, and it will add a MAC address to this frame. So here for this frame a MAC address, so that means the MAC address for the source and destination. So it will add the source and destination of the MAC addresses. So if my laptop wants to send data to my printer means the switch looks at the destination of the MAC address, then sends the data to the right device via the physical layer. So via the physical layer, the data link layer sends the data. That's it. So this is about the data link layer. So what first happens? So this physical layer, it will have only the zeros and ones and whatever the data you are having, it will have only the data. And the next goes to the data link layer, and the data link layer nothing but it is dealing with the switches. So the entire zeros and ones, whatever the zeros and ones you are having, it will package them into a frame and add the MAC address, source and destination MAC address to that frame. That's it. So the data link layer organizes data for local delivery and helps devices on the same network talk to each other. Up to here. So fine, up to here it is finished. So then comes the network layer. So here up to here, if you are in the local private network means, so then this one will be sufficient. But if you are trying to transfer across the networks means, then you need to have a network layer. So at the top you will be having another one that is nothing but network layer. Okay, so this is the network layer. So in this network layer you will get the IP address and the routing. Above that, so above the data link layer we have a network layer, and this is where the things start scaling up. So we are no longer limited to one small network. So the network layer includes IP address. So here in this one you will be having IP, router and packets. So here the data you will be having it as called as a packet. Okay, so here we will be having is in packet. Okay, so this here we will be calling it as a frame, and here we call it as in packet, and here we call it as in data. In this layer we call the same data, same thing as a data, and when it comes to the data link layer, so it will call it as in frame, and in this one we call it as in packet. Now let's say that you are sending data from San Francisco to Toronto. The routers in between them read the destination IP, route the packet from one point to another, until it gets to the final destination. So this layer answers how do you get from here to there, means even if 5000 miles away, it will try to send you. So there, this is the thing. So here you will be having IP address and routers and all those things you will be having. The next one is the transport layer. So the next layer what you will be having is the transport layer. Okay, so this one is the transport layer. So that the top of this one is the transport layer. So now that you are moving data between the days, so now when you get the network layer, so you are moving data from one device to another device across the world. So now the data we are transferring it. So this layer ensures that the data gets there correctly or not. Okay. So in order and without loss. For example, you have sent the data from San Francisco to Toronto. You want to know that whether it has been reached or not. So this is where the transport layer comes. So usually here we call data here as segments. So here up to here we call the packet, right? Here we call it as in segments. The data is called as a segment here. Okay. And the main protocols you here is the TCP and the UDP. The protocols here we will be using is the TCP and the UDP. So if the segment gets lost, somewhere when you are transporting, means TCP will detect and will request it again. UDP won't detect that if the data is lost or not. It just sends and forgets. That's it. So the transport layer gives us connection reliability. So the DCP connection, what it will try to do it is, so when we are trying to send the request, so it requires an acknowledgement whether the data has been transferred to the destination or not. If it doesn't transfer to the destination, means then it will try to transport the same packet again. So that's why TCP connection is more reliable, whereas an UDP protocol, what it will try to do is it will send and forget. So it will send the data whether it has reached the destination or not, it will not care. So it will send another packet again. If the data is lost in the middle, means it will be lost. That's it. So UDP we will mainly be using in the streaming, video streaming or something like that. TCP means we will be using in the websites and all those things we will be using it. So we'll try to learn about these all the things upcoming. Just this is the transport layer. The next comes is the main complex one, that is nothing but an application layer. Okay, so this is one is the application layer. So now this is the main thing which we need to care about as a software engineer. So you need to care about here. This is the thing. Finally, we have the application layer. This is where you as a software or a Node.js developer actually work. At this layer, we build HTTP servers like websites, email applications SMTP, file transfer servers like FTP, SSH servers and more.